Hey, it's Adam and Brent, and we wanted to let you know that if you're looking for more live or on-demand container content, you should subscribe to our YouTube channel.
Head on over to youtube.com/containersfromthecouch and also check out our website at containersfromthecouch.com. Thanks.
Thank you. Good?
Yeah, I think that
You
was
feel good
good.
about it?
Yeah,
All right.
feel pretty good.
I'm going to end the broadcast.
How's it going, Adam?
Hey.
I was a little delayed on that one.
Fancy meeting you here.
I just happened to be here on the couch and I see you. This is great.
I was in the mood for some coffee, and now that I'm looking at it, I don't have any coffee. I need coffee. This is how bad today's going. But so what are we all doing here?
I got something else to boost your energy. All right. We got a new service launch and it's super exciting. Okay. People love containers. Obviously the show is doing great. Everyone loves learning from us.
I love containers.
I know they're awesome. It's just a great packaging format for anything you want. And we at Amazon have a new service to run them just fully managed. Just give me a container, you can run it, and it's amazing.
This is something that I've heard from customers throughout the years is, okay, it's great. You have ECS. That helps me orchestrate a whole bunch of containers that all need to talk to each other. And then, of course, we came along and we created EKS because, customers want the open source Kubernetes experience in a managed form. But I still often hear from customers, I just want to run my container. Just let me just give you my container and you run it. And I don't want to have to think about anything else. So are you telling me we can do that now?
We can. Let me show you. All right.
Wow.
We'll show you. Let's deploy simple container here, web service on this. Just takes a few minutes.
All right. Show me.
All right.
Educate me.
Here's App Runner. App Runner is the new service. It is,
I like that.
give us a container or give us a source code repo, right? Some people already have the containers. We're going to build it for them. Some people just say, you know what, here's my repo of code. Please just build it for me and then host it. And
that's nice. You don't even have to know how to build a container.
Yeah. And we'll walk through the pre-built container. The blog post here for the launch blog will also show you how to hook up a GitHub repo and deploy from GitHub repo to URL.
Nice.
Fully managed.
Awesome.
So,
I can't wait.
Right here, create a service, just like anything else. We're going to say we have a container registry and we're going to use ECR public. We already have a demo app for you hosted here on ECR public. If you go into the gallery, it's under AWS containers and we call it Hello App Runner. Okay.
Nice.
Gives you some more usage, some more details about it. But we don't need to worry about it right now. We're just going to click the URL here for it and paste it right in.
I'm with you so far.
Yep. This is if I've lost you so far, we can go slower, but I just want to let's show you how easy this is. Okay.
So this is literally give me my container and run it.
Container image. We'll call it containers from the couch. Containers from the couch. Right. Let's just give it a service name.
Okay.
And then we just need to say what port. What port does my application expose? Where is it actually publishing some service on?
And I, as a developer, should know that already.
Yeah,
I would hope
so.
Yeah.
You're probably running it locally in dev or something, but you need to have some way to expose this because App Runner is all about running those web services for you. Just you bring us minimal knowledge as possible. So that's all we need. We have a container image, a name, and a port.
Okay.
We can change our CPU memory if we want. We can change auto scaling. We'll talk about that in just a second. Okay. Health checks, security, all that stuff. We're gonna click next here. Just a review on what we set up, and let's just say create and deploy.
Okay.
And it's going.
This is nice.
It's going to go. So all of that, like I don't want to say the S word, starts with S, ends with less, but it's, wholly managed services. This is the full pipeline.
I was like, what word is he talking about?
Well, at first you thought the naughty word.
There are no servers for you to need to manage, but there's also no load balancers. This is load balancer-less. There's no clusters. This is clusterless.
That's right. Yeah, you didn't specify any kind of cluster. You didn't even specify I guess you did. It did ask you, CPU and memory, but you didn't have to pick like instance type or anything like that. Interesting.
I don't need I didn't need to pick. I get DNS off the bat, like right out of the gate. I get a unique endpoint for my service. This is also going to have TLS for me, managed TLS.
Oh, wow. Okay. That's cool.
And I didn't pick a VPC. Like there was nothing in there that I needed to do. This is App Runner right now is all public services. We have a roadmap on GitHub. You can see it in the blog post that we'd love to allow some private access on VPCs. But right now for the simple stuff, just deploy it. You get a public endpoint, publish your container, you're ready to go.
Nice. All right. So obviously it's going to take a couple minutes for this to come up, but you mentioned a blog post. Do you happen to have that handy?
It's going to be on the AWS Containers blog.
Okay.
And it's going to walk you through basically deploying this, but also it's going to show you that we did this application. Not only is it published on ECR Public, but we have the source code available as well on GitHub. So
awesome.
You can head over to GitHub and it gives you a couple other options. If you want to see the full managed build pipeline, check it on GitHub. You can fork it here on GitHub and connect this into App Runner. You can say, instead of saying I have a pre-built container, say I got a source code repo, connect it with this repo, and you can walk through the same steps. And you can say, the blog post outlines it for sure, but you can also say like, I have a managed config file. You just give it a name at that point. You say, here's my source code repo. This is what I want to name it. And you're off.
So
wow.
you mentioned build pipeline. So what happens when I've done it the first time, we have our code, it's built our image, it's deployed it. This is amazing. But now I want to build like a repeatable process. Can I do something like that with App Runner?
Absolutely. Yeah. You can have a trigger on, if you have a source code repo, you can have it triggered automatically whenever you push to a branch you define, or you can have it manual if you want to actually push changes in GitHub or in your repo and then go back and say, okay, now I want to deploy the thing. So you can separate those if you want, but you can also just say automatically. The only thing you really need in your repo is actually this App Runner YAML file, which is going to give you a managed runtime. I can make that a little bit bigger for you. Manage runtime, your build commands, and then what command to run the app and a port. Just like kind of information we had. You don't need a Docker file to build it. It's just, this is fully managed.
No Docker file?
No Docker file.
Holy cow, that's awesome.
And again, all of this build pipeline is builds per minute of usage. So as you're building it, you're not charged for your build pipeline existing if you're not currently building things.
So I don't have to have my Jenkins servers lying around.
Adam, we know you love Jenkins. You can keep them if it makes you feel good. Keep the Jenkins servers if you like them, but you don't need them.
But I don't need them, and I don't need to pay for them because App Runner is just going to do what it needs to do, and I only pay for the time that it runs to build and deploy. Yep. That's pretty awesome.
Yeah. One other thing to point out here is the App Runner is container based, and it actually each container instance shares requests. So it's not a per request sort of like invoke my container. We do have, you get one running by defaults that goes into kind of like a lower state, but you're only paying for like execution time and memory usage while it's there. But this allows you to do some things that are kind of neat with containers, such as there's some shared scratch space. So this application actually publishes, it generates one of these avatar images for you, which you can share it on Twitter or in Slack or something, and it automatically populates. And the avatars are unique for each application, and it saves it to disk. We got a little scratch space, and each request just keeps reusing that same scratch space. So I'm not regenerating that each time. I don't need to put it in S3 and store it and fetch it. It's just something that, hey, I had a little scratch space, I can put it there. And this application also publishes a Prometheus metrics at a metrics endpoint, because you can keep that in-memory cache of long-running history about the application. If you want to scrape it, you can. You don't have to. CloudWatch is built into App Runner. It gives you automatic metrics. It gives you automatic logging. I did this as like an example to say, okay, if you want to do something with an in-memory cache for whatever reasons, something long-running, you can have that.
Wow.
Very cool.
Can you show us some of that CloudWatch stuff that you were mentioning? Sorry, Brent, I interrupted.
Yeah, no, it's all good.
Or will we see that when we get deployed?
Look, it's running.
Our app is running already. But yeah, you get your logs down here, which will show you the actual, like, hey, this is the deployment log, or the event logs for like as things are rolling out. Your deployment logs, if you're doing a source code.
5 minutes. That's awesome.
Yeah, you can get up and running any public container and ECR public. We would like to support some other registries in the future, but for right now, ECR private, ECR public, supported out of the box.
Okay, private as well. Cool.
Yep.
Nice.
And application log. So I can see health checks. I can see requests on the application. I can view it in CloudWatch or view it right here embedded in the console itself.
So deployment logs, application logs. That's visibility into two pretty important areas. That's awesome.
Yep. And so that's pretty much it. So once and you can also get custom domains. You can bring your own domains here, everything. But this is the example app. We'd love for you to try it out. In the blog post, walks you through it, and then inside the app itself, you can share it to see your unique banner image. There's also a link. We have a workshop, goes into some more advanced things you can do, such as talking to a database and some more things on just showing how like rolling upgrades, those things work.
That's awesome.
Yeah. And the docs. And that's it. That's as simple it is. You can run a container. You're paying per, execution as you're using it, per request or per instance. So you can scale those up as well. You can scale this up, start with 1, scale up to 20, 30, whatever you need. It'll auto scale based on those requests. And you're paying for usage of those requests and builds.
Wow. Okay. So it auto scales just out of the box?
Yeah, by default, there's per request on each instance. I think it was 80 requests. Once you get the 81st request, it'll spin up another instance for you and start sending requests there. And those are concurrent requests. So you can have them sequentially just coming and you won't scale up. If your app can handle 100 requests, you can change some of that as well. That's all in this.
Okay.
So auto scaling right here, I have a 100 concurrency. My minimum's 1, maximum 25 is
wow.
What I had set by default. Get some automatic health checks here, all out of the box.
That's awesome. I can't wait to start messing with this. So you mentioned roadmap. What's coming next?
All sorts of things. Right now for the build pipelines, we're supporting Node.js and Python. For the container registry, it's all ECR, public and private. We would like to do Docker Hub. We want to get some more languages in there. Probably even if you want to bring your own Docker file build pipeline. So definitely check out in the blog post. We have a link to the projects. So it's public on GitHub. +1 some features there. If you find something that you really want to do, something that you really want to get enabled with to use this service, go check it out.
That's awesome. All right. I'm going to go mess with it. So thanks for showing this to me. This is fantastic.
Yeah. Sounds good. And anyone that deploys it, definitely hit that tweet button. We want to see your custom avatars and how you're liking the service.
Yeah.
Yes, definitely.
All right. All right. Take it easy.
Good luck. Thanks. Bye.
Right on. So we are, by the way, I see comments in the chat, no sound and all that good stuff. So I see we can hear Brent, but we can't hear Adam. Exactly.
Let's see. There's my audio. It's back. Thank you, everybody, for that. Thank you.
Sadly, that means they missed your whole introduction.
Oh man, and I got to tell everybody here, I think this was my best intro yet. I was witty, I was funny, like I really was feeling good. So, for those of you that missed it, I'm really sorry, but maybe tomorrow I'll try to start out with a better one. Anyways, Brent, please go on.
That means they missed out on the free AWS credit code that you spoke. That's awesome. All right, so we are going to be running through parts of EKS Workshop this week, and we're going to start off with mostly we're going to limit ourselves to the beginner level stuff. So we're going to start off talking about the introduction, where we talk about just what is Kubernetes, how does it work, what do we do, and then we're going to dive into building a cluster. Then we're going to move on to hopefully today deploying our very first container. So that's the goal for today. We'll see how far we get. If I get long-winded, then maybe we don't quite get there. But come back tomorrow if that's the case. We're going to be here all week. and we're going to be doing this live all week. So definitely plan to join us. If you're on the West Coast, it's a great lunch and learn opportunity. If you're on the East Coast, it's kind of like a nap time situation. So you can feel free to, take a mental break from work for a bit and, tune into us and ask questions in chat, take advantage of the time, and we'll be like just slowly churning through this stuff. So without further ado, let's talk containers and Kubernetes. So we start off just, we started last week talking about containers and ECS and orchestrating your containers using ECS. And we kind of touched on it a bit, but let's reiterate, what is orchestration? If you think about it, orchestration is necessary once you start to have a certain level of scale. When you break a monolith down into microservices, you go from managing one application to managing a set of applications. So that set of applications could be, 2, 3, or 4 additional apps, or it could be a dozen or more additional processes. When they're all running on a single server, they're still pretty easy to manage, even if you're managing them by hand or if you're using traditional operations tools like Puppet or Chef. But once you start to get into the dozens to hundreds of applications that you have to manage, it starts to become unwieldy to do it the traditional way, assigning a node a certain type, and then saying like you might say, this set of servers, this is my web tier, and my web nodes all need to have these 7 containers running on them. I mean, that's great, and it certainly works, but it's pretty limited. It's taking the perspective of still tying applications to instances. So at that point, by moving to Docker, really the only advantage you're taking advantage of, or the only thing that you're gaining by, is you have better packaging for your applications, and that's certainly worthwhile. But you could still have more. So in addition to better packaging, being able to more easily install an app, so to speak, we could actually also take advantage of the ability to shift applications around and kind of balance them and place them where they'll fit better, so we can get better efficiency of our resources. So instead of thinking about your infrastructure in terms of, I have web servers, I have database servers, I have cache servers, and all these other types of servers, instead you start thinking of in terms of, I have web apps, I have cache apps, and I have database apps, and I need those to all be running somewhere in my fleet of servers. Kubernetes and other container orchestrators, these just give us a way to group together our servers into a pool of resources, a big pool of resources that we can then launch our processes out onto. Kubernetes is a container orchestrator, and it works by allowing us to declare what is the end state that we want, and then it uses its own built-in logic to get to that state. So if you think about for a second, Puppet, Chef, etc., those are great because they give you a unified language that you can type instructions in, and you can say, I need to be able to install package A, then package B, and package C. Then I need to be able to execute command, whatever, and then grow a hard drive to a certain size. And you give this list of step-by-step instructions that have to occur. We don't do that with Kubernetes. We don't do that with any container orchestrator. What we do instead is we describe, boom, this is what it should look like when you're done. and the orchestrator figures out how to get there. It looks at, what do I have right now, and what do I need to do? What are the steps that I need to take to get there? So it's not up to me to decide what those steps are. I think that's really cool. It's sort of the next level of operational excellence. So definitely it's worth exploring in a little bit more detail. Now, we're going to be talking about a little bit about Kubernetes, but also we're going to be talking about EKS. And I might occasionally use those terms interchangeably. So let's talk real quick about what is EKS. EKS is Amazon's Kubernetes service, the Elastic Kubernetes service. And what this is we had a lot of customers running Kubernetes on AWS. And just like many other opportunities, we see, we can make this easier for our customers. We can take the heavy lifting away, the operational overhead. We can take that off your hands so that you don't have to worry about that anymore. And once you start to see, if one person is doing something over and over and over again, great. They're going to get really good at it. But if 1,000 people or 10,000 people or 100,000 people start to do the exact same thing, at that point, we should look at doing it for you. We should, if we're going to be obsessed about our customers and helping them on their journey, then we should start looking at those opportunities and doing that for you. So that's what we did when we launched EKS. We actually saw that a bunch of customers were running Kubernetes on their own, DIY style. They were struggling a bit with managing the control plane and managing upgrades and all that stuff. And we said, if we just focus, we can probably solve this problem for all of our customers at scale. And so we launched the EKS service to be able to answer that challenge.
Hey, Brent.
So, yeah.
So can you talk a little bit more to that point of, so we come from a background of, previous to having this managed, system for us of managing our own orchestration platforms. Can you maybe talk to some of the pain points that come with that, just at a high level?
Yeah, I mean, just if you've ever done it, just think about what you have to go through to upgrade a cluster. Like, let's just start there. Upgrading a cluster is not a trivial thing. You don't just type a command or yum-y upgrade or anything like that, because it's not just one process that's running. It's actually an entire collection of processes that are running, and they all have to be kind of orchestrated themselves and upgraded in a particular order. And we have to make sure that one is healthy before we move on to the next. So it can be a challenge, quite a challenge. And being able to perfect that process is something that you don't have a lot of opportunity to do. If you think about it, Kubernetes is a project that cuts a release every 3 or 4 months, and so that gives you 3 or 4 times a year that you get the ability to go through the upgrade process and figure out, what do I need to do? And once you've gone through it, then you're just so relieved that everything worked. You don't want to go back through it again and hone and tweak, or at least not many of you do. So you're just like, I'll tweak it a little bit more in 3 or 4 months. So that's just one example of a challenge of running, the control plane tier of applications yourselves. Just stop and think, what version did I start on? How many upgrades have I done? If a new version were to drop today, how would that change my timeline? What would I have to do? Would I drop all my work, or would I just be like, oh yeah, okay, I can take care of that in a few minutes? We want it to be so easy that it can just be taken care of in a few minutes and you don't have to think about it. Customers, before EKS, didn't really have that luxury. They would plan, elaborate maintenance windows, and they would have to figure out, when am I going to do this upgrade? A different scenario is if one of your nodes dies, how do you troubleshoot? How do you fix it? Or if one of the services that's running on the control plane dies, how do you detect it, troubleshoot it, fix it? So these are all things that, you have to be good at to be a good Kubernetes administrator. And so, we want to be able to assist in those areas, and then let you focus on deploying and running and scaling your own applications.
Definitely.
Hopefully that helps answer the question.
Yep. Thanks, Fran.
Cool. Okay, so Kubernetes. We're going to take a look just at a real basic walkthrough of Kubernetes and how it's laid out. And then we're going to get into EKS and how that works. So what is Kubernetes? I've kind of alluded to it already or said it outright. It is an open source container management platform. And by the way, if I didn't say this before, you can see all of this material at eksworkshop.com. I'm just stepping through the intro section of the website right now. So you can watch it on screen now, but if you want to share this later, you can share the videos or send around the workshop link. It's out there and publicly available and free for you to use. So what does an open source container management platform do? Well, it helps you run containers at scale. And then it provides objects and APIs for building modern applications. So let's take this first box real quick and let's just break it down. Open source. If I was going to emphasize anything here, it's open source. And then container management platform is secondary to that. I think that, people use Kubernetes because they want to manage containers, but also they pick Kubernetes because it's open source. Now that brings a couple of features to the table. One, they can see the code, validate the code, and modify the code. And that's hugely valuable to a lot of people, especially the developer-minded people. But two, it also gives us the ability to run virtually anywhere. So I get asked a lot of times, what should I use? Should I use ECS or should I use Kubernetes or EKS? And my answer is always the same. It starts off with a question back, and that is, well, are you all in on Amazon? And if you're all in on Amazon, then you might consider ECS. But think about the other scenario. If you're not all in on Amazon, you perhaps have to manage compute in a data center, manage compute in your office, plus then also some compute on Amazon. What do you do then? You're used to having at AWS all of these super nice APIs to be able to bring stuff up, take stuff down. So that's really great. A lot of times you don't have that in your own data center. You just have some bare metal that you have to go and like touch. And who wants to do that? So Kubernetes actually gives us a consistent API everywhere that we run it. So we can choose to run Kubernetes in AWS, plus run Kubernetes in our data center, and we can basically build the same experience in both places. So we can then start to write code, train our operators, train our developers to have the same set of expectations everywhere. Also, one cool thing about Kubernetes is that it can scale down to be very, very tiny. So even though we'll be talking about it in terms of running it in production, where you have, multiple control plane nodes, you have, recovery from failure and stuff like that, lots of redundancies, you can actually scale it down so far that you can run it on your laptop. People run it on Raspberry Pis. So because it can scale down that small, it's great for a developer environment. So if you think about it, you can have the same experience as a developer going from a dev environment all the way through to QA or staging or whatever your company calls that, all the way to production. It can be the same set of APIs and the same experience and the same operational procedures. So that's one of the best parts of this being an open source platform, is that level of functionality can be built in. So let's talk about the nodes. The nodes that you'll have to run if you're running Kubernetes, and then we'll break that. We'll show you what will be running for you when you run EKS. So the machines that make up Kubernetes, they're called nodes. The nodes meaning instances. That would be the equivalent of an EC2 instance in AWS lingo. They may be physical or they may be virtual. You can run bare metal, you can run VMware instances, you can run EC2 instances, etc. They break down into two classifications: the control plane node and the worker node. I'm going to leave it up to you to guess which does which. So no, I'll explain it. The control plane node is where all of the decision making goes. That's where all of the administrative processes get run. And then the worker node, that's where your applications will execute. So when you want to launch your application out onto Kubernetes, you're going to launch the data plane nodes to handle that compute. The worker nodes, on the other hand, are just going to handle scheduling those applications to run, locating those resources for those applications, detecting when they're healthy or unhealthy and routing traffic to them, and all that stuff. Now, Kubernetes, one of the cool things about it is its API and its object-oriented nature. So Kubernetes objects are just entities that are used to represent the state of a cluster. So remember, I said we don't describe the step-by-step path to get to where we want to go. We just describe the end state. And we do that by describing these objects and what we expect to see when everything is perfect. So an object is simply a record of intent. Once it's created, the cluster does its best to ensure that it exists as defined, and this is known as the cluster's desired state. So we might say, I need a deployment of application A, and that deployment is an object. So I can actually just describe that to the Kubernetes control plane, and then it will do whatever it needs to do. It'll figure out all the steps necessary to get me that deployment. And then once it has it, it'll sit back and say, this is perfect, and everything will look healthy. And then if anything should come along to change the way that deployment looks, the control plane will notice, and it will do whatever corrective measure it needs to correct the situation to get it back to being perfect. So all we do is we describe the end state to Kubernetes. So here's what we can describe. What pods are running on which nodes, any IP endpoints that map to a logical group of containers, how many replicas of a container we might be running, and there are more. Okay, so some of the objects. Pod. This is probably, you could think of this as being the smallest unit of measure in the Kubernetes space. It is simply the description of how to run one or more containers. Last week we were talking ECS and we talked about tasks. This is the Kubernetes equivalent. This is the pod. And a pod, you might start off thinking one pod, one container. Doesn't have to be that way. That is definitely the most common thing to see, but it's not the only thing that you'll see. A lot of times you'll see a pod that includes a couple of containers. One may be your application code, and another one may be your sidecar. A sidecar might be used to send logs wherever you need those to go. One might be used to collect metrics. You might even have your application container plus a log container plus a metrics container. Now you have three containers in a single pod. What's great about a pod is they actually share compute together. They always go out together. They're always running together. And when you kill them, they go away together. And they also share a network interface, so they can talk to each other over localhost. So that's really handy too. When you're thinking about, should I put this in a pod, in the same pod, or should I make it a separate pod, just ask yourself, when I deploy them, how do I scale them? Do I scale them together always, or do I scale them independently? When I'm scaling them independently, they need their own pods. When I always scale them together, they should all be in one pod together. A daemon set is another kind of deployment. And what this does is it implements a single instance of a pod on every worker node. And you can filter and say, you know, like only worker nodes that include GPUs should have this kind of daemon set running. Only worker nodes tagged with a certain tag should get this daemon set. But for the most part, think of it as I have a collection of instances, EC2 instances, compute, whatever it is, collection of compute, and I always want one copy of this pod running on all of those, each of those. So a lot of people do use this for Splunk forwarding or whatever other log aggregation or X-ray collection or you know, anything that you need to be installed at the instance level. Install it with a daemon set. It's much easier. A deployment details how to roll out or roll back across versions of your application. So a deployment it describes how should this go out. And you might say, well, you know, why does that matter? Everything should go out the same way. Well, not really. There are cases where deployments you need to think about how does this go out versus a different application. And I'll give you one good example of this. If it's a web application, yeah, just, you know, like add more, contract the old version, add more, contract the old version until you're fully rolled out. That's perfectly fine. But if, let's say, instead you're talking about a Kafka consumer, you know, every time you add a Kafka consumer to a topic, it rebalances, right? Imagine if you were doing that incremental add and incremental subtract, you would be rebalancing the entire time span of the deployment. And that might be many minutes. So that might put you very far behind consuming whatever you're pumping into that topic. So instead, you know, you might, for a Kafka topic or a Kafka consumer, consider completely kill the old version and completely start the new version all at the same time. And that way you're minimizing the rebalance time. So that's just two examples of when you might choose different deployment styles. But anyway, getting to choose that is really handy. What else do we have? Replica set. Ensure a defined number of pods are always running. When you're in production, you will probably never want only one of something running if you're sending live traffic to it. So you can define with a replica set, I want 3 running, or I want 7 or 37 running. A job is a process that it starts, runs, and then once it's complete, it goes away. So I like to think of jobs in terms of cron jobs. People use the job object as a distributed cron all the time. Service, this is how we can actually create an IP address and map it to a logical group of pods. So I might have a front-end web application, and I'll create a service that fronts those pods. So that's how everything that needs to send traffic to my front-end application talks to my front-end service. And then the traffic gets routed inward to the pods wherever they happen to be running. And as those pods come and go, and as they move around, that mapping is constantly being kept up to date so that traffic can be routed to the appropriate pod. A label is a key value pair, and it's usually used for association or for filtering. You can use it for all kinds of stuff, but that's a pretty common use case. So let's take a look real quick at the architecture of Kubernetes. So this is a logical view of the architecture, and these yellow boxes, you can think of those as being, well, in fact, they're labeled the control plane and a worker. So these are all of the parts that are running in each location. Now, the orange box is kube control, and then the green box is the internet. So think of kube control as being, if you're the operator of Kubernetes, this is you, this is where you're sitting. And then the internet, that's the traffic that's going to be coming into you, hitting the applications that you're running. So let's take a closer look at just the control plane bits real quick. So again, orange box, you using the kube control command, it's always talking to the API server. So there's a process running on the control plane called the API server, the API process. And that is the thing that kube control always talks to. So then elsewhere running on the control plane, we have a controller manager, and we have a scheduler, and then we have our state store, etcd. etcd is just a distributed key value database. It's equivalent in a lot of ways to Zookeeper in Mesos, or Console from HashiCorp, distributed key value. So this is where the API server will write all of its information so that if anything ever goes wrong and we need to read what is the current state of the cluster, we'll have all of that data stored. So kube control only ever talks to the API server, and then the API server can reach out and queue up information or talk to kubelet. So that's our path to get to the worker. Notice it's off the control plane. We'll take a look then at the worker.
And Brent, I know we're going to be doing more with kube control in the workshop, but I think maybe just even a high level of what are some of the benefits of using kube control? What are you doing with it?
Totally. Oh, this is actually a good topic. I love, and by the way, I say kube control. Some people say kube cuddle. I've heard all kinds of crazy pronunciations, but for me, it's kube control. Hopefully that doesn't offend our audience. But what is kube control? It's basically a wrapper around the Kubernetes API. So if there is an API call that you can make, then there is a kube control command that you can execute to make that call. And I think that's awesome. So instead of having to formulate a curl and have the right authorization headers in place and understand when you need to get versus when you need to post and all that stuff to talk to an API, you can just run a command. Just bang it out, run it, and you've executed an API call at that point. So it's really cool. And if you ever then want to explore what functionality do I have in kube control, start exploring the Kubernetes API. That'll really get you a long way to figuring out what can I do with kube control. So definitely check that out. Also, kube control, the format is it's pretty cool once you realize that you have the command kube control, and then you have a second word. That second word is always a verb. Your kube control get, kube control describe. It's always a verb, and so that can really help lock in the command structure for executing whatever API call it is that you're trying to execute. So just figure out what am I trying to do? That's your verb. And then what object am I trying to do it to? That tends to be the third word. And from there, you just start filling in details after that. So that's how you use kube control. It's really simple. Okay, so we were back on the control plane. Let me run back here real quick. And I was talking about kubelet and I was pointing out that it was off the box, right? Well, that's because if we look over here on the data plane, it's running on the worker. So that's how the control plane connects to the data plane, is by the control plane API server and kubelet communicating with each other. So that's why we see the API process here communicating with kubelet. So kubelet, you could think of this as being a Kubernetes agent. So this is what is running on all workers, and this is how they connect to the API to figure out what they need to do. So let's say we need to queue up a deployment of our front-end web application. The scheduler decides where the resources are that are available, and it decides where this pod should be scheduled. So it then writes to the API and says, schedule it on worker 1. And the API process then queues up an action for worker 1. And as soon as worker 1 checks in with the API process, it sees I have an action, and it goes ahead and executes that action. And so worker 1 is executing all of the appropriate commands to launch my front-end API. So where are we now? We have kubelet. Where does it write, or where does it control? That is what launches pods for us. So in this particular diagram, excuse me, we see that we're launching a couple of pods. We're using the Docker daemon to do that. But we also have this other thing over here, kube proxy. Well, remember in our big diagram, there was you, the operator, running kube control commands, but then there was also the internet. So let's pretend for a second that I'm launching my front-end web application, and we're expecting to receive traffic from the internet. That traffic has to get routed to the appropriate container, and those containers can be running on any worker, but also on any port on that worker. So we dynamically assign ports to be able to fit containers into the workers. So we don't all, if we were sticking with static ports and you launched a container that took up port 8080, well, now I would have to schedule the second copy of that running somewhere else because port 8080 is taken. If, on the other hand, we just say, give me any available port, now I can run as many copies of that as I need to be able to answer requests, and I can spread that out wherever it'll fit in my compute fleet. So anyway, kube proxy is how the traffic gets routed inward to talk to whatever the appropriate container is. So the traffic comes in from the internet, it hits kube proxy. Kube proxy knows everything that's running on this worker and knows that this traffic is destined for my front end, and it sends it to that container. How are we doing with questions?
All good.
Sweet.
I'm just
All
answering
right.
in the chat, so we're just chatting in
Nice.
the chat. All is good.
All right, so let's talk about Kubernetes cluster setup. If you're going to build Kubernetes yourself, you have options. Minikube is certainly a great option. It's great for development and learning, teaching yourself Kubernetes. If you want to build out, a DIY cluster, COPS can help you do that. So you can launch, for example, you can launch on EC2 instances in AWS. kubeadm will help you build out a Kubernetes cluster, also good for learning, development, and production. And then there's Docker for Mac, which is Docker Desktop running on your Mac. It actually is running inside a virtual machine, but it does a really good job of sort of hiding that fact from you. And it makes you feel like you're running your container in the Mac OS. So it's really cool if you do have a Mac. There's also Kind. This is spelled out Kubernetes in Docker, but you'll see it often referred to elsewhere as Kind. So you can definitely check that out for learning. Now let's talk about EKS. So we've been talking about Kubernetes, and everything that we've talked about so far in that little intro is how Kubernetes works everywhere. But let's talk about what are the specifics with EKS.
And Brent, a question did come in.
Yeah.
Just around kube proxy. The question is just, is kube proxy bound to a specific port on the worker?
Yeah, it is. Good question. So what you tend to do is you have kube proxy take up a port or 2 or 3 or 4, whatever you need it to take up, and it will be the owner of the official port for that service, and then it'll route the traffic from there to whatever randomly assigned port that the container is actually located at. But that way you can have, one process sitting there owning the one copy of the port that you have or that you have available on that one worker. So that's how we're able to sort of scale port addresses. Hopefully that answers your question.
Cool.
Okay, so EKS creation cluster workflow. Now, I like to describe this because I like to describe what this one bullet point actually encompasses. So what we're doing is we're reducing building the cluster down to one bullet point. And then everything else is the same, whether you're doing a DIY cluster or you're running EKS. So creating an EKS cluster is, for us, simply running a command for EKS. But if you think about what do you have to do for building a DIY cluster, go back, a couple of those slides and look at COPS or look at any of those production level processes, and you'll spend a long time building your control plane. You have to bring up control plane nodes. You have to bring up, ideally for production separately, etcd nodes. The etcd nodes need to, network talk to each other and build a quorum. Then your control plane nodes can start using the etcd nodes, and they can start to bring up all of their processes, including the API server, the scheduler, and all the other ones that we were looking at. So only then are you ready to actually add worker nodes. So that process can take, a very, very long time. We boil it down for us, for you, we boil it down to a single bullet point, launching an EKS cluster. And that's what we're doing for you behind the scenes.
And I think it's important to talk about that separation of etcd from the control plane nodes, because what happens if you run them on the same nodes, and what happens if all your nodes go down?
Yeah.
Where's your state of your cluster?
Exactly. Yeah. So if you run etcd, completely independently, then you're protecting yourself from, getting into some kind of weird IO contention, where, I've seen clusters even get deadlocked, where I make an API call and it's trying to write to the database that's running on the same, nodes. And because the write is so intense and so heavy and so repetitive, I can't give back the result of the API call. And so that ends up creating this API storm that, just continues to send, retries. And keeping those things separated gives you a fighting chance at recovering from that kind of situation. Now, it doesn't make the situation go away. It doesn't eliminate the possibilities there. There's definitely other things that you want to do to safeguard, but it's at least one massive step in the right direction. So if you're ever building a cluster for production, definitely consider splitting out your etcd nodes. I see that question. Is there a threshold as to how far the actual state can be from the desired state? The desired state is always something that we're trying to attain. So I don't know about a threshold necessarily, but I can tell you one situation that comes to mind is if we're trying to, for example, do a deployment, and that deployment, it requires that we schedule pods based on the availability of certain resources. If we're out of resources, then that deployment is just going to sit there and wait infinitely. So I wouldn't say that there's necessarily a threshold, but that's a situation where the actual state will never reach the desired state until there's some kind of intervention. and the intervention would be to add resources. So, and we in the workshop will actually get into automatically adding those resources using auto scaling. But that's a great example of, it will do everything that it can do, but there will be times when it just can't do enough. And so that's when intervention has to occur. So I said single dot create cluster. What does that boil down to? Well, that's really us creating an H8 control plane, creating the IAM integration. We'll get into a little bit more of that. Building out certificate management for you, and then setting up a load balancer. And I'll show you a little bit more about the load balancer here in a second. Maybe even right now. So, so what is the load balancer, and how does all of this communicate together? When you look at the EKS cluster that you've built, you actually won't see control plane nodes. What you might see if you really start to look around, though, is you might see some ENIs that are attached to a different VPC or a different network. They're attached to your network, but they're also then allowing traffic from a different network. Here's how EKS is built. The blue box, that is, think of that as your account and your VPC. And then the orange box, think of that as our account and our VPC. So we have a VPC where we are bringing up the control plane nodes. We are bringing up etcd. We are bringing up all the right things. And then what we do is we provision ENIs into your VPC. When you build EKS, you target a VPC that's in your account. That's where we'll drop in some ENIs for you. And that's how our control plane nodes talk to your worker nodes. So they appear to all be on the same network. However, they're actually doing cross-account ENI connectivity. And then as far as the reverse traffic goes, the reverse traffic is when the API needs to talk back to the control plane. Kubelet needs to check in with the API. That happens over a network load balancer. So this is the load balancer in the last slide that we're referring to. We provision a load balancer that has an IP address that then your worker nodes know to reach out and talk to. And that traffic gets routed to the API process on the control plane.
Yeah, there's just talk of ENIs, so I just think it's for those who maybe aren't super savvy with AWS terminology.
Good call. What is an ENI?
Yeah, so it's an elastic network interface, right? So this is a way to expose a service or a resource in your network, in your virtual private cloud. So VPC is a virtual private cloud. That's your logical network where you, in this case, would run your worker nodes, but then you're sharing that with the virtual private cloud from, well, not sharing, but they're talking to each other from the control plane. It's virtual private cloud to your virtual private cloud.
Awesome.
So I just wanted to touch on that.
Thank you. Okay, so high level, what's happening? You're executing kube control. You're sitting here running your kube control commands, and you're firing those at the API process, and that is running, at AWS, EKS. It's you're talking to whatever your cluster is, .eks.amazon.aws.com. So we are running that control plane for you, and we are presenting the API to you. Your workers are then running in your own private VPC, and they are checking in to the same API process. So you can reach it from where you are running kube control. They can reach it from where they are inside their VPC. All right, so that's the lowdown of.
Hey, it's Adam and Brent, and we wanted to let you know that if you're looking for more live or on-demand container content, you should subscribe to our YouTube channel.
Head on over to youtube.com/containersfromthecouch, and also check out our website at containersfromthecouch.com. Thanks.
Thank you. Good?
Yeah, I think
You
that was
feel good about it?
Yeah,
All
I
right.
feel pretty good.
I'm going to end the broadcast.
Rhymed. I didn't do
Well,
that on purpose, but
And
you can quote me.
if you've been around AWS, I'm speaking to the audience now. If you've been around AWS for any length of time, you've started to notice probably that we have a bunch of two pizza teams, and they often will, do things in very similar ways, but they're still independent teams, and they'll arrive at similar conclusions. So this actually happened for us because while EKS Anywhere was being developed by one team, by Chandler's team, and being worked on, we also separately on a different team were working on ECS Anywhere as well. And so, who wants to talk about ECS Anywhere? Just tell us what's the idea behind it, and how would the customer go about using it?
So the idea behind ECS Anywhere is that you get to benefit from a fully AWS managed control plane and just connect your hardware to the AWS control plane and put it under AWS management. And it's super fascinating. The idea is that I don't have to worry about the control plane anymore. The control plane is being automatically upgraded by AWS behind the scenes. We talked a little bit about how you could automate that with the EKS Anywhere distro. But in this case, there's actually AWS engineers who are managing the control plane and updating that. And they're the ones who are on call if anything goes wrong. And that control plane is just connecting down to your hardware to send commands to it. And you're responsible for running an ECS agent on your machine, which connects back to the cloud and essentially turns into a little extension with its own IAM roles that it can fetch and everything else as if it was there inside your data center, basically.
That's awesome. So you have all this compute in your data center. You know that you want to begin to move to the cloud, run containers, use the AWS APIs. You can do that by just talking directly to the AWS ECS API, the Amazon ECS API, and then have it talk back to just an ECS agent running on your compute. Like that's really simple, right?
Yes,
about
and
as simple as it can get.
And this goes back to what we were talking about earlier. So I have a data center and I have a use case where I need to access resources in my data center. Rather than having to deploy my virtual machines in the closest region, whatever that is, I can just use that existing hardware, use the virtual machines I have on site, and those can now run containers through ECS. So if I need to access local resources, a local NFS share, whatever that is, I'm very close to my data now. I'm right there.
And I know, so this has been announced. It's not available just yet. However, I know you guys have worked up a demo of ECS Anywhere. So whose screen am I going to share?
Justin's first, probably.
All right.
So, and I did want to add one thing too, that just the fundamental differences here with EKS Anywhere, ECS Anywhere of the managed control plane. This is, allowing us to bring worker nodes into your data center and EKS Anywhere doing actual control plane if you need to. There still are physical limits and reasons you may not want to do some of these things, such as latency. This demo here is actually a really bad idea to do if you're running production off of something like this. So just
we're full of bad ideas.
Yeah, it's just pointing out this is for an example use case of how simple some of this is, but at the same time, some of the limitations here, where you can see this top table here I have we're describing our container instances in an ECS cluster, and we have the agents. We also have its mixed architecture because Nathan and Adam have some Raspberry Pis, and I have a spare laptop. So we have mixed architecture here, and then we just named these data centers with right now zero connectivity between them. So this isn't like something that's like, oh, I can migrate workloads from one to the no. It's not necessarily working like that because my node can't talk to Nathan's in New York, which Adam and I are down here in Southern California, and our latency to migrate data or something would be terrible. So absolutely think about how you need to use this stuff. But for something that I want to throw some random jobs and do compute somewhere, some of that stuff is something you could do. We also just gave some random host names here. You can see these are all through managed instances, which is Session Manager, allows you to have on-prem managed instances. This is something you can do today. Don't need ECS, don't need it. You can actually just say, hey, I want to manage my instances and get session management services on your local instances. So I gave a demo of this back in June about using Session Manager instead of SSH for on-prem and for cloud. So you could say, hey,
can I just interject and correct one thing real quick?
Yes.
So if people are looking this up, it's actually a systems
manager, Session Manager.
Yeah, systems manager. Yeah.
There's too many managers in it, but
confusing.
Yeah,
Yeah.
not confusing at all.
right. But this, just looking at this table, this is, AWS CLI just doing a watch. And anytime we have, you can see Adams is running a job right now. I don't remember what job that is. We do have some task definitions. So if I run a task here, I had one called pod info, which is a demo, container that runs. I think, did yours get it? I saw your memory flash there. So your CPU and memory, this is what's available essentially. So we'll wait for ECS to basically schedule that to one of our nodes, and it'll show up here on how many tasks are running. There it is. Yeah, yours. So we can, something like this is a super simple thing. I saw a question earlier about load balancers. Again, none of this is actually connected to have load balancers or exposed in any way. These are just running a workload on these instances and also showing off, again, cross architecture, using the same spec, using the same definition. We can see that some of them will occasionally land on my box, but it's kind of like a container roulette right now, where it's whoever gets it is just the lucky one that is running a random Nginx server.
Yeah, and
I would like to call out that this is a native ECS task, meaning that this task has a task role and the task execution role. So if you're talking back to AWS services, the task role will be able to say this task and this container can talk to this SQSQ, for example, or whatever, or S3 bucket or anything. So this is first-class citizen when it comes to the AWS APIs and the AWS objects.
That's a great point. And by the way, Justin, your task, I'm watching in real time. I'm just on my Raspberry Pi watching Docker PS. Justin's pod info node just ran on mine.
I just popped your screen up.
And Justin, if you can launch that task again, not the pod info, launch
the region ping.
The region ping task.
Yeah, launching it now.
Cool. And so basically you can see there's a couple things happening. Yep, Justin just launched that task. It was short-lived and it's done. I also have a long-running task where I'm looping through the code. But anyways, you can see I have an ECS agent. This is a Raspberry Pi. I mean, nothing crazy, nothing fancy here, but using the native AWS, the ECS constructs, as Massimo mentioned, we're deploying containers to our local Raspberry Pi data centers.
And as far as the workflow change goes, I noticed in Justin's command, it was, what was it? Launch type external.
Yeah.
Was that really the only change? I'm not saying that's all you had to do, but as far as like when it comes to changing the way you launch something, is that it?
Yeah.
Yes.
Wow.
Yes.
Yeah, Massimo has a great talk at reInvent. Go find his talk on how he explains a lot of this more in detail. But essentially, yeah, it's a new capability that is added into ECS, and you're able to specify, I want this to be external, and that's how your instances, when they register themselves as external instances.
Yeah.
And
So this is the first iteration that we have done from a development perspective. So we added a new launch type and the new compatibility external, in addition to EC2 and Fargate, which has been existing for a while. And we intend to also add capacity provider support to these. So they will be able to manage these external capacity with capacity providers as well.
That's very
awesome.
cool. And
I can tell whenever a container actually hits my
yeah, like
Raspberry Pi, because I feel a little fan kick on.
I'm gonna try and feature.
Can we just call out how dope this little cluster on his desktop is? Like, that is so cool.
Yeah, that's pretty great. So
See if I
you
get the
have,
mic over there so you can hear the fan sound.
So describe your cluster for the audience.
Actually, that's a nice
So
case.
what we got here is we got 4 Raspberry Pis, and there's the Raspberry Pi 4B model, so it's got 4 processors and 8 gigabytes of memory. So we're looking at a 16 CPU, 32 gigabyte memory cluster here that can run tasks. And as we mentioned earlier, one of my favorite things about this is that this has a lot of the features that you get when you're natively running in Fargate or on EC2. Most notably, the fact that you can actually get task IAM roles. So I didn't have to actually, and this is one of my favorite things, I didn't have to actually put any AWS credentials onto these Raspberry Pis. I just registered them with AWS Systems Manager so that they became managed instances. And then I ran an automated command which caused Systems Manager to provision these Raspberry Pis as ECS instances with the ECS agent. And from that point forward, now whenever I launch that task, they automatically get temporary short-lived IAM credentials that allow them to make AWS API calls on behalf of the application. I never had to actually touch these and run an AWS configure or get like IAM credentials. That's all automated, and it's all secured by those short-term, short-lived credentials.
And so this is just another reason why you should watch Massimo's demo, because Massimo in his demo talks to SQS, EFS, and the way his tasks get permissions to talk is through IAM, which is all managed through ECS. There's no credentials on the Raspberry Pis. He's not hard coding them anywhere. We're using IAM roles, attaching them to the tasks to make those calls and allow those API calls to happen. So we'll find the link for that and post Massimo.
I'm almost there. I got it.
I just posted it in the chat.
Perfect. Who's doing it? Brent?
Yeah, 1 second.
Okay, cool.
I wanted to add also something along the lines of what Justin was saying at the beginning of this demo. I think that what you saw here and what Chandler said when he described EKS Anywhere and EKS Distro built on top of the philosophy that we're using for EKS and ECS. So ECS is over-indexing on simplicity and ease of use, whereas EKS is over-indexing on flexibility and extensibility, right? So this whole notion that with EKS Anywhere, you have to instantiate the control plane closer to the data plane in your data center. For some customers is, well, this is too much complexity for me. And for others, it's like, this is what I need to build what I need, right? So for example, fully disconnected cluster that lives wherever, right? Whereas for ECS, we took a different path. Like, since ECS is all about ease of use and simplicity, we want to keep as much as possible inside the cloud so that our engineers are your SREs, so to speak, as Nathan was alluding to. And the only thing that you need to do is installing the ECS agent and the SSM agent on those managed instances, right? So it does have more limitation when it comes to comparing this to EKS Anywhere. Like, it needs to be connected, right, to work properly. But it's more simple.
I do want to interject on that a little bit. What we mean by connected to function properly. So I can actually disconnect the uplink on my switch here, and all of these Raspberry Pis will continue running my ECS tasks, and they'll continue functioning locally. However, I wouldn't be able to schedule anything new onto these because the control plane is running over the internet on the AWS region. I have to communicate to the AWS region, and the region has to communicate down to my Raspberry Pis. Whereas if I was running the EKS Anywhere, I would be able to have a local control plane internally where I could actually schedule new pods onto my hardware, even if I was fully disconnected from the cloud. So that is the small caveat there.
Yeah,
but my workloads would continue running though. So,
and with that freedom comes responsibility, right? I mean, again, you're managing a data plane locally in the data center, so it depends on how much flexibility and ownership you want.
I love that.
That's exactly the point, because for some customers, even that is too much, and they may want to need to use an outpost for that, right? AWS managed capacity instead of customer managed capacity. So yeah.
Yeah. So there's a ton of options available to you as a customer today. And like Justin and Massimo were just summarizing, it's all about how much responsibility you want and how much flexibility do you need. And but it does seem like there's something there for everyone, right? And we know our customers aren't all one thing. So our customers, in fact, even within a single customer, there are often use cases that will demand multiple solutions. So I like that there are now a lot of solutions available, a lot of flexibility, a lot of choices that the customer can make. So I look forward to all of the anywheres, really getting my hands on that and seeing how it works. I'm going to have to build my own Raspberry Pi cluster now just to keep up with you guys. So, but yeah, I hope that this has enlightened you just a little bit. And help you decide, what path you want to go down with managing your compute. Cool.
Bingo.
All right. So I've linked to Massimo's talk in the chat, and I'll pop it up here on screen real quick. It's definitely worth checking out. It's a reInvent 2020 talk, so go get it and see how we're thinking about running containers. And until tomorrow, I hope everyone has a great day.
Thanks, everyone.
Yeah. Bye-bye.
See ya.
Hello. Thanks for joining. Sorry for the delay. That was completely my computer having Monday's issues. And actually, if anyone notices, I'm on my phone. So this is gonna be super exciting. But we have to show you eCase Anywhere. It was a must. So wonderful to have Sheetal back with us. Hi, Sheetal. Thanks for coming.
Hello. Yeah, I'm excited. We have Vivek here, who has been working on EKSA for a long time. We couldn't think of any other better person to have and come share space with us here to tell you all about EKSA.
Yeah, I see I'm still having some problem with streams here, but I'm gonna figure that out. So if anyone hasn't been paying attention last week, oh good. It looks like I was gone for a second, and then it looks like I'm back. Oh, and I can't. I can't pop in comments. This is an unfortunate. No, there it is. Okay, never mind. I'm just trying to get used to. I have it open in two places. This is hard sometimes, but you know what else is hard? Kubernetes on-prem. So my transition right there. If you weren't paying attention last week, we officially GA'd EKS Anywhere, which was pre-announced at reInvent last year for running Kubernetes clusters on-prem. It takes a lot of the EKS abilities of how to manage life cycles of clusters, really all the best practices that we at Amazon have learned for years and years running Kubernetes at scale, and helping you do that on-prem. And like she said, Vivek is here to help explain a lot of that and go through. We're going to show a demo of it. Obviously, Vivek has been one of the core engineers building EKS Anywhere, and I'm super excited just to have everyone see it. Vivek, why don't you give us a quick intro, how long you've been at AWS, and what specifically, like, was there a focus that you had on the project?
Yeah, thanks for having me here. I was at AWS. I guess I'm at AWS for like a total of 3.5 years or a little over that. So I've been here for a while. I wasn't on the Kubernetes team most of the time. I was on a different team, and then I transitioned into here because I really wanted to get into the nitty-gritty of containers and how AWS operates containers at scale. And what other better place to do it than EKS? So I came across this specific opportunity to work on EKS Anywhere to bring our Kubernetes platform to on-prem. And over the last basically half year, we were working on this EKS Anywhere product, really thinking about the end-to-end on what the user experience is going to be like. And since our main tool to do it is through our CLI, that was the effort that I was helping lead to essentially bring that end user experience as seamless as possible so that you could just, create clusters, upgrade with single commands. And that's what I'm excited to demo in a bit.
Awesome. Pull this out of the way. I wanted to, if anyone didn't know, we did open source it. So here's the landing page for EKS Anywhere. We have, part of this open source project was a lot of just letting people see the project and see the code and run it themselves. And one of the things I'm most excited about when we announced it and we're working on it was the fact that it is fully open source. So it's here on GitHub /AWS/EKS Anywhere. It works on using a lot of existing Kubernetes projects, and we working in the community to really refine a lot of those with how we wanted them to work for customers on-prem. And so, to me, the coolest thing is just you don't have to be an AWS customer. You don't have to have an AWS account. There's no connection requirement back to AWS to try it out, to use it, to run it. Go ahead and do that. It is fully supported by AWS. If you want the support, you can pay for support. You can get a transition from, hey, I have a production cluster. Now I need someone to actually, help me out with this. And that's one of the benefits here of give it a shot. If it works for you, awesome. Use it how we're plugging in things and expanding it. We're listening to everyone in open source on what they need. But then from there, we're just running with, here's the open source, but here's how, if you want it to integrate better with AWS, we have the EKS connector. We have, other authentic, like OIDC is there right now, how we work with providers, all that stuff is coming. So I'm really excited about it. I'm also realizing it's really hard for me to mute my microphone when I'm here on my phone. And I don't know if anyone else is seeing screen flashing. I'm going to stop my screen share because it looks like I'm flashing. We are having some weird stream problems. I saw other people in the comments mention it. So, and because we were a little late too, let's actually just dive into a demo here. And if you had a chance to look at documentation or give EKS Anywhere a spin, let us know, because we want to hear your feedback and what you were working on and what you're trying to do with it. But I also know Vivek has already prepared a couple things for a demo so that we can look at it and really see some of the benefits here for running it.
Yeah, definitely.
Let me pull in your screen.
Okay.
So
yeah,
tell us what you have.
Yeah, so I have a blank terminal right now, but I'm kind of going to walk through how the tool is going to work for EKS Call Anywhere. I have actually created a cluster before to save us time with showing that whole process, but I will be demonstrating the upgrade workflow as well as how you can change some fields through Flux if you have your code in a GitHub repository as well. So I have this terminal here. I have EKS Cuddle installed already. And if you're familiar with using EKS Cuddle for bootstrapping, EKS clusters, you notice some of these commands already. But this new command that we added over here is EKS Cuddle Anywhere. We have a separate command for EKS Cuddle Anywhere just to help, bootstrap the resources specifically to EKS Anywhere, as all the other commands, they're already built from the EKS perspective. So we thought, like, you know, as we're introducing EKS Anywhere, it would be easier to introduce it this way. And if we were to type EKS cutoff anywhere, you can see that we have a couple of commands listed over here for, you know, being able to create, delete, and generate like the cluster resources. So right now we mainly support creating just a EKS cluster that's a managed cluster, and you would also be able to upgrade your cluster. So like the main core operations you do here is create, delete, and upgrade. And we have a generate command here just to make it easier for you to be able to understand what fields you need to configure. For example, if I do something like test -pn, the provider that we're mainly working with is vSphere for your on-prem use case. You can see how this command basically outputs a bunch of configuration for you, where you can kind of modify, for example, what endpoint do you want your control plane to use? What's the count of, like, you know, your external etcd configuration or control plane configuration, and some of the other fields that you would want to specify for vCenter. So one thing you'll notice here is that we have external etcd configuration support, and this is because that's how we operate etcd for EKS customers itself. From an EKS perspective, we give you the control plane, so we handle that management for you. But from an on-prem perspective, we're letting you basically have all those pieces in one location so that it works for you for an on-prem, but in the same way that we set up EKS on the cloud.
And if people are used to EKS control, if you're creating an AWS hosted cluster, there is a spec file that you can use that you can say, hey, I want to create a cluster in AWS. How does that, you know, there's a YAML file with like what type of node groups and that sort of stuff that you need. And this is a very similar model where that pushes that configuration into CloudFormation, which does that sort of reconciling of state to say, okay, this is what we need. And in this case, this is, you know, they have a slightly different spec because it's completely different environments and different tunables of what you actually do on-prem. But the workflow is similar, right? We create a spec and then we run the command to actually do something.
Exactly, that's exactly right. And I actually have a spec of the cluster that I have created already, where I have some values defined, like I have GitOps configured. I have some other like information on the machine config, like the number of CPUs I want, memory MIB. So if you're used to like configuring these type of resources for EKS, you'll see that maybe some of the field names are a little different here, but like for the most part, it's a similar experience of taking a YAML and making resources like available to you. And one major difference that we're doing here is, like you're talking about from an open source perspective, that because we're open source and we're trying to leverage what is available to us from an open source perspective, we actually do rely on Cluster API, which is a Kubernetes SIGs project, to be able to create these resources for us. So like instead of relying on something like CloudFormation, we are creating these resources using Kubernetes, which I can kind of show that workflow while we're doing like the upgrade workflow as well.
Hey Vivek, we have a question.
Yeah.
Is it only vCenter, or do we support it on ARM or any small factor devices?
So we started off only supporting vCenter because that's kind of the major use case that we had for EKS Cuddle Anywhere. We are going to have other provider support as they come. And this is where we want to leverage, our open source contributions and like issues as much as possible. If there's a request that you have, you could just go to our GitHub page, and we have a lot of issues. I think someone has already asked for like Raspberry Pi and some other stuff. So like we have a lot of asks that are coming in. We can only address certain ones based on like the interests that each have, right? So that's how we're kind of working towards like support for certain things. So definitely like +1 on issues, create issues on GitHub if you definitely have some of those requests. But yes, we are starting off with vSphere as support. Yeah, I see another question there too. OS family is Ubuntu. So we actually support both Ubuntu and BottleRocket. And if you're running the generate cluster config command over here, you see how it generates BottleRocket by default. Just for demo purposes, I didn't actually think about this too much, to be honest. I just set it as Ubuntu. So then that's why we have an Ubuntu cluster. But if I had set it as BottleRocket, then we would have a BottleRocket cluster. So it's as seamless as that. Like you would be able to try this with OS family BottleRocket, and it would set it up using BottleRocket.
So would we flip that switch and make BottleRocket as default, or do we just keep it an optional for users to specify?
Yeah, so that field is something that you need to specify. So when they run the generate cluster config and when we're generating default values, we do default it to BottleRocket. But if users want to use Ubuntu, they have to change it to Ubuntu. So for the demo purposes, I just had Ubuntu. Like there's no other reason for it. It just shows that you can do it with both OS families.
And for anyone that doesn't know, BottleRocket is an AWS open source operating system for running containers. We've had a couple containers from the couch episodes on it in the past, but it's not something that everyone necessarily knows. So I'm just pointing that out as well, that this, BottleRocket being an open source OS by AWS, again, it's fully supported by Amazon if you need that support. And it's also very secure because it strips out a lot of things that you typically wouldn't need on a traditional Linux operating system. It's API driven. So go check out the containers from the couch I did last year for BottleRocket if you want to learn a little more.
Yep, exactly. And here I actually I ran the create cluster command to kind of show the options that it had. And our main way to basically create a cluster is based on that file that we generate. We specify that as the file name to be able to create your cluster. So that's kind of how we take the input for the create cluster command. So for the interest of time in terms of the demo, I've already ran this command. And if I go to this other terminal window that I have, when I run kubectl get nodes, you can actually see that I've configured a Kubernetes cluster with 1.20, and it's running our latest EKS distro version for 120. So EKS distro is something that we had actually launched end of last year as well, which is our open source distribution that aligns very well with what EKS is using for their distribution. So it's like if you just specify 120, you will know that you will get whatever is the latest EKS distro version. That's 120.
Right, this is all layers, right? This is like at the very bottom here, we have BottleRocket as an OS that Amazon open sourced, a couple of years ago. On top of that, we actually have the API, the binaries from Kubernetes, which is EKS distro, which is what we run in EKS hosted in AWS. So you're getting the same containers, you're getting the same bits with, if you read the repo, backported patches and some fixes and those sorts of things that we needed inside of our environments. And so EKS Anywhere is just building all these open source tools to package that all together to make it something that we think is good for customers trying to run on-prem. And I saw this question come before about this being a wrapper around Cluster API. And if you're familiar with Cluster API, yeah, exactly. There's a lot of pieces here that this is using Cluster API, the core pieces of Cluster API for a controller and for the spec and CRDs, and it takes a provisioner and ties those things together. So in this case with EKS Anywhere, we're more productizing some of that open source bits to say hey, that's actually a lot of decisions you have to make, and there's a lot of choices around, hey, how do I want to implement this piece? What CNI do I want? What integrations do I need? And in this case, we're taking, we take that best in breed tool and saying this is how you can manage Kubernetes clusters at scale. Let's help customers make some of those decisions and make it a little easier to deploy and use. Because the first time I ran Cluster API, I was very confused. There was a lot of controllers. There was multiple CLI tools. There's a lot of components in it that just, I was like, okay, I could understand this. I could probably, I built clusters with it. But then ongoing maintenance and support became difficult because of all those divergent, integrations and things that were, for me as an operator, were a problem. And EKS Anywhere we're trying to help you make some of those decisions and options. We can add those things, but we tried to stick with what we saw as a lot of people using and what we saw for, just stability and support reasons. We wanted to allow people to do easier.
Exactly, and we have a lot of we basically made a lot of opinionated decisions here to be able to provide some of that functionality. And one of our main, like from a user experience perspective, like motivations is how can we do this all in one command? We should be able to create a cluster using one command. You shouldn't have to run like 10 different commands to be able to create your cluster. Now, with 10 different commands, you can get more customizability, but that's not how we were focused, right? So
the flexibility is great. Cluster API, you can start with the base controllers and go anywhere and do anything you can do with normal Kubernetes. That may not always be the best option. So we really try to, in EKS Anywhere, find the path of best supportability and what we see a lot of people wanting to do. And one other question I saw come in about can you deploy it to pre-provisioned nodes? Let's say I have a rack of servers, they have an OS on them. Can I point this at those IP addresses or those MAC addresses and do that?
No, we don't have that support right now. When we, especially with our vCenter support, we're creating new VMs. We're bootstrapping those VMs and setting them up. And that type of support might be in the future. That's not something that we were thinking about from like a GA perspective.
Yeah, but we definitely hear if you want any of these features and providers and support, absolutely open an issue on the GitHub repo. We're looking at those and trying to see what it is that people want next. We know that we need bare metal supports. How that actually gets implemented is a little bit like how we're actually doing that for customers really depends on that initial feedback. So we want people to give it a try and let us know what they're doing.
Yeah. So here, I actually just ran the get pods command, just kind of show what are all the different pods that are running in this Kubernetes cluster. And you can kind of see that, yeah, we have some controllers that are CAPI controllers running there. We also have an EKSA system controller, which is more used for our Flux use case, which I'm going to demonstrate just now. And then we install other stuff like we have an etcd ADM controller there. We have Flux that we've installed for you, which Flux is also a project that allows you to basically enable GitOps. From making a change from like a Git repo, you can synchronize your cluster with those changes essentially. And we can kind of, I'll show basically how you can do that with cluster management itself. And yeah, some of these other ones are just self-explanatory, like kube system stuff. So here with this, I've actually created 2 clusters. The one that I'm going to demonstrate is this first one that we're showing the pods for. So we can see here for this demo that we have these folders, and under the EKSA system folder, we have this YAML file. And this is the YAML file that we basically used to create the cluster. We went ahead and uploaded it to the GitHub repository in this case. Right now, the only provider we support for GitOps is GitHub, but other providers would come as there is interest for it, right? So if you have other use cases like, oh, I wish this is in like Bitbucket or like some other providers, like that's where we would be able to get that information from the GitHub issues if you're able to add them there. So,
yeah, and there is a question on, I think, what CNI is being used. I think Justin mentioned that's a Cilium because it's not AWS in region, so it's going to be Cilium. I don't think experience differs a lot there, but yeah, it's Cilium for now.
Yeah. Also, I think the question was phrasing it as like what's provided for EKS distro. We don't actually package a CNI for distro. We package it through Anywhere. So that's a clear distinction. Like if you were to just download EKS distro and just install your Kubernetes cluster, you would still have to make a decision on what CNI you need. It's with this opinionated tool that like we decided with Cilium. So here you can see like, okay, I have a count of 3 for external etcd configuration, control plane.
Can you
Make it
pinch to
bigger?
zoom that a little bit?
Yeah. Oh yeah, pinch. That's easier.
There you go.
So you can see some of these other values that we have, like 120, like everything that I basically like showed earlier, right? So I want to make a change from this Git repo where I want to just scale up our worker nodes. And I just want to make that as a code change. I don't want to get into the Kubernetes cluster and make that change, right? So let's just make that change real quick here. So if I edit this file, I go ahead and change this 2 to a 3. And I'm just going to emulate creating a PR. So if a user, someone like an administrator, someone is like, making this change, you can get this approved and view this change. And as you can see, all I'm making is a 3. So for the purpose of this demo, I'm just going to merge it so that you can see that this Kubernetes cluster is synchronized, like this configuration is being synchronized to the Kubernetes cluster. In the meantime, I also wanted to show the upgrade use case, right? So from the created cluster, we actually create this folder with the name of the cluster that you've created. And here you can see how this is going to be changed to 3. So I'm going to change this to 3 for the upgrade use case. And for the upgrade, I want to upgrade to 121. So let me change that to 121 real quick. That's the only real change that I'm making. Here we have some templates defined too. So I'm going to remove this template field because I'll show how it works with not having a template defined. So the only change that's really being made is this 120 to 121 when I'm doing the upgrade case. So now by this point,
Real quick,
the Git repository would have already synchronized the Kubernetes cluster, right?
and that's what actually
So,
I wanted to take a pause on that and just see. So you have two things in flight right now. You have the one PR from GitHub, and because you're using GitOps inside the cluster, you have the Flux controller running. That looks at the repo for changes. And so this is slightly different from what's used to a traditional CI/CD where my GitHub, Jenkins pulls that in or something and then pushes out a config out to some endpoints. And so a lot of people are doing it that way. It's a great model to have that sort of infrastructure as code. Let's get things out there. In the GitOps model, we run a controller inside the cluster that does a pull instead of Jenkins doing a push. And so it's a slightly different model if anyone's not familiar with it. And that was one of the things we pointed out earlier, where this Flux configuration for GitOps, I think I put the link somewhere in here. We worked really closely with Weaveworks to be able to enable this and say, hey, we want to have Flux inside the cluster to be able to allow people to do this GitOps model, because it's literally what Kubernetes is doing with controllers, right? You have controller looking at that API and doing a pull-based method. I also saw a mention here of it's Flux v2, and right now at GA, this is Flux v1, so it's not v2 or something. I forget the name of the new project that is like an overall wrapper for this. And there's also questions about Argo being supported, and not currently. We have Flux v1. We wanted to allow people to start with this model of saying, hey, from a developer, it looks very similar to every CI/CD you've used in the past, where I git commit code and changes happen. But from a security model and from a functionality model, it works slightly different, where we have a controller inside the cluster that doesn't pull. So that was the first change. The second change is actually we want to upgrade the cluster, and you're just resetting that sort of spec to where you need it to be, or where it was going to be from that, so that you can actually show the entire workflow of, we were on Kubernetes 120, we want to go to 121. We already assume that the free node change has been applied because Flux is just really good at doing that. And we don't really have to question, like, is that going on or not, right?
Exactly. Yeah, no, that's great that you were breaking it down. That's essentially what I was trying to do. I was trying to change that worker nodes to show like the count to 3, because I had already made that change. Because Flux, it was, as you could see from how long it took to come up, it took about like a minute. It took time to be able to see that GitHub repository as it's doing that polling to see like whether it noticed a change, and then actually applying it and talking to the appropriate controllers to then synchronize the changes. So now we can see that like when I had described it the first time, it didn't show up, then it's showing up as being provisioned, and then now that node is finally ready. So it was able to scale up to 3 worker nodes.
And I also want to take a little bit of a tangent here to talk about Delboy GG asked if there's anything EKS Anywhere is doing for throughput bandwidth if you're using a direct connect on-prem. And the answer is actually no. In this case, EKS Anywhere is giving you Kubernetes on-prem. So there's nothing specific about EKS Anywhere that's like doing some sort of special connection or looking at like your customer account or region or anything like that. In that case, it's direct connect from your data center into AWS if you're accessing AWS resources. Again, not a requirement, but something that plenty of people are doing. There is an EKS connector, which allows you to see, your cluster from on-prem in the AWS console, but again, it's an optional thing, and that is using a slightly different technology. It's using Session Manager tunnels, but still, if you're going over Direct Connect and it's shared, that is all up to your data center, your ISP, and that Direct Connect. Nothing EKS Anywhere is doing specific for that to manage bandwidth or access.
Yeah, and I guess there are leading questions on how on-prem data being on S3, right? How do we access that? And load balancer controller egress. Maybe Vivek, you'll be covering in the demo, but Justin, I guess we would want to talk about it.
Yeah, I mean, to these points of how that integration works, like the load balancer controller, if you're creating AWS load balancers and you're using it from an on-prem Kubernetes cluster, it's the same things you'd have to do for any on-prem Kubernetes cluster. You need to, the load balancer controller running your account needs to have some authentication to the AWS API. It's not necessarily like a pod-based IAM at that point. It is, some sort of authentication, IAM permissions that you are setting up, and then how you're routing that traffic from the load balancer back down is the same as you would do it for any on-prem server and an IP address. So there are other configurations you need for like opening firewall ports or direct connects and that sort of stuff that is up to you for an on-prem compute environment, which isn't any different with EKS Anywhere versus a standard. If you had a server in your data center and you want it behind an AWS load balancer, you would do all the same steps. And so Vivek, you ran the upgrade command here.
Yes. So I was just running that in the meantime, just in the interest of time, in case so that we can see the result in the end. But essentially, all I did was I had made those changes to the demo YAML file already, right? Where all I did was I needed to change the Kubernetes version from 120 to 121. So this was the file that I had changed it in. So I just went ahead and specified that file for this upgrade command. And you can use this upgrade command not only to make changes to the Kubernetes version, but also some other changes that you would like to make to your infrastructure. For example, through Flux, we don't support the ability to be able to change the control plane count because that's in order to make changes to that, like in terms of like a control plane or things like that, we need to actually move the management out. And what I mean by that is when we create this EKSA cluster, we are actually creating a self-managing cluster for you, meaning all the management controllers that exist, if you instead of having a separate management cluster, all those controllers and stuff would exist in this one cluster, so that you only have to deal with one cluster. You have a single point, like everything's there. Like you won't have like the single point of failure from like a management cluster. And that's kind of initially what we had thought, right, on going forward with. With that, in order to actually perform some of these upgrades, like changing the Kubernetes version or things like that, you can see from this upgrade command that we go ahead and create a Bootstrap cluster. And during the create workflow, we create a Bootstrap cluster, which is a kind cluster essentially, where we install cluster API controllers on it, and we create those VMs and etc. from that Bootstrap cluster, and then move the management over. So that's what we're kind of doing for the upgrade workflow as well, where we're taking that management, moving it back to the Bootstrap cluster, doing the maintenance and like upgrade, and then we'll move it back to that workload cluster. So it's a short-lived cluster. Like it won't actually persist after the command. So some of the things that we had to, yeah.
Oh, just say a couple more questions are coming in. Is this similar to ECS Anywhere? And ECS Anywhere is the ECS control plane lives in Amazon, and you create worker nodes that connect back to that. And so you're able to, from AWS APIs with ECS, say, hey, I want these workloads to run on-prem. EKS Anywhere is a different operational model, like Vivek was just saying. Everything is on-prem. You could, well, right now it's not enabled to be able to do a fully offline, air-gapped environment, but we would like to enable that in the future, where there is no requirement for an EKS or an AWS connection or even an account. Everything runs in your data center. It's a control plane that runs locally. When you need to connect to it, you aren't going outside to AWS APIs and routing back in or anything. You're connecting directly to an IP address on your network, and in this case, in a production environment in vSphere. And that also enables us, when you run the local cluster on your local machine, just like Kind, that API server, the control plane, etcd, and the worker node run locally on your laptop. So you don't even need an internet connection if you have the images pulled to be able to run that. So it's a different model than what ECS Anywhere is enabling customers to do by saying, hey, I don't want to be responsible for the control plane. I just have a bunch of nodes that I want to run jobs on. In this case, it's a fully fledged on-prem Kubernetes cluster that is for you to connect to, but also for you to, or you're responsible for in a lot of ways, where there is etcd that should be backed up, and like access to the control plane, all that stuff is in your environment, and you need to secure it and manage it just like you would any other server that needs some sort of level of security.
Yeah, so some of the things that had happened here for the upgrade command, which is similar to what happens for the create cluster, is we have to basically authenticate based on some of the configuration that you have specified, right? So we make sure that we're able to connect to that vCenter environment. We're validating some of these resources that we have. So these are some of, I guess, like pre-flight checks that we do before running create cluster and upgrade cluster commands. What's different for upgrade cluster is we talked about the EKSA cluster controller, right? And you could always have a situation where you're running an upgrade, but maybe someone's making a change to GitHub and like merging it and etc., right? So that's why we're pausing the reconciliation with the GitOps controller, which are here, Flux controller, so that we don't, any changes that happen from the GitHub perspective would get paused while we're doing this upgrade. It's like it's in this maintenance period, basically. Like those controllers are being paused and we're applying some other changes when running the upgrade cluster. So this create bootstrap cluster, we create this Kind cluster where we install some of these cluster API providers to be able to run some of that maintenance. And this output is pretty self-explanatory here. It's basically moving the cluster management from our workload cluster to that bootstrap cluster. And when we're saying upgrade that workload cluster, we're taking in the changes that you made to that YAML file. We are taking care of what that means in terms of translating it to whatever cluster API understands, and as well as whatever other things that we're doing on top of that, and going ahead and upgrading the cluster on your behalf. So from the user's perspective, the only changes you really need to make are changes to this YAML file and running these commands as a one-time command. There's no other like, oh, you need to, if you had experience with maintain a Kubernetes cluster, like you have to like cordon nodes and like drain and like make sure that you're like handling that maintenance stuff from a very manual process, right? We're doing this all for you in the like a backend, so you don't have to maintain like all that yourself. Like you just have to interface with these commands.
And to your point, also like upgrades, we have to work this way because we want to move that control plane off, make the changes, and then call those vSphere APIs. We do also have plans to enable a centralized management cluster. So you can have a management cluster that can enable and control multiple EKS Anywhere clusters. If you're familiar with Cluster API, that is the traditional design that they have. In this case, we wanted to enable both the small sort of one-off, like, hey, we can do a one-to-one self-managed cluster, or the I have hundreds of clusters, can I manage those from a central team or a central place? And that's what the management cluster would do. And in that case, a central management cluster doesn't do this same bootstrap cluster on my local machine to make a change. You would call the APIs in the management cluster, which would then control the other clusters. So there are different ways of operating here, depending on what you need and what scale you're working at. But we want to enable both.
Yeah. So this is what we currently have right now with that bootstrap cluster that's being created on the whatever machine you're working on. But yeah, that we do have plans for that to basically, especially if you have that use case where you really need to manage hundreds of clusters from a single point, then our CLI would be able to interface with that, so that we can create and upgrade clusters through that cluster. But yeah, that's currently a work in progress.
You know, it's really hard trying to beat Wally to the answer on some of these questions coming into chat. He's on top of it. Can you also, I don't know if you have another terminal. I was actually curious to look at the Flux logs for the change on the scale up. I don't know if it shows when it gets that pull in and what it actually does.
Okay, let's take a look to see what we can find there. So I'm gonna export the kubeconfig here. So it's demo. So I'll show the EKSA controller logs real quick first. So EKSA, in this namespace, we have this controller log. So if we were to do kubectl logs minus n, so this is the controller that we install on the Kubernetes cluster, and basically when Git is making changes, Flux goes ahead and takes those changes from Git and applies it to the Kubernetes cluster, and then our controller takes the reins from there and then makes the appropriate changes to the cluster API objects. So if we do ls here, oh yeah, I need to put a manager. We have a manager. Okay, so now we're in the logs, the nitty gritty like logs basically. You can see, let's see. Where do I'm trying to look for where these logs may come up, because right now, like, the reconciliation is paused here. And when we moved some of the management back to the Bootstrap cluster, then it's like not able to find some of those resources, but it would essentially get resolved once it does. I'm trying to look for where we did the scale. It should be worker count 1, looking up. Yeah, so we don't have like a super clean way of like trying to look up exactly where the count is.
But was the scale done? The scale up was through Flux, or because this controller, there's two pieces in the cluster, right? There's the controller managers from Cluster API that we're also installing to help manage the cluster aspects of it. But then the changes, the actual like Git pull is the Flux controller, correct?
Yeah, the actual Git pull is the Flux controller, which then once it makes the change to our EKSA cluster object, then our EKSA cluster object is actually doing the scale up to like the 3 worker nodes, like we were saying. So that's what I was trying to look for, where our controller was doing the scale up. But we can also take a look at the Flux logs as well. So if we do get pods -n flux system, so we have all these controllers. Wait, shouldn't there be one? Let's see. Whoa, it just paused. Let's see. Is it not? I'm wondering if it's talking to the right cube config.
I'll pull in this question too.
Yeah.
Oops, now I lost the tab. We do have a roadmap and issues. Go ahead and check out the GitHub. I'm going to paste that back in here to the chat. So it's a great place if you have things that you're looking for that you want on the projects. If you're looking for new providers, please add an issue there so we can track just in general like feedback. But we are looking at, I think there is a project on the repo now. It's not fully fleshed out because this just launched on, what day was that? Wednesday. But we're still working on adding new things as we're working on them. So for sure, check out GitHub and get involved there if you want to see features and check status of things. And I saw one more. Where'd it go? Oh, Delboy, GG. I just want to call this out too. Sometimes on-prem static is actually great. If it doesn't need to be dynamic, if you don't have jobs that fluctuate a lot. I know you mentioned you're running ETL jobs for, I think it was geospatial stuff. If you know that scope of those jobs, then I don't personally see any reason it has to be dynamic. I do understand hardware dying. Yeah, that is sometimes a problem when you have to redeploy things because hardware failures. For sure, it is nice for 100% to have things that can, adjust and sort of react to things coming in and out and be more flexible. Dynamic scaling right now, EKS Anywhere doesn't have any sort of auto scaling for nodes. So if you are looking at, hey, when CPU threshold across the cluster reaches some point, I want to add nodes or remove nodes, that's not currently integrated. We definitely have some plans for that. And because this is using cluster API, there are ways to work with the autoscaler and things of that nature to make that work. But right now, we're still trying to figure out how to implement that and make it as easy and simple to implement as possible, because we don't think everyone should have to learn all of the flags for cluster autoscaler. So there's components there that we're still trying to just make them as simple as possible for people to implement and run and support. And those are the things that are typically really hard when you have 100 different choices, trying to narrow that down to say, I need these 3. Maybe you shouldn't have to be an expert on everything in the cloud native ecosystem, but definitely it's nice to have some aspect there of being able to react.
Yeah.
Wreck-It Ralph, what is he doing here? That's awesome. Anyway, F5. Yeah, if you're on-prem with F5, we have a guide on how to implement KubeVip, which gives you a virtual IP address for services inside the cluster. You can use that in F5 and just say, F5, here's my endpoint, please route for this. And F5 actually uses its own virtual IPs. In the past, if you're doing things semi-statically, like was pointed out earlier, you can also run an ingress controller as a daemon set and point F5 to all of your node IPs and say, hey, all of my nodes have 443 and 80 running. The F5, you can put in all those IP addresses, or you can even have a controller or something called that F5 API. There's nothing integrated right now for that, but I know F5 also has some pretty cool tooling around Kubernetes to allow it to figure out where services are running. So look at the upstream docs. We're not necessarily building everything into EKS Anywhere. There's a lot of pieces where we've been working with partners just to say, hey, what's your support look like? If you need storage, if you need load balancing, if you need other things, we don't want you to have to throw away all of your on-prem investments. Lean into those with your vendors, talk to anyone that you've been using support from, and keep getting that support. It isn't like you have to now use everything in EKS Anywhere. No, plug in the things that make sense and use the providers and the other tooling that exists in the ecosystem that'll solve your problems.
And all of the existing cluster integrations and what we suggest and what we have worked with and what we have tested. I just pasted a link, cluster integrations for Ingress and load balancer.
I'm finding that link. Where did that go?
I just pasted. Sending it again.
I know we're also coming up on time. Did the upgrade work?
Yeah.
So many great questions. I didn't even follow up with it.
Yeah, no, it was just doing its thing, you know. But it moved the cluster management back after it upgraded that workload cluster, and now it says cluster upgraded with a nice emoticon. Now if we do kubectl get nodes, all I have to do is change 120 to 121. So now you can see that it's using the latest available for 121 for EKS distro here. And I actually had, and I didn't get to show like the service running before I ran the upgrade. It totally slipped my mind. But I had this like deployment already where you just curl it, and something that Justin worked on. And all it shows like it's showing, it's hitting the load balancer that I had, which I had installed like kubebip on here before after creating the cluster. And we have those docs on the EKS Anywhere docs as well. And it's able to hit the service after doing the upgrade too. So there's no disruption to that service here. But yeah, like that's essentially how upgrade is. I'm like, from a changing Kubernetes perspective, it's just a matter of changing one line and running the command.
Yeah, and that was the workflow we wanted for people. You know, you change the text config, it's declarative infrastructure, and let the actual controllers do all the work. And it's not a human that needs to be in the loop and do those things. So, yeah.
I think quick questions. Add-on support. Any plan to support managed add-ons?
Yes. We would love to. Right now, managed add-ons is mostly core DNS and VPC CNI. And so half of those add-ons you don't need on-prem, or you wouldn't necessarily want. So 100% we're working on a lot of things with add-ons to add more functionality, but also to let you figure out which add-ons you want to manage. So we want to make managing a cluster easier, because there are a lot of things that have to go into Kubernetes on top of, hey, I have an API server. Now what? And we're trying to make a lot of that just seamless and upgrade with the cluster, and be more of this infrastructure as software sort of model of declarative specs that controllers run on. But it does take time to integrate those things together, and to make sure that every environment and every add-on that people want, we can support and give the flexibility people need.
So yeah, regarding that, like add-on support will definitely come based on interest again, right? So if there's any specific add-ons that you would like to get added as part of the cluster creation workflow, like please add those GitHub issues. Like that's what's gonna help us tell us like what is it that people want to look for. Like for example, like we are installing Flux controllers and stuff almost like an add-on in a sense, like that type of the GitOps integration gets installed after the core cluster is actually created. So we do have room to be able to support more add-ons in the future as well as part of the workflow. Ideally, we would want everything to be configured through that cluster spec file, so that it's like Justin said, declarative configuration, so that everything is just there at the very beginning, and then you just run the create cluster and everything should just show up as expected to you. So yeah.
Thanks everyone for joining. We do need to close out because there's another stream after us. I will say there was a couple questions in here about like logging and monitoring, how to get updates on like what's happening for EKS. Follow here on Containers from the Couch. This is where we talk about most of the new services, new launches, new features. This is a great way to stay informed on AWS and EKS specifically, and then also follow the AWS Containers blog, are kind of the two places that I think most things come in with information. On here on the channel, we really try to show off, you know, what we're working on and show demos of it. Vivek, you did a great job showing both those use cases of, you know, deploying and upgrading things. So, but yeah, that's my best, like right now, there's a lot of places to get that news. We really try to focus on EKS containers, AWS here on this channel, and then the containers blog is another great place. So I think, yeah, we need to wrap, but thank you everyone for coming. Feel free to reach out, leave some comments. I know all of us are looking forward to hearing feedback on GitHub and what you're doing with it. So have a great rest of your day, and we will see you later. And once I find the actual video for Countdown, there's the outro. All right, bye everyone.
Hey, it's Adam and Brent, and we wanted to let you know that if you're looking for more live or on-demand container content, you should subscribe to our YouTube channel.
Head on over to youtube.com/containersfromthecouch and also check out our website at containersfromthecouch.com. Thanks.
Thank you. Good?
Yeah, I think that was
Feel good about it?
Yeah,
all right.
Feel pretty good.
I'm going to end the broadcast.
Hello. Welcome to the much awaited and anticipated Infinidash live stream. I'm so excited for everyone that came. Thank you for watching this video. In the chat, go ahead and let me know where you're at and what you're looking forward to with Infinidash. And I'm just so excited to be able to talk to you about it today. This is going to be amazing. So for this show, it's a little different than our typical Containers from the Couch. Yeah, the legacy logo. I know, right? Like when it was in beta and I saw the logo, like we had to use it. So I wanted to bring that in. But this show is a little different than our typical Containers from the Couch. We usually show you, like myself, Brent, Adam, a couple people from AWS are talking about some of our services, teaching you a little more hands-on in some ways. And this time we actually really want to talk about just the service itself. And I have a very special guest with me today. Corey Quinn has decided to grace you all and myself with his presence and to really dig into what Infinidash is, how it can meet all of your service needs. So let's go ahead and bring Corey into the stream. Welcome, Corey. Thanks for coming.
No, thanks for having me. It's always nice to come here and show up and more or less talk about services that I halfway understand and I can bluff my way through the rest. The actual real understanding here is actually mostly done by Ethel, the dog behind me. And I want to be clear, just like a lot of AWS services at general availability are usually like aspirational versions of what they hope to be. In the same way, Ethel is sort of the aspirational version of what an actual dog is.
Nice. And I was going to say, like, with Infinidash is very much part of the AWS principles with being customer obsessed. And we work backwards from customers to be able to design this new service. And I'm pretty sure I saw the new service or the new principles being added this week. And was one of them own a dog? Because I think that's a very Amazonian thing to do. And I don't know if it got in there or not, but I saw it was in a draft.
We're sort of nose and nose right now because I did a whole thing a few weeks back that there are 17 ways to run containers on AWS. There are only 16 leadership principles. Containers are still winning by a nose. But again, in the fullness of time, I'm sure there will be more. And Infinidash is a terrific option to get them to parity.
Right. And I mean, Infinidash bringing all of those container native services along with serverless and cloud native and infinite web scale is just going to be amazing for so many use cases.
Yeah, what I love about, in seriousness for a second, what I love about the entire joke is that AWS has this whole spiel where they work backwards. They'll start with a press release and then work backwards how they divide projects. We have to go back further. Forget the press release. Now, let's start with the customer and community enthusiasm and everyone's talking about it. Then you go back and write the press release. Then you go back and go through Amazon's normal process. I think that is the missing piece.
Yeah, I think there's a lot of improvements that are brought into this process, and being able to work backwards with that is. I'm loving the comments. I'm trying to keep up with some of them. And really, yeah, I mean, Lambda events, of course, like it runs pretty much anything we want in this makeup service, which is the key, because it is everything to everyone and nothing to the people that don't want it. So that's really the goal here of being able to talk about this.
Exactly. People are putting what they want to see into this, and that's valuable and that's important, because it's sort of like religion. People take out the bits and pieces that they want. Same story with this. And what people are saying about the service is often a microcosm of their entire approach to AWS services, launches, things they like, things they don't like. There's a case study in here somewhere. I'm not sure whose, but it's buried in there.
Yeah, and even just going into some of that like groundswell of commotion and talk about it, I wanted to bring in a couple of like things that even I was kind of amazed about. Where Werner, our CTO at Amazon, it's launching today. Infinidash's GA event is today. He's his time watching in between this halftime of the football game, and we want to do this live stream just to be able to get people to understand what it is and what it isn't, and really ride that wave of being able to talk to people about it. And if you didn't know, the redash is also scheduled and planned for, I think they said Q5. So whenever that happens this year, I think that's somewhere in post-pandemic time.
I can't wait to tear the sponsor's prospectus apart on that one. It's going to be amazing. I also would like to point out as well that Monday is Andy Jassy's first day as CEO of Amazon. Has Adam Selipsky taken over the CEO role of AWS yet, or is that a simultaneous thing? I haven't seen either way. If you can't say, that's fine too. But I just, in my own head canon, what I'm seeing here is like day one, he's at his desk. So why is every customer raving about Infinidash? What is that? And the answer is going to have to be an for Christ's sake, because it is absolutely bizarre and surreal in a bunch of ways, which is my biggest regret about it, is that I didn't start this nonsense. People are attributing that, and I'm trying to pass it back as fast as humanly possible. But Josh over at Twilio was the genius behind this. Sorry, Joe Nash. I'm trying to condense and drop letters out there. It's a compression algorithm. There may not be a compression algorithm for experience, but there is a compression algorithm for the letters in the middle of Joe Nash's name.
we can compress whatever we want. Yeah, we can compress anything except for time. So
yeah, you can compress anything except getting it back out intact is a separate question.
And I mean, from the comments here, like everyone is on board and wants so many of these things to exist. And I love that, like this was able to carry itself with books, with conferences, with there's actually a very important one here. Where is it? The Infinidash swag, which is honestly amazing. Any of the proceeds here, I'm going to drop a link to this in the chat, but this actually proceeds are benefit to a youth LGBTQ plus organization. So highly recommend here if you want some Infinidash swag. There's that.
And who would not?
Yeah, I mean, this is just,
now, of course, we have the competing logos. That's the challenge. The one that I'm particularly partial to is they already put up about their stickers on the way. This is going to be fun. The real question, of course, is how long of a life cycle does this have? In 2 weeks, are we going to say Infinidash and no one's going to know what we're talking about? Let's face it. In many cases, and this actually highlights a point I've been making for years, that we have long since passed the point where I can talk convincingly about AWS services that don't exist and not get called out on it by AWS employees. It just never occurred to me to actually try to do it publicly. I thought that was the joke. No, do it. It's better.
Yeah. And I mean, I work here for a little over a year at Amazon, and it's so big and there's so much stuff, but as a customer before an enterprise, like you want to use all those things. And to this point, like, yes, CloudFormation, Terraform, and Pulumi support are all coming next quarter. It always are. So it's fully supported in Infinidash next quarter. So it's on the public roadmap. Of course, it doesn't
support tagging at launch, because why would it?
Yeah, well, we're working on that. It's definitely going to be prioritized. So if you haven't, also people watching the stream, one thing that we don't typically get with some of these launches is these amazing videos and theme songs from any service launch, which is just phenomenal. Sai and Elle and Forrest all did great Infinidash videos that I'll post the links here in just a second. But this was all like just amazing content to be able to see like what people are excited about and then how people learn and how they latch onto things and then be able to produce their own content to say like, this is how I want to use the service. This is what I think this should be, and explaining it in very entertaining and creative ways.
And again, if people wind up missing the Infinidash launch, that's fine, because they'll be able to do it all over again in 8 years when it launches in GovCloud. One thing that I did that I thought was fascinating that came out of this was I used GPT-3 from OpenAI to generate a whole launch blog post on this. And it decided that Infinidash, it is a sort of a wrapper that interfaces with step functions like dash, step. Oh my God, they're better at those cutesy naming things than some marketers I know. And it took a developer advocate and promoted her to the GM of step functions in the bio. And this thing's incredibly convincing and almost eerie. It was a little incomprehensible, but let's be honest, let they who have not seen an AWS launch announcement that wasn't slightly incomprehensible cast the first stone.
And I mean, to that point, with GitHub Copilots being able to write some of this, Infinidash is actually, a full no-code solution. So it fully, GitHub Copilot fully supports it in a no-code solution, so you don't actually have to write any code. And actually deploys with AWS Copilots into your environments, and you can actually track your finances with Copilot Financing, which is another tool that all share the same name but work great together to be able to figure out how to use the service and what people want.
I'm looking forward to seeing what people build with it.
I mean, at infinite scale too, right? I mean, that's the whole point. There is no limit here, and this
the only limit is your mind, and also, let's be realistic, your budget. Everyone has a credit limit somewhere.
It's true. I mean, unless you're printing money. I mean, I don't know. Like if we make
sure that's called Bitcoin.
That's what I was gonna say. That's where I was going. You jumped ahead.
Too easy. You telegraphed too much.
Yeah, I'm sorry. Sometimes we hit the same wavelength, and it is unfortunate. That's when I have to really make sure I go back to being customer obsessed and not Corey obsessed.
Yeah, someone was asking, I think it was Matt Stratton, that he heard that this was written completely from Copilot suggestions. Is there truth to this? Look, machine learning is very clearly bias laundering. When now with things like Copilot and the rest, you have GitHub Copilot, to be clear, disambiguate there. It's very clear that instead of laundering bias, it's laundering our shitty code and providing plausible deniability. It should not, instead of GitHub Copilot, it really should be called Git Blame the Computer.
And I mean, for real licensing concerns around that, right? Like I keep seeing those topics come up of like, having worked at multiple enterprises, what is that license that I just auto-generated from a machine learning model that I don't control and I don't know where it came from? It's amazing.
That's that right on the screen. There's a logo I was talking about. Yeah, I mostly stay out of the open source licensing debates because there are serious concerns there. Don't get me wrong, but it also primarily feels like it's a place where engineers get to cosplay as attorneys, and that doesn't always go super well.
Yeah, I only tangentially been a part of it at multiple companies, and I am not a lawyer. For Oren here, if you look for, actually, this is interesting because the first open source version of it was No Code by Kelsey Hightower. So if you're looking up, anything that's along the same lines as Infinidash, No Code is a great place to start.
The real question, too, is how this is going to go over within AWS in some interesting ways. For example, when reInvent happens and people wind up working references to AWS Infinidash, and they're like, oh, you're not allowed to mention, like usually they have slide review where they're talking about AWS versus Amazon at the front of a service name. They're super interested in that. They're like, oh, you're not allowed to, you can't talk about Infinidash. It's not a real service. The only correct response is, yes, it is. And it really comes down to whether it gets into the slide or not. How convincing are you? That's my operating theory.
It's all about that confidence, for sure.
Oh, yeah. Joe and I have announced that we are going to be giving a reInvent talk about AWS Infinidash. And I feel like Twitter was concerned or misled into thinking that we were kidding. We are not kidding. We will be giving a talk on Infinidash. I don't know how yet, but it's going to happen.
I'm wondering if we can get it on the CNCF roadmap. I mean, that would be pretty cool to like the landscape. If there's an Infinidash funded startup, we could get logos and some content for too.
How many things are on the CNCF landscape right now?
More than AWS services. I know that for sure.
It was over 400 the last time I checked. One of the best viral tweets of our industry that went out was just a screenshot of the landscape, and the only caption was "Jesus Christ," which, yep, pretty much. It is one of those overwhelmingly complicated things. I guarantee you that we could be convincing enough to get a small square assigned. Now, the real question, because everyone sees what they want to see inside this fake service that's rapidly becoming real, is which part of the landscape does it belong in?
All of them. It's just that vertical scale of, it's actually that, crossing borders, or we can put it in just, a little piece in all of them. But I think just one line through all of them would be great. And also, like, have you actually seen the product marketing, like marketing landscapes? Those are terrifying. Those, like, I think there's 400 in CNCF, but those are thousands.
I've seen some with thousands on them. Yeah, it is.
Yeah. And it's just like those, like, data management, big data marketing. I'm just like, okay. Like, I get where this is going, and how do we backpedal? That's
there's some great ones out there. Like the Deloitte's Agile Landscape thing is very similar as well. It looks like a subway station or a subway system map.
Connect all those dots with the different green lines and whatever way you want to go.
Yeah, and I want to be very clear here. These things do have value for their target audience. It helps disambiguate a whole bunch of things and see how these things play out. But devoid of that context, you look at it and it looks hilariously bad. Because, yeah, it turns out if you dress something up and put it in the context it doesn't belong, and everything looks ridiculous. And from that springs humor. I want to be clear here. I'm not trying to dunk on people's hard work this time.
And people are very good at visual, spatial, and pattern recognition. And it's not good by taking a bunch of obscure names and then saying, oh, that's what that does. And being able to connect those dots of something you're familiar with and then connect it to something else that you're not familiar with. You can automatically have understanding around what that thing is and what it does. And grouping those things into physical locations helps in many ways. And not even just like on a picture, but I mean, you think, like, physical in your house. Like, I can tell you where I put down my pen because it was in a place where I put my pens, and like that's like in my head ingrained, and I can do those sorts of things. And it's just amazing how the human brain works.
Or doesn't, as the case may be.
Yeah, it is hard sometimes. I mean, you have to balance that line. And so, I mean, this has been great. I do want to show off the live demo we have prepared for showing off Infinidash, how it works and how people can get started with it.
Things always launch in Oregon as well, which is a good thing to know. There are some regions that are a little late to get services, but Oregon and Virginia and Ohio are the same pricing tier. They are generally day one availability. It's always day one. Yeah, it feels like that sometimes. It's the Groundhog Day one, and that's great. But it's useful to know what region you're in. I also just want to point out how much I adore the fact that your system tells you which region you're in. I suddenly feel the burning desire to add that to my shell prompt. I'm stealing that idea, not even slightly kidding.
So actually, this is directly from Starship is a command prompt generator. So I have some aliases to do sort of this stuff for me. So if I have a demo, I have AWS P for AWS profile, will automatically drop me in my demo account. So I have a demo there as that's the AWS account I'm on, and that's the region I'm on. So this is all Starship.
I have a lot of very similar things too that I built myself from scratch. So if this is, sorry, I didn't mean to derail this into actually something that has content in it, but we will talk later, and I'm going to explore that mightily.
Yes. So and for anyone, like let's just AWS Infinidash. Sorry, my keyboard's so loud. It's how you know I'm a programmer. We have just the basic, standard help that we always get from any sort of Infinidash program. So, and like we were saying earlier, full, like it's having CloudFormation, AWS Copilot. It's no code. So I'm actually in a repo that I haven't written any code yet. I can post that config. I have it in my dot files. It's not oh my ZSH. It's let me look up Starship. Starship RS. That's what it is. I'm gonna post this in chat. As soon as my computer catches up, whenever I screen share, everything is slow. And now I gotta get back to where StreamYard went. Here it is. This is the prompt I use. I've done all sorts of different things in the past of custom prompts, and this one's fast. It supports a lot of things that I want out of the box, and I'm building to the demo. I know it's all suspense here for you. So, but people want to ask questions, and then always good for yes, I am always good for a ZSH promo. That is me. Yes.
Same. Although I don't use it by ZSH. I use something that is 15 years old, and I've been iterating on it manually for that long. Is it well written? Absolutely not. Do I use half the stuff in there? No, but I'm too deep to quit.
Yeah. So you getting those ingrained. Why do you pick the tools you pick? Inertia. That's day after day of just doing that thing, and that muscle memory is hard to break. That's for sure.
Oh yes.
So I actually want to make sure that everything switched over here. Just a second. So here's the demo. Whoops, that's not it. It's Infinidash. We only have one command because that's the only command that Infinidash needs, and it's deploy. And so, like I said, I don't have any code here. This isn't in a repo of things that I spent all week writing. It was just launched today. So I'm running this command for the very first time today to show everyone just what Infinidash can do. So. That's it. And that's the demo right there. I mean, it works out of the box, it deploys, and it's actually a globally available service. So that's all there is to it.
Excellent. And remember, if you don't understand anything about Infinidash, that is almost certainly because you are not good enough at the computers yet, and you should feel bad about it. That's right. That is the implicit statement every time someone doesn't get something. I do wish to reiterate once again, the service is not real. It was made up as a joke, and it has taken on a life of its own.
Yes, and we thank you all for joining the live stream, and we hope that you keep finding all these amazing services and community around them, helpful, and don't feel bad if you don't get the next service when it comes out. And
I thank you all as well for assisting us in bullying AWS into building a service they had no intention of building whatsoever, but they say they're customer obsessed. Well, now is the time to prove it.
I guess that's what we have to do now. So I probably have some PR fact reviews to go look at after this. So thank you all for coming. Have a great weekend and enjoy. Hello. Hey there. So welcome to Containers from the Couch. For those watching us today, you may see a new face here, and it's not just mine, but it's Peng Hao, who is I won't do too much of an intro because I want to let him introduce himself, but he's doing some really cool things on the AWS Copilot team. So Peng Hao, why don't you really quick just do a quick intro and say hello to our beautiful audience.
Thanks, Adam. So I'm Peng Hao, and I'm on ECS DevX team. And right now I'm just working on Copilot. Nice to meet you all.
So, we've done quite a few shows on Copilot, and today we're going to use Copilot as a tool for ECS exec, which we'll talk about in just a moment. But we're also what we're going to do is we're going to demo how to use ECS exec. What is ECS exec? We'll talk a little bit about it. And we'll demo it in two ways. So one will basically use ECS exec to interact with a container running on AWS Fargate. So if you're familiar with Fargate, that is basically a serverless abstraction way of running your containers in AWS. So you don't manage the underlying virtual machines, patching, maintaining those, securing those instances. You don't have to think about that with Fargate. So one of the big asks from our customers prior to ECS exec being released was, hey, there are times where I need to actually enter the container to do some troubleshooting. And, generally, in this space, when we talk about running containers, when we're running them in production, one thing we generally advise is you shouldn't be doing that, right? You shouldn't be just execing into your containers, running arbitrary commands all the time. Frankly, it's not a great practice because, of course, you can do anything in that container and you could open up the doors to maybe potential bad things happening. So with ECS exec, though, of course, there's going to be the time where something goes wrong and you have to just get in there. Logging, metrics, everything you have is good, but you need to just get in there and see what's going on. So we have a really cool demo that Peng Hao built, which is going to basically, I won't give away too much, but we're going to exec into a Fargate container and we're going to interact with a little database and do some cool stuff. So prior to that, maybe let's start with, well, first of all, hellos. So, hey, why is Bob not allowed? And good evening, good morning, and good afternoon to all the different time zones that are watching us. We always appreciate you. Okay, so first let's talk about ECS exec. I kind of did a little brief overview on it, but I'm going to go to my screen share here and let's just talk through what that looks like. So I don't have Brent today, so I'm relying on my technical expertise, which is not as strong as his when it comes to this. So this is our documentation page for ECS exec. So essentially, let's see, I'll link it here so you can see it in the video. But ECS exec is a way to interact with your containers without the need to open up ports, enable SSH. You don't have to think about those things anymore. So in the past, prior to us releasing this feature, if you needed to access a container that was running on EC2, remember with Fargate, that wasn't even possible prior to this release. You'd have to enable SSH, which means you as the person or team managing this environment have to control SSH keys. You have to think about securing them, rotating them. Also, you have to think about, opening up ports to your EC2 instance, right? Opening up SSH, which just frankly, it opens the door for just someone to try to start trouble. And aside from all that, you also have to, when you have SSH enabled on your servers, someone's actually accessing that server and has access to the underlying host. So now I have to think about securing the host, securing my users, ensuring that they can only do what they need to do when getting in there. So there's a lot of complexity and a lot of thought that goes into that. So with ECS exec, there's no more worry about that. So you don't enable SSH. You don't have to open up port 22 to the world or to your corporate VPN or your corporate network. All the communication behind the scenes is done through AWS SSM. And that's all documented here in our documentation. But essentially, when you enable ECS exec for your tasks, behind the scenes, the ECS is actually bind mounting the SSM agent and all of the components needed to make sure that when you want to exec in, that the packages are there, the software is running, without you having to configure that in your container image prior to deploying it. Was there anything else you wanted to add to that, Peng Hao? I kind of just dumped everything.
Yeah. In order to enable this feature, actually, you need to, if you use run task API, then you need to specify the to enable this feature. If you run it through the service, then when you create the service, you need to enable this feature so that the container will have the SSM agent up before you running the execute command to SSH into your container.
That's a great point. Yeah. So if you had a task running today and you didn't enable ECS exec when you launch that task, you wouldn't be able to exec into it. So at the next task launch, you have to make sure that you have the proper IAM role policy set up. It's attached to your task to ensure that it can talk with SSM and so on. So that documentation that I linked here, check it out. And during my demo, I'll also show off some of the, I'll show you some of the different things you have to do to get it enabled. So with all that said, I just did a lot of talking, and frankly, we're 8 minutes in and it's too much talking. Let's get into a demo. So Peng Hao, we'll start with you. Why don't you talk about what you're going to demo today and show us how cool it's going to be?
Okay, so first of all, let's give a little bit background knowledge about Copilot. So Copilot is a open source command line interface that makes it easy for developers to build, release, and operate production-ready containerized application on Amazon ECS and AWS Fargate. So we're dedicated to provide a superb end-to-end experience for our new and current ECS customers. Like, you can get your application deployed and manage them with ease. In the meanwhile, we also make it possible for you to extend or customize your application infrastructure. So let's get started with an example where we have a web application, web application, and we want to have it talk with a RDS Aurora database. So what are we gonna do?
So Peng Hao, I just want to add. I think, to put it simply, when it comes to when you want to run containers in AWS, no matter what, there's things you have to think about when deploying your containers. If you're using ECS, right, you have to think about just getting a cluster, setting up IAM roles, policies, building a load balancer if you're going to have a load balanced web service. Copilot simplifies all of that. And I think personally, my favorite part about Copilot is the guided experience, which makes it even simpler. So when you start, Copilot walks you through by asking you a couple of questions to understand what type of workload you're deploying, and then Copilot does the rest. So
yes, exactly.
It gives me the warm and fuzzies inside. So
yep. So let's start with Copilot app init. So basically, this command will create a Copilot application. So application can consist of multiple microservices. It's a collection of them. So let's create one. So for simplicity, I already create those resources. So we have an application named Couch Demo. And then after that, we're gonna create a service. Remember, we want to create a like a web service that can talk with the database. So we can call the Copilot service init. So we're gonna choose this one, and then we're gonna just name it hello. So this service has already been created, so this should take real quick. I'm gonna just use the local Docker file. What this application do is, what this service do is actually just gonna grab information from the database and then show it on the on the page. So let's take a look at what we have in the manifest.
And so Copilot, by the way, you initialized your service. It asks you what type of service do you want. How do you want to name it? And then it actually looks through your directory and says, is this the Docker file you want to use to deploy your container, or to build your container image? If not, you can also define where it is. So again, it's doing a lot of the work for you. You just have to answer some questions.
Yeah. Normally we'll ask you more, but it's just for simplicity, I already created those resources, so it won't like ask me those questions again.
Yeah, makes sense.
Yeah. So here's the manifest file. So the manifest actually contains almost all the configuration that you can configure for your service, like the image location. You can like add and put. You can either put the local file, or you can use your own by specifying there's a location field that you can specify. And then we have a CPU and memory configuration for it, and the count is this one just means how many copies, like how many tasks do you want to run in the service. And this is important. So exact true by default, when you create a service, we'll put this line by default. But if you don't want to get the exact enable in your service, then feel free to get rid of this line or just specify this one to be false.
So that's it.
Yeah.
So with Copilot, to enable exec, I literally just say exec true. That's it.
Yep, that's it.
Wow.
And then in order to deploy the service, we'll have environment. So environment actually means the stage of your service. Like you can deploy your service into the test environment or prod environment with some different configuration. Like you can specify the override here. In your manifest, for example, like tasks, you want to run 2 copies, but the prod maybe you want to run 6 or more, or have auto scaling in them. It's also possible. And then after that, I'm gonna show you how to create a Aurora database. It's actually an add-on in Copilot world. So if you do Copilot storage init, you'll create a under the hood, it will create a CloudFormation template, and then when you deploy your service, it will be deployed as an add-on stack, as a nested stack, and then will handle all the things that you need to make your service or make your container talk with the database.
So basically, again, Copilot's just simplifying a lot of the complexities with building your database. Then, if you need IAM roles or if you need security group rules, it's handling all of that for you.
Yes.
And so here, with the storage init, there's the 3 options: DynamoDB, S3, Aurora Serverless. This is just super cool.
Yep. I'm gonna demo later. Like you can without the access. For example, we have a security group controlling the inbound traffic through the database. So actually, it's not possible for you to talk with the database without executing into the specific container.
Nice. Very cool.
So what would you like to name this database? I'm just gonna name it with storage, my storage. And then we're gonna use PostgreSQL. And then what would you like to name your initial database? Just a random name, initdb. Okay, so we've created this before, so it will tells me like this YAML file, this CloudFormation template file already exists. But like if I didn't create it before, it will prompt me to like it will output the secret name that I need to inject into my code in order to do this. I'm gonna show you real quick how we're gonna use that in our service. So this is my the front end service. We can get the secret from here, and then all the information here to connect to the database, and the web page will just show the content of this table.
And so, it's common in containerized, workloads to, source secrets from environment variables. Can can you tell me how that? So I saw you were grabbing it from an environment variable.
Yeah.
How does that get set up?
So I'm gonna show you later because I need to deploy my service so that we can have that secret, right? But to answer your question, it's actually stored in a secret manager. So and the ECS will handle all about this if you just inject into the ECS. So it will allows the container to get the secret from the secret manager. It's automatically handled by ECS.
That's fantastic. And Copilot. So when Copilot builds the database, does it automatically give me that secret as an environment variable?
Yep. Like I said, the database, the Aurora database is created as a nested stack, and then it will output the secret as an output, and then in the main stack, which is the service stack, we'll reference that when we create a service.
Fantastic.
We'll reference the output. So here we're gonna just deploy the service. We're gonna just do service deploy to deploy the service to the. We need to create an environment first. Sorry about that. So as I put before, environment is actually means the stage of your service. So we're gonna just create a test environment with a profile, and I'm just gonna just use the default setting.
And by the way, I'm sorry. Go ahead.
Yeah, since this environment has been created before, so it should take real quick. But normally it would take about 5 to 6 minutes to create that environment. It consists of the VPC and then the load balancer. But it won't create a load balancer unless you have a real web load balance web application web service deployed. So it's the load balancer will be deployed when you deploy your when you deploy your service instead of creating the environment.
That makes sense. So you're not sitting around paying for idle resources being unused.
$16 a month.
Yeah. And I just wanted to say, so, we're kind of going through, maybe moving a little fast on some of these Copilot things. We have other shows. If you just go to youtube.com/containers from the couch, we have a lot of shows where we actually dive really deep into Copilot and go through it. So just wanted to share that as well.
Okay, so since I've already deployed my application, my service to the environment, so now I can do Copilot service show to get the information of my service. Like Adam, you can see the secrets here. We have a my storage secret. That's the output of the like the nested stack, which contains the Aurora database. So it will output the secret here, and then in your service code, you can just reference that. This will actually show up when you do the storage in it, but since I've already done the storage in it before, it doesn't output that. But typically, this secret's name will be print on the screen and prompt you to use that in your code.
And also notice, though, that it's value from. So ECS has native integrations with Secrets Manager and SSM Parameter Store. So what we're doing here is we're not exposing that secret in plain text to your in your task definition. So you don't have to worry if someone runs Copilot Service Show like you just did, that I'm going to be able to just see this secret in plain text. I'd have to actually have access to Secrets Manager to see that. So just, another, again, little thing, but this is, thinking security first.
Yep. And then we can try to, like I said before, we can try to get connected to the database that we created before to see if it works. For example, if I just do PSQL and then with the whole endpoint name and then the port number and the username, password, and DB name. And then the password, I'm just gonna type the password here. We'll reject the connection actually because it's not like because we are not in the container yet. So this is controlled by the security group. It takes a little bit of while, but
yeah, it'll time out eventually here. And while we're waiting, there was just a question from Ramya Raj. How is ECS different from EKS? How do they compare in terms of running apps? Are there specific apps that are more suited to run on ECS? So really, I think it just comes down to the flavor of CLI and how do you prefer deploying your applications and deploying your containers. They're both container orchestrators that can run at high scale. It just depends on your preferences. If you're familiar with Kubernetes, just using Kubernetes and Kubernetes terminologies and the APIs, EKS makes a lot of sense. If you're more familiar with AWS APIs and you want to stay more native in the AWS ecosystem by just using AWS APIs and so on, ECS makes a lot of sense. So both highly performant, just depends on the use case and what you prefer.
Okay, we're gonna not wait for it. We're gonna kill it, and then let's take a look at the website. So, hello world, and if you put I already put some data into the database.
Maybe zoom in a little bit.
Okay, sure.
Perfect.
Students.
And then while you're waiting on that, another question came in from Venu. And forgive me if I mispronounce your name. Can we use this Copilot in production workloads? Absolutely.
Yes,
so
absolutely.
Yeah, Copilot was GA'd. When did we GA Copilot?
Last December. Last November.
Yeah, but you go ahead and answer the question, Pengo, please.
Yeah, you can definitely use Copilot in production. Like we have right now, we already have a lot of customers using Copilot, like hosting their website or etc. Like over 100 of them. So like 100 of a stack, as far as I know. But yes, yeah, the quick answer is yes.
Yeah, definitely. And look, we're building it with good practices in place. So I would say if you're new to ECS or you're even relatively new to containers, Copilot is going to help you get a production ready workload up and running in minutes. And I know I say that, but test it yourself. You'll see what I'm saying when you actually deploy it on your own.
Thanks. So yeah. So the website, so the web application is just gonna grab the data from database and show it in this web page. So I'm just gonna go ahead to execute into the container. Let's say if it just has all the students' name here, right? Let's say if we want to split the name into the first name and the last name, create 2 extra columns for that. Then we're gonna just go to the container. For example, like we can do Copilot service exec. Okay, so looks like we need to have the session manager plugin installed in order to do this. That's expected because you'll need a plugin in order to do the execute command. That's also required if you use AWS CLI instead of Copilot. But Copilot will help you to install the plugin instead of going to the website and follow the tutorial. Copilot will do it within just one click.
Again, that guided experience where you're missing something, Copilot's going to catch it and help you out.
Yep.
So
okay,
cool.
It's installed, and then we're already in the container. So let's do ls, and then it will show the list of all the files. And then of course we can do the PTSQL thing to get ourselves connect to the database. Okay, cool. This works. And then let's take a look at what we have. We have this table, and then we have user ID and then name. So we can do this to create a first name column, and then last name column. And then we can update the table like this. Okay, let's take a look at the website again. Boom.
Nice.
So this is how we can do to, to execute into the container and then add some data or modify the table. Yeah.
So, obviously, I feel like again we should just say like, if you're running in a production environment, realistically, you shouldn't be, modifying your database on the fly.
Yeah, for sure. But yeah, it's just maybe for debugging or if you really want to, make some change. But apparently that's not very typical, and you should be careful about the role that you assign to have the permission to do this.
Yeah. So, just things to, be careful. Obviously, this should be used just for troubleshooting purposes. If you have any type of, mutations on the database, let's add them to your pipelines and let's automate that. So,
okay, I noticed a question. Can we push the container logs? Yeah, that's a good question. Actually, by default, we will just push our log to the CloudWatch. I can show you here, for example, if I can quit this and then exit the session. And then if we do Copilot service logs, it will show us all the logs of this service, like the exact log along with the service log itself. But if you want to configure to push to the Elasticsearch, I'm not sure if you are familiar with FireLens, but Copilot actually integrates with FireLens. Like you can have configure in your manifest, so that you can use FireLens to push your log to S3 or Elasticsearch or even Datadog if you like. Please visit our website. We have a page for that.
Yes, I'm actually finding that right now. So here
Thanks.
we have on sidecars.
Yes, it's on the sidecars.
Perfect. So yeah, quick answer is yes. That's awesome. So let's see. Another question came in. So how easy is it to run a query on your DB from the CLI? Well, so just remember, it all depends on access and all that. But in this instance, this front end service talks to the backend Aurora serverless database. So Peng Hao was able to run his queries, modify the database, and do what he needed to do.
Yeah, so I think that's it for my demo. To be honest, the execute command itself, like Copilot execute, it's very similar to the real, if you use AWS CLI, you do execute command. It's pretty much like it, but again, like Adam will show you how to do exactly in EC2 instance without Copilot. The real trouble is is how you configure those IAM role and the other setup instead of the execute command, the API itself.
Yeah.
So I'll hand it over to Adam to show us how to do the EC2.
Awesome. Thank you. That was a really, really awesome demo. Mine's not as cool, but oh boy, this got super big. Okay. Let's bring it in a little bit. Okay. So I like to say, Copilot is really the easy way. It's just an easy button. You get your containers deployed. If you want to exec into them, you can enable exec in your manifest, and boom, you're ready to go. So for use cases that are, maybe a little more, I don't even want to say advanced, that are just different, where you want to run EC2, and there's many reasons, some reasons why customers want to run their containers using EC2 instead of Fargate. But frankly, I'd love to have a conversation, because Fargate is really incredible. But so in this instance, there are some prerequisites that you have to have in place. So one thing that we didn't mention was the ability to log commands that are actually run on the container using exec. So because the integration is built in with SSM has the ability to actually log all the commands that whoever it was that exec into that container ran. And so you can log them to CloudWatch logs, or you can log them to an S3 bucket. So, from a security perspective, I've said 100 times today, we really exec only when you absolutely need to. Don't make it just a regular practice. But if somehow you want to have controls, you use IAM to control who can exec into a container and who can't. But also, if you want to have the ability to see what that person ran when they were on the container, you can do that as well. So I first want to give a shout out to Pahud. If you're not familiar with Pahud, he is a developer advocate in Asia Pacific region, and he just does the most amazing stuff with CDK, and he's just anytime there's a new feature in ECS or EKS, Pahud the next day has a video and a whole walkthrough on how to do it. He's so amazing.
Exactly. Yeah.
So I'll post this in here. So I kind of built off of what he did, and basically, so what I did was there's some prerequisites if you want to enable logging. So I created a KMS key. I created an S3 bucket, as well as a log group. So when we enable exec, we have to enable at the cluster level as well. So what I did at the cluster level was I enabled the log configuration to log to that S3 bucket, as well as that CloudWatch logs group, and to use this KMS key to encrypt.
To add more context about that, so if you don't add any configuration at the cluster level, then you won't get any log for it. For example, it just doesn't push your log to anywhere unless you specify the exact command configuration in the cluster level.
Perfect. Great point. Thank you. And so you can see here with the CDK, I'm just creating an ECS cluster. And one of the things that I really love about the CDK is outside of the high level constructs that are available that build a lot of the boilerplate for you, there are times when maybe there's a new feature that was released that's available in CloudFormation, but it's not necessarily available in the CDK yet. So I'm just simply adding an override, which will basically, behind the scenes, it's going to update the CloudFormation template to add these particular keys to my cluster CloudFormation configuration. So I just created a cluster with some EC2 capacity. And another thing here is the policy statement. So you have to, at your task level, okay, so when you create a service or you launch a task, if you want to interact with, if you want to use ECS exec, you have to have these particular actions enabled, available in you have to have an IAM policy attached to your task. So essentially, these are the 4 actions that you need to have added to your task role. And so we create a policy, and then we actually attach it to our task role somewhere down here, right here. So we actually attach that task role. And then lastly, I'm just creating a service. I'm just creating a simple load balance web service, and I hate that I'm doing this, but it's just a simple Nginx demo. I didn't integrate the cool demo that Peng Hao built, but anyways, one last thing. So at the service level, so when I actually create this service and the task definition, I need to have this enable execute command set to true. So similar to Copilot, where if you want to enable ECS exec, you have to just set that to true in the definition there. Okay, so that's all the boring stuff. So I have it deployed. Now, one thing you'll notice is I'm adding my cluster capacity, my EC2 capacity, but I do not have SSH enabled. So I've already deployed this environment. That is like crazy large. Let me zoom out really quick here. And this always is oh yeah, the font size is super crazy. Let's see how that looks. Much better. Okay. So I've built my environment. So you see I run a CDK diff. We'll see it already exists. So I have my ECS cluster. And you can see here I have an ECS service. It has one task running. So we can drill down in the tasks. I can see here's my task. It's running, you know, my Nginx image. Very basic. Nothing fancy here. So let's go to the other thing I want to show is the EC2 instances. So I'm actually going to go back into the previous console here. And I want to just show you. Oh, did I?
No, you didn't.
Skip. Yeah, my bad. So if we go to the ECS instances, you see here's my container instance. Okay, so I'm gonna drill into the instance. Let's actually look in the EC2 console. I just want to show there's no funny business here. I'm not enabling SSH or anything. So these are all internal. None of this is external access to my cluster. Okay, and they're all running in, my cluster is running in a private subnet. I'm sorry, my instance is running in a private subnet. So I can't SSH into it. I can't do anything like that. So I'm going to use the AWS CLI to exec in. Okay, so let's walk through the command. So it's ECS, AWS ECS execute command. I'm setting my region, my cluster name, and then the task that I want to actually exec into. And then the specific container, and then what command do I want to run. So it's all interactive now. So when you execute this command, it's actually going to enter into that container. And I already have the session manager plugin installed. And you can see here I am. And we could even, if we wanted to, let's see. So look, I'm in this container, you know, so I don't even have PS installed. Let's do this. Let's do apt-get install him. So I'll modify the Nginx config, and that way we can see, you know, what that looks like. But actually, let's open up. I'm gonna leave the container, and I'm gonna do this. I'm gonna just deploy. Let's get that load balancer output, and then what we'll do is we'll look at the URL. We'll look at the web page, and then we'll edit it in real time. So there it is. So there's our Nginx conf. Let's exec back in. And then, oh, you know, I'm going to just really quickly, there's a couple questions here. So first question is from the Cream Puff. Hello. How do we keep track of what AWS IAM actions map to an ECS feature? So generally in the documentation, so I hope I'm understanding the question correctly. If not, please feel free to clarify, you know, my understanding. But generally, so like for example, this feature, in the documentation, we tell you exactly what's needed. So you can see here, these are the permissions you need. Optionally, here are some additional features you can add to your task definition. and so on. So generally the documentation specific to this feature should give you what you need to ensure that you have the proper access and permissions. And then can we enable ECS exec true for already created clusters? So I believe on a cluster, you go ahead.
Yeah, I think the answer is yes, because I just look at the CloudFormation documentation for that. Like the interruption is no, so it means that you have no interruption when you change this configuration. So I think I think you can do that.
Yeah,
but
my
that's
understanding
just for the
is
log. That's just for the log.
exactly. But you can't, right? If you have a service that's a task that's running, you would have to redeploy the task with exec being enabled. You can't exec into a task that existed prior to this feature running. So, okay, wow, super small. So you can see here though, it's been so long since I don't even know where to go. Where's our page here? Is this the one? And where's the index.html? So yeah. Anyway, so you can see though here I'm in the container. Let's see. Let me just I don't remember where it's been so long. Where the index.html is. Is it var engineer? No. Anyways, this is just me being so outdated with Nginx. So that's it. So everything I've done has been logged to CloudWatch. So I can look at CloudWatch logs. There's also, again, that S3 bucket that has all the activity, all the commands that I ran, all here. So for security perspective, any type of audits, you have all that data accessible to you, and so on. So, oh, cool. Thank you so much, Nick. Yeah. So, oh, the ambiguous title. Okay. Well, that just means I got to get better with titling these videos. But thank you so much. User share Nginx. Oh, my hero. Okay. So let's check in here. Let's see. You are amazing. So welcome to, do I have to reload them? Everybody coming to my rescue. So that's awesome. Thank you. There you go. So welcome to Containers from the Couch. So I exec into the container. Everyone, thank you. It was right in the nginx.conf. I just missed it because I'm live on the air and I just couldn't read. So there it is. So we were able to demo ECS exec. You can see there was with Copilot, it's all built in to the experience. So when you need to, when you want to enable it, it's as simple as just enabling exec to true in your manifest. If you're using CloudFormation, CDK, or Terraform, there's obviously a couple more steps you have to take. You have to make sure you attach the IAM policy to your task role. You need to, if you want logging enabled, you have to set it up at the cluster level, and so on. But as you can see, I mean, it's pretty straightforward. And once you're in, you're in. I didn't SSH into that host. I can't SSH into that host, and everything I did was logged for auditing purposes, and then we're done. So that's about it.
That's
so
amazing.
Yeah, I mean, is there anything else, any parting words you have, Peng Hao, that maybe you want to share with the audience?
Yeah. So welcome to the Copilot world. If you want to investigate more, feel free to take a look at maybe like previous video on Containers on Couch, or you can go check our Copilot website.
Yes.
I can share the link.
Here, I just posted it.
Okay, thanks.
Yep. So, yep, there's the Copilot CLA. Also, youtube.com/containers from the couch. You can get all the details We have a lot of Copilot videos. Last Halloween, we did a really cool special with Copilot. We deployed the Spooktacular app. It was really fun. We had a good time. So check those out. So is there a repo for this demo? So
do you mean the Copilot one or the CDK one? The CDK one, I think Adam already posted a link for that. And as for mine, the thing is, it's actually currently a private repo, but I can make it public, and maybe I'll post it on our our doc page,
Cool.
Copilot doc page for that.
And we can also Twitter. So if you have it on Twitter, you can just follow us on Twitter. We'll repost it, and you can get it from there. And then, okay, so I think we'll wrap up. There's one last question. How does it do its magic? So behind the scenes, this is all through SSM. So ECS will bind mount the SSM binaries to your container while it's at runtime, and all the communication is done through SSM. So it's explained a little more in depth in the documentation, which I will post here so everyone can see. But yeah, so that's it. Thank you everybody for joining. We really appreciate you joining in and watching the show. Of course, we have Containers from the Couch content that comes every couple weeks. Some weeks we have more than others, but do follow us on the Twitters, as well as youtube.com/containers from the couch. That's where we'll post a lot of our new content as well. So thanks so much, Peng Ao, for being here. Thank you for everyone else.
Thank you, Adam, for hosting this.
And cool. We will see everybody real soon.
Hey, it's Adam and Brent, and we wanted to let you know that if you're looking for more live or on-demand container content, you should subscribe to our YouTube channel.
Head on over to youtube.com/containersfromthecouch and also check out our website at containersfromthecouch.com. Thanks.
Thank you. Good?
Yeah, I think that was
feel good about it?
Yeah,
all right.
I feel pretty good.
I'm going to end the broadcast.
And here we are. Hello.
No, I think every day I'm just so surprised that this works that I'm just always and then I forget.
We should record us, in the preview mode while this is in that minute, because I'm always clicking around, making sure everything's up. Do I have everything set up properly? And it's to the last 3 seconds, and then I'm ready. I'm ready at the last second, always.
What did I forget? Oh my gosh.
Yeah. This is my life in general.
Wait, who do we have with us today? Justin.
Oh, hey, Justin. Oh.
Hey, Adam.
Yeah.
we didn't practice that or anything.
We did it. We were even gonna high five. Remember? We had a whole thing. Except my hand just. I've got a little gap here.
What's up with that?
Yeah. What's up? That's like some kind of ripple in the space-time continuum.
It would be amazing if I did this and then a hand came out the other side. you probably have to get your wife to
smack you hey, Adam.
We can do
that's
that.
hilarious.
We can find a way. Anyway.
Oh my
Anyway.
gosh. Hey, look who we have. We have Cube Jerome. Here we go. Here we go. Also, Alex Smasha. Here we go. Remix. Oh yeah, that would be really funny.
Yeah.
No.
I'll get my son to do it. So it's this little tiny hand coming out.
Baby arm.
Oh, yeah, the baby arm.
Oh, that's right.
Yes.
Adam has baby arms.
Well, Adam, you're like what, an hour away, an hour drive from me or something, an hour and a half.
Yeah.
So it's like, yeah, if you're Elastigirl, sort of like stretch your hand, it just gets smaller as it goes. So
Yeah,
it might make
exactly.
sense. Yeah.
It totally makes sense.
Oh my gosh. Oh my gosh. That would be awesome. I would have to fly. I don't know. My hand would just never get there, I think.
Yeah.
So
it just
oh, well.
wouldn't happen.
Be stuck on the 10 freeway just the whole time waiting.
It would take
That's
a couple
right.
days.
Traffic sucks. What are we going to talk about today?
Today we are
Justin
talking
Mullen.
about the new AWS load balancer controller for Kubernetes. So there's an existing AWS, the ALB control, ingress controller, which manages ingress resources with Elastic Load Balancer, or sorry, application load balancers inside of your Kubernetes cluster. And the new version of the, I'm still trying to remember how to say it, the AWS Load Balancer controller is more generic. It does a lot more than just ALBs to ingress. So we're going to talk about what it can do and how it works and how to deploy a couple things.
Now that you've explained that, I realize I may have titled this thing wrong because it's not the new ALB ingress controller. It's the new LB ingress controller.
Not
that-
ingress, LB controller.
LB
Load balancer
oh,
control, because it does application load balancers, but it also does NLBs, network load balancers. So it does more than ALBs and it does more than ingress. So it needs a new
Right.
name.
nice.
Yeah, so
Yeah.
it's not just ingress; it's a Swiss Army knife.
Yeah.
Any-
and Cube
anything that-
Jerome,
Go ahead.
Cube Jerome, straight to the point. Multiple ingress per ALB.
Yes.
Ooh.
Yeah, so
And
you can
also-
share your ALBs. All your ingresses can go to one. Well, not all of them, but depending on how many you need, you can, instead of one ingress, one ALB, you can have multiple ingresses pointing to one ALB.
Nice.
That's
And
money.
you can do more than you said. You can also do more than ALB. What else can you do?
Network load balancers is the other good thing. So if you have non-layer 7 traffic, UDP, TCP traffic, you can also use an NLB at the service level. So it's not an ingress, because ingress objects are only layer 7. They expect HTTP, they expect a lot of things for ingress. But at the service level, you can do layer 4 routing from a network load balancer directly to pods via a service IP. Well, actually, I think
Nice.
it doesn't even use a service IP. It just uses the service object, but routes directly to the pods.
Nice. And what about classic load balancers?
Classic load balancers, if you still expose a service inside of Kubernetes, uses the internal cloud controller, which will create classic ELB load balancers for your service. So if you just say, I want a service, make it a load balancer type, the cloud controller still does that piece of it. But this load balancer controller, and that's also partially tied to the way Kubernetes manages those services. They have a new object, and I forget which version. I think it's 119, put it in beta maybe, where you can actually have an external service load balancer controller. So right now it is tightly coupled inside of Kubernetes to say, I want a service, I want a type load balancer. That right now is the cloud controller has to do that. But in the future, you'll be able to say, oh, I want a service type load balancer. Oh, and use this other external controller to manage that for me.
Nice. Okay. So that means, like, when I think about it in terms of, what I get a lot of questions, especially with people having gone through the workshop. They learn about, I'm going to build my pod, I'm going to build my deployment, then I'm going to build a service, and they get CLBs, and then they take that concept and they go to, their real world environment, and they have like 26 classic load balancers, and they're like, oh my gosh, does it have to be this way? And so that's when I point them at ingress, and how all of that works. So it sounds like this is not going to replace that first scenario, but it's going to definitely improve what we point them to, and we show them ingress. Now ingress is going to be even better than before. So that's really cool.
Yep, that is the plan.
So Cube Jerome wants to know, so this is a new controller, right? If so, why a new controller instead of improving the ALB ingress controller?
It is, so the code for the controller is going to live in the same repo. We're renaming the repo to be the new load balancer controller. So it is new code because the way it's implemented is pretty different in a lot of cases. The migration path from I have the current ALB ingress controller to this new load balancer controller is seamless. You can just take what you have and install the new controller, and it can work exactly the same way. The new controller has some other pieces in it that are optional or upgrades, as far as it actually uses a CRD to manage a custom resource definition inside of Kubernetes to manage your endpoints. So things like API calls to your AWS resources is a lot less because the controller doesn't have to call out to the AWS APIs every time it needs to, a pod, get scales up or scales down or changes nodes or something. The controller itself can just can update the CRD and then update the target groups for the load balancer. So your AWS API limits will be reduced by this new controller, but you can just install the new controller with the old config and old ingress, and you'll get the same behavior. But it is a much broadened in scope controller, so we had to, there was new things that had to be written using the CRD, managing new types of load balancers such as NLBs, were all new things to add into it. So I'm sure there is some section of code that's shared, but the old controller was very limited in only looking at ingress and only providing ALBs. The new one, again, like I said, custom resource definitions, NLBs, those sorts of things are all added benefits. So it's the same repo URL, new name. There's probably shared code in there somewhere, but it's so small compared to what it does now.
So Cube Jerome, let's just say instead of how you said, instead of improving the existing controller, let's say we vastly improved the existing controller to the point that it's almost unrecognizable, yet still backwards compatible with the configs that you're using today. TrueSec wants to know, do what? What'd you say, Adam?
No, I said that's the key, is the backwards compatibility. I was going to ask about that, but that's fantastic.
Yeah. So TrueSec123 wants to know, how is the API gateway integration with this new controller?
To be honest, I don't think it does anything. I don't think it does anything with API gateway. So
right. So, but the idea, so if you use this controller to expose an NLB or an ALB, you still have to integrate with the API gateway. So there's still those connecting pieces you have to figure out outside of that. So whether that's through a VPC link or just exposing that NLB or ALB URL as the endpoint, there's many ways you can do it, but it's not built into this particular controller.
Yeah, and TrueSec123, this is actually a conversation that I've had here and there inside AWS, and I'd like to get a sense of what you're looking for as far as integration with API gateway is concerned. So maybe could you reach out to me on Twitter and DM me if you don't want to be public about it, and just let me know, what are you looking for with API gateway that ALB can't do? And I know there are answers. This isn't a trick question. I just want to know, like, when I go talk to people inside, I want to know like what to talk to them about. So definitely, I'd love to hear your use case there. Also, by the way, if you take a look at the app mesh ingress, let me know what is missing from that API gateway can do for you as well. That would be useful info to have too. Cube Jerome says the new controller is still in beta, right? And it's a release candidate, so we're expecting it to not be in beta for much longer, and so we're going to go ahead and do the unboxing and take a look at it. And we expect this is the experience that you'll have when it is GA. All All right.
I see all those comments popping in.
I know. So I like to like, you know, the follow-up comments that we don't have to necessarily be, you know, respond to. I still like to pop them on the screen for, you know, for future viewers' sake to see that, you know, things have been followed up. I missed the beginning. Are we talking about AWS ALB ingress controller? Is this the URL? Let's see. I have.
Yep.
Yep, this is what we're talking about. So bingo, you have it right.
And specifically, if you go to that repo there and you look at the releases, there is a release candidate 3, which came out a couple days ago. And that's what we're actually going to be deploying today, to walk through the steps and just kind of show what we need to actually have in our Kubernetes cluster to run this new controller. So that's really the idea here behind, you know, today's unboxing is we're looking at the release candidates, but the steps that you'll need to actually run it, you know, the final release should be the same.
Nice. Awesome.
Excellent.
So, and there is some documentation link. Some of it isn't updated yet for the new release candidate. So I have my own notes and my own kind of walkthrough of what we're going to do. So we don't really have a place for you to follow along just yet, but once the release is out, it'll have updated docs as well. But to start, we're just going to look at, let's dive right in with I already have a Kubernetes cluster. I think I'm on the right one. Yeah. And by the way, if people didn't see, 118 came out yesterday for EKS. So
nice.
That was a big release for everywhere. If you have a 117 or older cluster, you can upgrade to 118.
Justin, can I put you on the spot, and could you maybe do like a couple snippets of, you know, what's in 118 that's exciting to talk about? I put you on the spot.
It's hard. I don't remember which pieces in 118 were beta, which ones were alpha, and which ones are in EKS. So EKS specifically doesn't enable anything that's alpha, which I believe in 118 alpha got things like cluster or service endpoints, which allowed services to scale a lot larger. But again, that's not in 118. So at least not in EKS. I think that's alpha in 118. A lot of the other like minor changes, actually, let me look up.
Oh man. And again, you know, I just put you on the spot. Sorry.
No, like this is like CNCF has a great like walkthrough on special features in their blog posts that like highlight a few things. But 118, I feel like, oh come on, not tag. 118, I mean, it moves so fast that it's like 119 came out not long ago. Here's 118.9. EKS, I believe, is 118.8. Yeah, so it's based on 118.8, but there's so many releases here. There's a changelog. Boom.
And I guess this is just good for people to understand too, is when you know, if you're not one that's often traversing GitHub and looking through, like it's really, you go to the release page, you know, find that release, and you can see generally every product has a release notes, and you can see what you know has been released and patched and all that.
Right, and Kubernetes specifically has a lot of great tracking for all of the changes and what's deprecations, and if you need to like verify, I'm going to upgrade to a new version. Can I do that? Definitely look in the release notes.
Good advice.
So there we go. And this is also changelog since 118.7, which is one thing, right? Like not a whole lot. So we have to look at what we're going from in 118 or 117 if you had an older EKS cluster.
Yeah. Cube Jerome also pasted a link to the AWS docs. And when you look at those, you'll see specifics for EKS called out that are changes from EKS 117 to EKS 118. I still like, and then a link to the changelog that Justin is showing us. I still like going, you know, straight to the source and looking at the changelog. But if you need kind of just a really high level, you know, some summary, then the docs has it for you there too.
Yeah, and typically when I'm looking at the change, like I look at the major bumps because the minor ones are going to be a couple bug fixes, things like that. So changes since 1.17.0, server-side apply is huge for people that have clusters that change frequently. If I do a kube control apply and then someone else does a kube control apply, historically that was done on the client level. So you could have conflicts on the server and say, oh, I got two competing resources. Now that moved into the server, and so both people can do apply, and the server itself, the API server, will merge those and say, okay, I know how to do a three-way diff. I'm going to make sure that I get the correct output that people are intending here in that.
Nice.
Ingress did get updated from standard, or it moved from beta to GA. And so there's this new Ingress class, which you tell it basically like what type. It's similar to storage classes where I said I wanted, if you had a storage controller, you could say I want fast storage or slow storage, or I don't care, and you can have a default. And so Ingress class does a similar thing where you can say types of Ingress that you want. And this Ingress class, the controllers can use that. I don't know if the new load balancer controller uses Ingress class because literally 1.18 came out yesterday and the load balancer controller is coming out soon. So I don't know if those are actually interacting with each other just yet, but I'm sure in the future it will be moving in that direction because that's the new GA release for Ingress inside of Kubernetes.
Nice. Texan Raj asks, can you do a demo on server-side apply? I kind of think that's a little bit like the old way is a race condition basically, and the new way eliminates it. But I don't know if there would be a good way to demo the old way to then show you that it isn't happening on in a newer version.
I'm trying to think of another analogy of something that was similar. I don't know if whoever used Helm 1.0 used to do client-side rendering for all the manifests. And so if I ran a Helm install, it would basically do a big compile of, I need to build all these manifests and then I'm going to send them to the API server. And Kube Control does a similar thing if you're using like Customize or something else that merges manifests down to say like, okay, this is the actual thing I need, send it to the API server. And so if I ran old version, Helm version 1, Helm install something and then close my laptop and went home for the day, it wouldn't finish because there was nothing that like actually triggered the server to do anything yet. It was all doing it locally. And so Kube Control apply being server side, also like if I run Kube Control, run a bunch of, apply a whole directory of stuff with Customize, close my laptop, I'm done for the day, it's not going to work. Nothing's going to happen there. And so moving that to server side not only helps that if like I get disconnected, I have a flaky internet connection or something, but also in the sense, like I said earlier, where multiple people are doing an apply at once. And if there's a conflict in what they're doing, that apply doesn't have to happen at the client side now.
Nice. He says Kube Control debug looks cool also. Yes. But that's alpha, so not in EKS 1.18, correct?
Correct. It's not in EKS 1.18. I'm super excited for Kube Control debug. You can basically mount on the fly sidecars to your container, to your pod, and say, hey, I need to debug something. So you have a debug container or debug pod spec somewhere. I think it's just a container with whatever tools you want. You can have TCP dump and whatever dig, all the stuff that you don't want in your prod container, and you can run a debug command. It mounts you, drops a shell inside of your debug container, and you have the same PID namespace, network namespace, all that stuff. So super cool. We'll have to show that off once it moves out of alpha.
Yeah, that is cool. And can we just, I wanted to talk about this because this is a great point, right? Like oftentimes there's a lot of push for just latest bleeding edge, but realistically it takes time to move, to the next version. It's not just something you do. Some companies, they're fast, they get it, they're just, that I don't know, but the majority, right? It takes time before you upgrade. So that was just an interesting point by Cube Jerome to point out.
Totally. Yeah. And I was at Cube Jerome. I was actually going to ask again, can you reach out privately? And I'm curious, what is the holdup? Not that you should, it just came out yesterday, not that you should already be running it in production today, but you say not ready. It makes me think that it's going to be a while. And I'd like to know, what is it that you have to go through? What slows you down, and it's a curiosity thing for me. So if you feel comfortable letting me know, I'd really like to get a sense for what it is that holds you back from going to the latest version, pretty quickly. So that's awesome. But hey, we're here to talk about a load balancer controller, and I'm worried now that we're going to run out of time.
So
let's get
I
started.
take
with
the
it. Yeah.
blame for that.
So the first thing we're actually going to need in our cluster, it's pods, and let's look at what I have here. I don't have anything special running. Like I said, I just created this cluster, I don't know, half hour ago. So there's nothing special about it. The one thing that I think I did was I thought I created an OIDC provider for the cluster, which EKS control does for you. But I don't remember for sure. So I'm going to run the command again and just make sure that I have it set up. You do need that in the cluster because of the way the permissions of what the controller is going to try to come out and assume role for objects inside of AWS. And so we're doing this, instead of doing it at the node level, we're doing it at the pod level. And so we need to be able to basically hook into some of that permissions and be able to assume role from the controller. And so this is allowing us to do that. So, and I need to change this. So my cluster name, actually I need to look up my cluster name. Hold on a second. Something floral mongoose. Yeah. And if I think I put that in, okay, good. I put it in this variable cluster, and I have a AWS accounts variable too. So let's just do cluster, and this is in US West 2. Did it actually go? I don't know if that actually went. Did it?
I don't know.
It's not in my history now.
Press enter again and see if it tells you that it completed.
Okay,
jobs. Okay.
Okay, there we go. Oh, it's already associated. So it did run. Good to know. The second thing we need to do is actually create our IAM permissions for this assume role. So the controller needs to reach out into AWS and make AWS changes. So we need IAM permission to do that. The docs will have this example IAM policy here, which has all of the permissions that we're going to need for this controller to be able to do things. It needs to be able to read tags. It needs to be able to obviously create load balancers, that sort of stuff. So we will copy paste over here. Create this policy from a file, and we're naming it AWS Load Balancer Controller IAM Policy. So it's pretty straightforward AWS command, which is just saying we need to create that policy. And then we need to create a IAM service account. And this is wrong now because I have a different cluster.
I love the randomized names.
Right. So this is now saying take that IAM policy, and we're going to attach it to the deployment that has any pod that is under this deployment, the AWS Load Balancer Controller. And so that's any pods from there will be able to assume this role. Is basically all we're saying. We created the policy. Now we're saying, let's make a service account inside of Kubernetes that allows us to attach to that and assume role for that policy.
Oh, is he doing Control R? Oh, I thought. That's a good point. So yeah, in Bash, if you press Control R, that's how you kind of
search your command history.
Yeah, you start typing your command, and it'll grab it from history. I also pasted the Bash completion in there for CLI, the AWS CLI. I'm not sure which one.
Which is super useful to have.
Yeah. Yeah, I don't know what that was about. So
the instructions so there's our service account. The instructions for the load balancer is going to have two ways to install it. One from a static YAML manifest, which you need to do a couple things to edit it to make sure it works. One is specifically with Cert Manager. The way this controller works is actually installs a pre-commits webhook to be able to tie into the apply commands for services and that sort of stuff, specifically for NLBs and Fargates. But it needs that webhook to be able to look at the manifest as it's coming in, make some changes, and then apply it to the server. The Helm install is going to do that for you. And so FCF is awesome. I love FCF. The Helm install is going to do some of that for you, and specifically look and use Cert Manager to get a certificate for the webhook. So we're going to use the Helm install, but there will be instructions to do it manually as well if you need to modify certain things. And if I have the, and like I said earlier, this controller uses a CRD to change how endpoints are managed behind the load balancer for specifically for target groups. So we have this CRZ that we do need to make separately, which is a target group bindings is what it's called. So we're just going to create this. It's just a template creating that custom resource definition inside the cluster. Oh, apply with 3 Ps, huh?
You know,
I think my mechanical keyboard P is starting to wear out, and it like occasionally I get doubles on it. I need to figure that out sometime. So the other thing we want to do is Helm.
what's amazing is that the K is holding up. You know,
Would think that would wear out first, huh? So we have a EKS charts Helm repository. So we're going to add that to Helm. I think I already had it, obviously. And then I want to do a Helm upgrade command. And this is going to be the entire command to basically say it upgrade also does an install if it's not there. But if you have it existing, upgrade will change the old one to the new version. The main things we're doing here is I have a namespace. It's going into Cube System. I'm calling it the service name, the service account name that I just created, the AWS Load Balancer controller. I don't want Helm to create that for me because I just did it manually. And then I need my cluster name. The reason this needs to be set is inside the manifest. The controller config needs to know which cluster the load balancer is part of, basically. So we need to set that inside of the Helm install as a variable. And then here's the actual chart. The chart is just this EKS AWS Load Balancer controller. So everything else is just options to that Helm chart.
We should
Makes
make
sense.
a CDK construct out of this.
We should make a lot of construct.
I want to make a construct. Pahood, if you're watching, let's do this.
Pahood will be watching tomorrow morning when he's like at the gym,
Horseback or something,
you know, doing an hour-long plank.
An hour-long plank. That's just
That's right. While swimming on the bike.
Yep.
So the deploy already created our load balancer pod. It makes a deployment, obviously, and then makes a pod. I'm just looking at the logs here to see, okay, we have, information from the log just to verify that it's kind of up and running. And that's like all of the pieces of install the controller, right? Like it's there now. Now we should be able to use it. So the first thing I wanted to show off was the shared ALB endpoint. So I can have multiple services tied to the same ALB. And I have an example in this repo, Echo, which is just it has, does it create that namespace? I don't remember. I might need to do that. It has 5 replicas. It's using this Echo server example. And then down here, we create our service, target ports, and port that it gets exposed, and our ingress, which is pretty standard for any ingress controller that we're using. I think this is all identical to the old ALB ingress. I don't remember for sure if this was part of it as a annotation, but everything else should just work.
The slash scheme I'm not 100% on, but the rest of it looks right. I don't think you have, unless you already have the namespace. Yeah.
Based on that namespace, I can tell when the last time you tested this was.
Yep. Create namespace. There. Now let's create it.
Nice.
We're creating our containers. We expose the node ports. Here's our deployments, and we have a replica set. They're all running now, so I should be able to ingress in that port. I can see I have it up basically. What's the way to? I forget how to get the actual endpoint for ingress.
Would it show up on wide -o wide?
No. Here, I got an idea. Let's go look. Let's go look in
Yeah,
here.
that's what I end up doing most of the time. EC2. Oh, yeah, EC2.
Oh, I love the new console updates.
How many instances? Where's my network? Oh, balancers. There we go.
Alex Smasha, this thing isn't even out yet, and he's already asking, like, does it work with? So yeah, does it work with Global Accelerator by any chance?
No, not that I know
right.
of.
Yeah, but I think you could still use you could configure Global Accelerator to point at these ALBs or NLBs. So you could go ahead and get it all set up, and then just bring Global Accelerator along and layer it on top.
Yep, like in CloudFormation or CDK, you just reference that existing ALB and pass that in as a parameter or an input.
What is it? Here, let's try this. I created so many clusters over the last, I don't know how long.
That's right, Adam.
I should get it in my address once it's available.
That makes sense. Wait, so you couldn't find it in the console yet?
Oh no,
there's
unauthorized.
Yeah, okay.
Oh, I messed up something.
Okay.
Yeah.
So I need to fix my permissions here.
So the IAM role maybe?
The IAM role doesn't have the access it needs.
Just go admin star. For the demo.
Yeah,
no, I'm just kidding. Don't do that. just a joke.
Cube Jerome called it. He identified it. Ursa.
Blame and so Ursa. Jerome's on fire today.
There are very specific things here with node level access to things and pod level access to things. So when you create a cluster with EKS control, the old way of doing it, I could say there's a flag in there that says allow ingress or ALB ingress, I think is what the flag is. That will give you permissions at the node level to create ingress objects. In this case, with this new controller, that doesn't work because two reasons. One, well, it might work for ALB specific things. If you're only creating ALBs, it would probably still work, which is actually weird because I'm creating an ALB here. So I would think this would work. But we do want to move more from node level scope of security to the pod specifically. And so I could say a service account for my pod should be able to assume role into whatever endpoints or whatever AWS resource and do the thing that I need. So the Ursa is specifically pod level. It's narrower scope for who has permission to do what.
Makes sense.
So I am looking through my notes here real fast to super exciting. Debugging IAM, doing it live.
And now I feel like I need some sound buttons, that I can mash to play Jeopardy music and, the final Jeopardy song, etc. The final countdown, that would be a good song right now. The organ music that you play at baseball and basketball games. Dun, 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 dun.
Da, 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 da. Yeah, but the problem is licensing.
Oh, yeah.
So we'd have to just do it on our own.
Yeah, exactly. Like me singing it is probably fine.
Exactly. Exactly.
Okay, let's see. Can I don't actually know if this will work, but let's try it. See those logs again. So I cannot. Is that no? It's just called service accounts, isn't it? SA. Wow, look at all of them. Oh, there it is. And the AWS balancer. Let's see here. So here's my policy. I'm making sure. I wanted to verify that I had the right account number in here. This is my cluster. Adam IAM role. Let's verify that. Let's check it in the cluster for me. And let's see here.
Troubleshooting live, ladies and gentlemen.
I get my token.
It's all good. This is still super useful to see, like,
Absolutely.
how do you when things go wrong, where do you look? What do you look for?
And right now I'm looking in the console. I actually want this because this will show me what I have attached to that role. Okay. I have
Cube Jerome. While debugging it, what's up on the t-shirt, Brent and Adam? I've started working with a designer to get the design going, and I'm waiting to get the first samples back. Well, not like t-shirt samples, but design ideas. So it's coming along. We're working on it.
Takes time.
Restart this guy or girl. I don't know. Do pods have genders? Probably not.
Yeah, I'll go with not. By the way, I got a voicemail earlier. No, never mind. I can't. I tweeted about it, but maybe I shouldn't actually talk about it, in a YouTube video that's going to stay around forever. What?
Why was I signed out? I didn't do nothing.
That just happens from time to time.
Yeah. Let's see. Oh, come on. The select in this web terminal. Go to it. Not available. Are you serious? DNS, hurry up. Let's see.
So yeah, Cube Jerome, what did you change?
What do you think I changed? Admin access.
So to troubleshoot.
So here, let me pull this tab over. To troubleshoot, I went into my roles. I had if you look at, so I looked for floral, mongoose. These were the roles that I had. One was for EC2. The other ones were for other things.
Identity providers, which may have been like an
so here's the CNI
mismatch.
This is for the CNI policy, so that the nodes can add IP addresses inside the VPC. And then the second one was for the actual one I created, which is the add-on. So here's my original policy. I need to debug which one of these policies wasn't enough. And I actually saw that there was an error on ELB, which was interesting to me, but I didn't want to dig into it too much. So of course, the quick fix is let's add admin and see if that works, and then we can work backwards and see what we can remove.
And I like, let's talk about that for a minute. Like, obviously, in a production account, this is not something you should be doing, right? But Justin is in a demo account. He's not running production workloads. He's working through this in a test environment. That's okay. Yeah. Also, I have a tweet somewhere I'm trying to find where I talked about there's a CLI command where you can actually pass in a role to that command and say, what has this role tried to access within the past 24 hours? Or right. I forget the time frame. I'm going to find that tweet and post it in here, but that's another thing you can do to say, oh, it looks like it was trying to access this and it got denied.
Yeah, so I was going to suggest, to really track this down. We probably don't have time to do it here on the show, but CloudTrail log, you can go find, that particular role, that particular identity, and what was it denied from doing, and that's how you could figure out what you need to add to that policy or what that policy might be missing. So, but yeah, this is good for now, just to let us keep going. I suspect it's a typo or a mismatch or something.
Yeah.
Between.
Cube Jerome asked about CloudTrail. So CloudTrail, and if you know this, forgive me, but I'm just going to explain it. So CloudTrail is basically a logging mechanism that tracks all API calls made in your AWS account. And so remember, when you click in the console, that's an API call. When you call from the CLI, when Kubernetes makes a call to try to create an object in AWS, this is all done through the APIs in AWS. So CloudTrail will give you access and insight into those API calls. Were they denied, rejected, etc.
Exactly. And Sergeant Dammit asks, is there a doc for this? And there will be when this is released very soon. There will be documentation for all of this as well.
So I wanted to deploying that was supposed to just create one ALB that should work as the same as every other ALB. I actually want to show the sharing of an ALB for multiple services, just to let's see if that works, and then also show how you do that. So I have the second deployment here. It does the exact same thing as my Echo had before. You can see up here I have my same Echo deployments, and then I'm going to create an ingress for Echo. One difference here on the ingress. Sorry, that was a service. It creates a service for it, and then down here is create my ingress for it. And one of the things we actually do is we have this ALB group name, and so you can name your groups for whatever you want the ALB to be called. And so we can do it by services, we could do it by team or by namespace, whatever it is that makes sense for you, to how you want to group your ALBs. But now I can have multiple services behind the same ALB based on this group name. So I'm doing it here for Echo, and then if I scroll down later, I have the 2048 is the used to be a popular mobile game. Now it's a popular demo game.
I was going to say used to. Go ahead.
I mean, once you win, it's what else are you gonna do? So,
have you won?
You have to get to what was the total? I mean, beyond 2048, like you can go keep going. Yeah, I have it. I'm scared to admit how far I've gotten in that game.
I forgot the number also, but I do have it. I basically filled it out. Every square was half of the previous square, all the way back to the final
beginning.
square.
You win.
Yeah,
that's it.
Yep. Can't do any more.
So in this case, we're doing the new game 2048 service, and I'm using the same group name for my ALB ingress. So we should get one ALB with two services behind it. And the difference here being, you can see, down here I have my path of, the root path will be Echo 2040, or sorry, the root path will be the game 2048. So if I just go to the ingress that gets provisioned, I'll get that. For Echo, I'll do a path Echo. And so the same endpoints with different path-based routing for the ALB. So I should be able to apply this. And it creates, again, the deployments, ingress, rules, and services. So yeah. Okay, so they're already running. Ingress. I still have my first ingress here that I don't know why it's not working. And you see my second one. It should be okay. Game 2048. Wait, is that gonna? There we go. Now we got a host.
Nice.
Very cool. So Cube Jerome asks, do the two ingresses need to be in the same namespace?
No.
Perfect.
Why does that not work? Let's look back at this load balancer. Still shows provisioning.
Still says provisioning.
Yeah. So something seems to be taking a while to actually provision this. I get my listeners, my rules. You can see here I have exactly what I set up there. I have this echo path is going to go to the ingress echo, and then my star path is going to my game 2048. So the ALB is just set, reroute to these target groups. And actually, let me show off the what's it called again? Target group bindings, just to show what that looks like.
Yeah.
So I have, it creates two of these target group bindings, which are how the ALB controller mount or routes from, one ingress rule to something behind it. So if we should be able to see here and you can create these manually. You can create them with the annotations, or if you want control over, if you have an existing ALB and you want your ingress to join an existing ALB, you don't have to have the controller create the ALB for you. You can just create these target group bindings manually for whatever ingress or service you want, and cut out the controller piece of it to say, like, I have 5 ALBs. I just want this one to be part of a target group for this other ALB. That's exactly what this can do, which is
nice.
Super nice to be a lot more flexible to be able to allow people to do what they need inside of their environment.
Totally. So Tommy F17 asks, so these are multiple ingresses using path-based routing. Can you have multiple ingresses on the same ALB with different host names and do host-based routing?
I don't believe the annotations on this controller is going to do anything with that. You can do things with the, I'm trying to remember what's called, external DNS, and you can point multiple DNS entries to the same ALB endpoint. So there are ways to route that at a DNS level and say, hey, host name route over here. It's similar to what you're doing with just a standard ingress controller. Like if you have an ingress controller, not considering this one at all, I need to route multiple DNS things to that host, and then that ingress controller needs to be aware of what host names it accepts, essentially.
Yeah.
Otherwise, it's going to drop the traffic. But the ingress controller is flexible enough to say, accept these host names and then route them to these areas. Ingress does that by default. So if you route the DNS to this endpoint, then yes, you can set up the rules to say not just path, but which host names to accept. And DNS would point it there, and then it routes to the correct services.
And then he also asks earlier, so if you specify a group name that doesn't exist yet, does it create a new ALB?
Correct.
Awesome.
And so did I close my, no, here's my rules. Let's go back to the load balancers. I should actually I'll have 2 of them in here. One for that echo service that I had. Oh, it's active now. Wait, go.
Yeah, I think what we saw was it was provisioning with the new rule that you had just created. Yay!
And now for the rest of the time, I'm going to play this game.
Beautiful.
But if I have it here, if I go to /echo, I get an actual echo back of my request. So it's the same ALB routing to 2 services inside the cluster.
Nice. In 2 different namespaces. That's awesome.
These are both in the same, but yeah, it doesn't matter.
Oh, yeah. Yeah. Texan Raj says, can you put all this in your GitHub? And I think that we can expect these examples to be part of the documentation.
Yep.
When this does launch. Cool.
The last thing I can show
ahead.
real quick is just how to do the NLB. I won't necessarily do it right now. Actually, apply. No, it doesn't work there. Apply all of the hellos.
Do you have hellos? Are you in the right directory?
Yeah. What is wrong with my service?
You have hello dot.
It's there. The main thing you want inside of a service deployment for the load balancer control to deploy or create an NLB is this annotation, which just says on a service, we're going to use the AWS load balancer type, and it's going to be an NLB IP. And so this will, from the service level, again, not ingress, at a service level, I'm going to create a layer 4 network load balancer, which will route IP addresses to any pod that matches those labels.
Awesome. And that makes it Fargate compatible.
Correct. Well, yeah, I mean, ALB worked with Fargate as well.
Right.
But if you have network, there we go. If you have network service or pods inside of Fargate that need to route IP addresses, not HTTP, this is good for game servers. This is good for something that might need WebSockets or UDP traffic, right? You want to send a UDP, you can run Fargates here.
So Bokjo says, what about Doom on Kubernetes though?
It's been done before.
Yeah, this could totally, you know, Doom on Fargate. So you could totally do that.
That's so I already got that NLB provisioned. I don't know if you wanted to say something else to wrap up. Let me see if I can just find this IP real fast.
Yeah, so we've had a couple questions about when, and we're being coy, but we're saying very soon. So we're unboxing it today, while it's a release candidate, but we expect that this is going to be the experience that you'll have when it does get released for GA. So yeah, you're getting a kind of a first look at it. And then you'll be ready when this thing GAs, you'll be ready to use it.
Nice.
I expect everyone here to start using it the morning that it's launched. Just saying.
So we can see that I did get the other network load balancer in the cluster. So this would, again, it's routing network. You can see type here is network instead of, if I look at the type on this one, application. So I could route UDP traffic or something else TCP based that doesn't need HTTP. It's still provisioning, so it hasn't fully resolved everything. But end of the day, I should be able to curl here and I get a echo hello out of it.
Nice. Alex Smasha says troubleshooting session was cool. So I wonder if we should have a show on how do you troubleshoot things in Kubernetes.
Before I joined AWS, I actually wanted to start a Twitch stream of just like, anyone want me to debug something with you? Like if you have something that's in a test account or something, like let's just pair and let's just try to figure it out. Like maybe we will, maybe we won't, but it's super fun to me to like dig into those things and know where to look. And it's something that's lacking for a lot of people that just don't have experience. Like, how do I debug this? What layer is this actually causing the trouble? The trouble is this AWS APIs, is this IAM, is this Kubernetes, is this Linux? There's so many layers in that stack that, yeah, debugging is super hard. And all the debugging things I see are usually contrived. They don't like, hey, this is broken, let's figure it out. Like it never works as well as like a production. How do I actually figure this out?
Yeah, that makes sense. All right. Thanks, Justin. Thanks, Adam. We gotta get out of here in time for I think coming up next is AWS How Do Y'all, or How Do Y'all Partners, or something like that. I should really know the show names by now. I'm sorry. Sorry about that, y'all. But we'll be back. We're not going to be back tomorrow. There's an event happening, but we'll be back on Monday. So I'll see everyone then.
Thanks, everybody. Thanks, Justin.
Yep.
Out and still just as secure. Love it.
What do you say we just go right into the app?
I think that's a good idea. All right.
So I think the first thing I want to do is just recap what we did yesterday and then talk through the app. So we have our application, which contains basically 3 functions here. One is our Twitter scraper, which is a scheduled job, which I'm going to redeploy today. 2 is our API service, which our API service is what's going to ingest those tweets from the Twitter scraper job. And then, of course, we have a front end, which we talked about to visualize all this beautiful stuff. So let's actually just go back to, I love that. Oh boy. All right, let's go back here. I meant to ask to get that console timeout up. Austin, if you're watching, can you do that really quick?
This is what it's like to program at Amazon, by the way.
So, okay, so first I have both repos cloned. I'm going to go back to the Twitter scraper. And the reason I'm going to redeploy it is I want to start fresh. And what we're going to do is with Copilot, there's the concept of add-ons. And so yesterday, we just deployed our Twitter scraper job, which was just pulling in tweets, but it had no way of checkpointing the last tweet that it referenced. So we didn't just keep repeating the same data, right? So now what I want to do is my code has functionality to talk with SSM, parameter store. So it's just a simple key value store. And what it's going to do is at the end of the run, it's going to post the last tweet ID. And then the next time the job runs, it's going to reference that tweet ID as the starting point. Does that make sense?
Perfect sense.
So to get additional resources created with Copilot, so you may get to a point where you're like, okay, now I need a database. I need something that I can't necessarily create within the Copilot CLI itself. And that's where add-ons come into play. So if I go just really quick, I want to show you in my Copilot job name directory, there's an add-ons folder. And there is where I just have my SSM CloudFormation. So I can express additional resources that I need through Copilot via CloudFormation templates. So all I've done here is I'm just creating an SSM parameter, which is just going off of environment, which is passed as a parameter from Copilot to my CloudFormation template and just naming the parameter. And then, of course, I need to have an IAM policy. So there's two things here that I'm going to point out that are just super neat. This is all, to me, kind of, basic stuff. But the outputs. So there's two things here. One is the checkpoint parameter name. This is going to become an environment variable when my task gets deployed. So now I can just reference this checkpoint parameter name as an environment variable, which is kind of cool. Like I didn't have to do anything. It's just there for me.
So there's a couple of things happening here that I think is super thoughtful. One is you still have the ability to write CloudFormation for the custom resources, like you're pointing out. But two, you don't have to write all the CloudFormation. You're only writing, what do you have here, like 3 stanzas, that describe what it is that you need. I guess 2, actually. Yeah. And then your output stanza. And then, like you said, like you're pointing out, to take, just to be knowledgeable enough about the way microservices work and containers work, and just know that if you're outputting this, there's bound to be a reason for it. So turn it into an environment variable so that the application can use it. I mean, that's brilliant, and it's simple all at the same time.
Yeah, it's just thoughtful. Like I know it sounds silly, but it really is thoughtful. And then the last thing to point out is, because I'm creating an AWS resource that my task is going to need to access, now that's where identity and access management comes into play. I need to have a policy that's going to grant my task access. So I created this policy, and by simply outputting the ARN, so the Amazon resource name, I believe that's what it is, of the my echo goes off when I say that, when I say the word Amazon. So what it's going to do is it's actually going to attach that policy to the task role, which is what my task needs to basically talk to AWS resources. That's where we define the permissions. So that's it. I mean, pretty simple. Anything else you want to add here, F.A., that maybe I glossed over?
No, so I mean, this was a great recap of add-ons, right? Like Copilot, by default, it will abstract away all this infrastructure, but you will always have scenarios, just like in your job over here, where you want to integrate with additional AWS resources that Copilot does not provide by default. And you do that through like writing your own little CloudFormation template, dumping it in the add-ons directory, and boom, that automatically gets integrated with Copilot. We parse everything in the output, inject it as either a task role or an environment variable. Or if you're outputting a secret manager secret or a secure string from SSM, those will become secrets. So we'll
Nice.
automatically inject them as secrets.
That's awesome.
And that is a good point. So I did create secrets for this job, and so there is in the documentation there is a section on how to create secrets, and it's something that will improve over time. But I created my SSM secure string parameters, and this is the name of those parameters. And by simply referencing them in my manifest YAML, Copilot's going to figure out the rest and make sure that we have the permissions to access these secrets and that they get deployed as environment variables. So I'll get the actual value of that secret exposed as an environment variable to my task. Pretty cool. No secrets.
Super cool. No secrets were harmed.
So really quickly, I just did a Copilot job init. We did this yesterday. And now what I want to do is I just want to run a deploy on my job. Okay, and this is just a scheduled job. Brent, how many servers am I managing here?
So far, 0.
How many servers am I going to manage once I deploy this job?
Still 0.
Okay.
That's the way we like it. We don't like managing servers. You know,
Yes.
We used to have to do that, and it wasn't fun. So yeah, it's nice to not have to do that. And what's happening if you're relatively new to containers or to AWS is we're building in the background. Copilot is taking care of provisioning and building an ECS cluster for us. And that ECS cluster is then going to be used to orchestrate your containers running on AWS Fargate. And Fargate is basically our serverless container platform. So you're going to be able to run your job without having to have pre-provisioned infrastructure that just sits around all the time. So it'll just run, and while it's running, it'll have execution, and then once it's done, it'll go away, and you won't be paying for any infrastructure.
Bingo. And so now I'm going to go back, and we have our API service. So spoiler alert, I'm sorry we deployed this a little earlier. And the reason for that was because we actually have an add-on here. So let's talk, again, going back to the concept of add-ons, we have an add-on here that actually creates a serverless Aurora database. Nice. So again, how many servers are we managing? 0.
Now it's 0 and 0.
Yes. So we have a serverless Aurora database cluster. And I mean, it's all defined here in CloudFormation, and we're outputting the endpoint and the secret, which, as you can see here in the comments, these are injected as environment variables to our task via Copilot when it runs.
Nice.
Yeah. And this template is like a great example. If you need to integrate with RDS, you can take a look at this template because we set up everything securely by default. You can see us creating secrets for your password. It's placed in the private subnets, and everything will be set up with best practices by default.
That's
fantastic.
So cool. And is there an NAT gateway?
No, there isn't for this.
Yes. All servers and all NAT gateways were harmed in the making of this application. So while my job's deploying, okay, so that's happening there. Let's just do a Copilot service. So again, with Copilot, we talked about this yesterday. We have our application, which encompasses our environments, our services, our pipelines. So I can interact. So, Efe, you mentioned it earlier. From an operational perspective, this is not just a deployment tool, but this is also a day 2 tool where I need to see logs, metrics, data about my services or my jobs. I can do that all through Copilot. So let's actually do, first of all, Copilot.
I don't believe you. Show me.
Copilot service LS. Am I in the right?
I did actually believe you, but now I'm worried.
And now it doesn't work because you didn't believe me. What happened here? Where did I go wrong? Hang on. Let's open up a new terminal. I think this is once again a user error. Copilot app ls. There we go. So you'll notice the naming of the application, and certain things are going to look weird at first, but I promise you at the end, it's all going to come together. All right. So Brent, as you see this as we go along, maybe you'll start seeing a theme here. Okay.
I sure hope so. Otherwise, I'm going to look bad.
So you can see we have our service deployed, and our job is being deployed as we speak. Actually, just deployed. So we have our backend PU service, and you'll see our application name is in. So there's just, if you fit something in the middle there, you maybe be able to figure it out. So let's actually do Copilot service, and let's actually see the logs. So let's see if anything's going on. So it's listening right now. We have some old, data from earlier, but so nothing's happening at this moment. But what I want to do is I want to tail the logs, because at some point here, I'm going to have a task that's going to come up, and that task is going to be my scheduled job, right? Which is the Twitter scraper. And I scheduled it to run every 1 minute. So you can see now in ECS, it's coming up. Here it is, the URL. It's github.com/copilot Ghostpilot app.
Ghostpilot app.
I don't know if this is private or not. I don't think
it's not.
it is.
It's public, yeah.
So have fun. So let's just take a look at what's going on in my task here. So this is my scheduled job. If it breaks, I'm sorry. I've had it working, and then I break it, and then I think we're good though. So
you guys mentioned this yesterday too, but I think the part that I love the most about scheduled jobs is that it doesn't just run your task, it wraps it with a state machine. So with Copilot, you can, in your manifest, you can set a timeout, you can set retries, and if your task fails the first time with retries, if you say retry it twice, and the second time around, it will trigger it again, and hopefully it will work. So we build in redundancy in some way.
Fantastic. So look, here's now the scheduled job just ran, and it's polling all Twitter data from yesterday to present, and it's looking for anything hashtagged AWS Copilot. So you can see.
Whoa! I saw me in there.
There you are.
I see R. Jordan in there.
That's our manager.
I see. I see real Adam Keller.
That's me.
I see people.
That's Austin. But yeah, so we're pulling in all the tweets now, and take a look here. One thing I forgot to even talk about was service discovery and communicating with apps within or with other services within our application. So look, this was our first payload that we sent over, which was FA's tweet, which looks like it was a retweet to our backend. And you can see we sent all the data. So
let's look at that name real quick. Backend pu.n.local. Without getting into the name, I know that's part of what you're working up and building up towards. But just talking about service discovery real quick, service discovery on other platforms can be kind of difficult. You have to run your own service discovery service, etc. But on ECS, it's just a simple checkbox that you want to be able to use it, and then it works over DNS. So Copilot actually provisions the private DNS zone on your behalf, .n.local, and then it's just to refer to any of your services. It's service name.n.local. Super simple. And it works across all of your services.
And so you can see my application is actually sending duplicate data. So the API service is saying, hey, we don't want this. We already have it. So there are some duplicates that come in, but obviously you can see we set that checkpoint value, which means we are able to write to SSM. So that access to that AWS resource was automatically configured and figured out. So yes, if you want to see your name here, you just have to tweet a hashtag AWS Copilot, and then, please be nice and just, tweet some emojis. Please don't be inappropriate. That's not cool.
Yeah, our filtering is not robust.
No, right. Like I'm nervous that I even suggested it, but I think we have a nice audience, so we should be okay. So, and then if you had noticed, I was tailing the logs from the API service, and you can see it stored the tweet data, it received everything, it stored it, and that's it. So our API service is working, and it's gathering the data it needs and storing it in the database. And just for fun, we can also go to the database itself, and I'm just going to query it really quick just to show. Were there funny tweets? I missed them.
Alex Smasha is offering that for a certain price, he can build up a good filter expression for you.
I just didn't have the time. Or did I?
I think, I forget who said it, but I think also Alex, Copilot real MVP. Yes, this is definitely MVP. So, I mean, not Copilot, but the app that we're writing right now is very much like an MVP to get something going.
Exactly. So it looks like, so we had some duplicates. Just trying to see, it looks like there were some errors here, but storing the tweet. Anyways, so we can probably troubleshoot that separately, but regardless, we'll at least be able to see the tweets right now. I'm not sure why we're getting, well, it looks like it's just the error and it's just skipping because it was a duplicate value.
Oh, it looks like it's like some size related issue. Some tweets might be too long and it does not store the very long tweets. We should let our backend engineers know about it.
Yes. Also, how long can a tweet actually be? It's 240 characters. Surely we have the room.
That's a good point. Yeah. I don't know.
Yeah. Well, no. So it's a tweet, but then if it's a retweet, we also ship the data from the retweet, because the API, when you call the Twitter API, if it's a retweet, it's not going to give you all the content of the retweet. So you have to pull both in. And so that's what you're getting. That's what we're shipping to the service. So let's actually, you know what? I do want to talk a little more about the service discovery, just to explain how we kind of manage the communication. So in our manifest, I basically just set the API endpoint. Oh, what should we tweet? Oh, there we go.
There you go.
Perfect. Yes, there you go. There you go. Sorry. So I have an environment variable that I'm just setting as the API endpoints. This is basically the backend service name. And when we look at my code, as that's still tailing the logs there. Let's see, is it here? So what I'm doing is I'm just basically grabbing that environment variable that's the backend service name that I'm creating. And then I'm using my environment variable that's automatically available to my task from Copilot, which is what's the service discovery endpoint. So I don't have to do anything creative. I just have to access that environment variable, and I know what my service discovery endpoint is automatically within the task. So I just wanted to show that. And then that's it, connecting the two together and making sure they can talk to each other. Copilot manages all of that or builds all of that on your behalf.
So cool.
So let's see. I'm curious the errors here.
So here's a question. I can't pronounce your name. I'm not even going to try. But how can we write custom logs into AWS ECS from the back end? So maybe you could talk a little bit about how are you logging your stuff in your app?
It's a great point. Yeah, so good question. And then FA, as far as integrations, I'll probably pass it to you at some point. But so the way it's working right now is this is Fargate. So I don't have access to the Docker daemon locally like that. These are things I can't configure. But with Copilot and ECS, there's a few different things here, components for logging. One is the AWS logs log driver. So what this is doing is when we launch this task in Fargate, automatically Copilot is creating a log group in CloudWatch logs. It's obviously creating the permissions to ensure that your task can log there, but that's where all your log output is going. Now, if you wanted to log beyond CloudWatch, that's where something like FireLens or where you could use like FluentBit to log elsewhere, to ship your logs to other locations like Splunk or Kinesis, or I guess really anywhere else that you would want to receive logs.
I just can't wait to see how many of these things you can name.
Right, I could keep going. I could go all day here. But F8, as far as that integration with Copilot, is that something that exists now, or is that something we're looking at for the future?
That's right. So everything that you described is exactly correct. We'll create the log group for you by default, and we'll use the AWS logs driver to log to ship your logs to CloudWatch. And for FireLens, actually, Copilot provides already like a deep integration with FireLens. So if you, in the docs, if you go to aws.github.io /copilot-CLI, okay, yeah, sure.
I do it the lazy way. I'm sorry.
You go through like many hoops. Cool.
Here we go.
Yep,
that's
perfect.
me.
So if you go under the documentation section over there, we have a page for sidecars under developing, and you can find out how to integrate with the FireLens, So if you just scroll slightly below, we have some like easy integrations with certain specific sidecars, such as Nginx and FireLens.
Nice.
Perfect. So this is just another way. And again, you don't have to have think about running like a daemon set on a server. You can sidecar using FireLens, FluentBit, and then you can log wherever you desire. Alex Smasha, always providing the beautiful stuff. The beautiful outputs.
When he wasn't here at the beginning, I was starting to worry that I might actually have to, type in URLs myself, but he is so good at it. He usually beats me to it anyway. So yeah, I've just gotten used to having him here. He's like, unofficial member of the team now.
Yep. And so what's happening also, by the way, is there's a lot of data that we're going back in time to get. So that's why we'll see a lot of old tweets here, retweets, just different things that have come up.
Are we going back to the beginning of Twitter?
We are not going back to the beginning of Twitter.
Okay, good.
But we're just going a little bit back in time.
Nice. So there's another question. Is it possible to integrate Copilot with Java? And yes. I think the beauty of Copilot and the beauty of containers is that you can run anything in a container.
You reminded me, take a look at our application. So in the real world, you may not have everyone writing in the same programming language. So I'm not a Go developer. I think Go's amazing. I never learned Go. I write in Python. So my service is written in Python, but I'm talking to an API service that's written in Go, and our front end is written in Go. So this is an example of, polyglot programming where we just have multiple languages in our application. And of course, there could be a Java service here. If you write in Java, I could have written the Twitter scraper in Java and done that. So
that's right.
Yeah, it's entirely up to you.
And you can see that like how with Copilot, just with this example, we have really 3 different services. Well, 2 services and 1 job. And we're really embracing the whole microservice architecture. And with service discovery earlier, we can have our front-end service that just spans out to many different microservices. They all talk to each other through service discovery. So anything that's, with Copilot, we're trying hard to have deep integrations really for making sure that your your containerized microservices work really well with each other.
Exactly. And that kind of leads into this question also, the Lang, I'm guessing. If we would like to start changing existing applications to serverless apps, where should we start? I'm sorry if my question isn't related here. And yeah, I think it is. Existing applications are one of the areas that I think containerization and Copilot can really help with. And if you look at the infrastructure that we are building up here, so far we have a job, we have a back-end service. Tomorrow we'll have a front-end service with a load balancer. All of those things are being run in a serverless way. We won't have a single EC2 instance up and running. We won't have a single SSH port that we can log into and have to patch an operating system or anything like that. So there's a lot of really cool stuff happening in that landscape. There's also, we're planning, this will be a future show, but we have another, on that containerization topic, we have a show planned coming up for how you can get your app that's a Windows app into a container to be able to run. And we have a tool for that called App to Container. So yeah, we're going to be taking a look at that sometime.
You're too legit to quit. I'm sorry. That's 90s.
That's
MC Hammer. Sorry.
It's all good. It's all good. You do you. It'll work out.
Thank you. You do you. See, as long as I can do me. That's all. I just want to be me, and I'm crazy. But so speaking on the topic of just how do you start? So look, with containers, I think the barrier of entry compared to maybe like Lambda, I think is a lot. It's easier in the sense if you want to take a lot more and bundle it into a container. Whereas with Lambda, it may be a lot more difficult to bundle a large code base into a single Lambda. Lambda is very much functional programming, very, specific components. It does one thing very well, very microservice focused, right? But you can always, and Brent, we talk about this a lot, is you could do what's, the strangler method, right? Where you have your app, just front it with a load balancer and slowly break off components and take whatever the low-hanging fruit, something that's easy, that's to get you started. Or, sometimes Brent, I feel like I've heard you say, take the hardest use case and bring it in, but take what makes sense, right?
Yeah.
Move it and just start funneling traffic to your microservices as you break apart from your kind of legacy application you're looking to break up.
Exactly. So many monoliths will have the notion of routes that, for this route, go execute this branch of code or whatever. So just go route by route, look at what can stand alone, and then go off and write that as a standalone service, and then break it apart, like Adam said, at the load balancer level, and start sending your traffic over to that service. There are all kinds of approaches that you can take. That's just one. But once you've done that, what you'll end up with, you still might have your monolith around, but it's going to be so simplified, or so, it's going to have far less responsibility. It'll still, in and of itself, it'll become easier to manage. One of the downsides that people don't like about monoliths is they grow to be so complex that if you change something over here, you might break something over there without knowing it. But as you carve off, functions and take away responsibilities from that monolith, it becomes simple again. So, you kind of win both ways.
Yeah.
And with Copilot, the way to approach this would be, if you have an existing application, you would first spin up a load balance web service, create a monolith that's containerized, and then you create these like smaller backend services, and you communicate to those backend services with service discovery, exactly like Adam is doing right now with the scheduled job.
Bingo.
Yep.
Yeah.
That's kind of funny. Could we substitute shell scripts to launch applications with Copilot scripts or something like that? And I'm wondering if you might be trying to get at, building up a CI and then a CD process. And are we still in a waiting pattern? Could we talk about the pipeline functionality?
Yeah, we should definitely do that. So that's a good point. I don't think with Copilot, I think Copilot actually, all the things that you would want to do with bash scripts, I feel like Copilot does for you. And obviously I'm sure there's going to be an edge case that I missed and you're going to call me out on it, which is okay. But the idea is what do you really need to do? You need to build a Docker file into a Docker image, and you need to deploy it somewhere. So Copilot wraps that up for you. And also there's the concept of pipelines, where at some point you should be, especially when we're talking production, you shouldn't be doing this from your Cloud9 instance, from your laptop. There should be a pipeline, and approvals should be done at the Git level.
Yep.
Right? Like
Totally.
you use Git as your approval mechanism. Once that change gets merged, the pipeline handles the rest.
Yep. That's so cool. And then Dallas Marlowe points out, and this is, by the way, super smart guy. So we should listen to what he says. He's also right. Grouping microservices by the data sets they work with is often also a good approach. And yeah, totally. If you can, in the case of a monolith, a lot of times you have just one data set. But if you already have, breaks in your data set, like this part of the monolith goes off and processes an S3 bucket or something in DynamoDB or some other, data store, then that can be a signal to you. Take a look at carving that off, because it's already, the data that it's working against is already carved off. So that can be that. Thank you, Dallas. That's a great idea.
Yeah. So it sounds like Dallas, and Dallas is really smart and good with data.
100%. Yes. James Littleton just felt the need to shout pipelines really loud.
I love pipelines, so I'm with you. Let's shout it, and let's shout it loud and proud. I'm all about the
Absolutely.
pipeline. So to create a pipeline in Copilot, it's actually really simple. And so Copilot has this functionality. It's just a command line parameter, Copilot pipeline. And with that, I can initialize a pipeline. I can, and then deploy the pipeline. So it starts with the init, which is always kind of like your first entry point into Copilot, right, FA? Like Copilot init.
Right.
That's going to get you started with whatever it is you're trying to deploy in Copilot. So if I want to deploy a pipeline, I simply do Copilot pipeline init, and it asks me if I want to add an environment. I do want to add one. And that environment's going to be this MPK environment. And now it's going to look, in my Git. I'm not sure exactly how it figures it out. FA, you could probably tell me that.
Well, you're in a Git repo right now. I checked out Git repo.
That's exactly right.
Yeah, right. So obviously, yeah, thank you. But I don't know if it's looking at my Git config, if it's running a Git remote. I don't know. It's doing something.
Yeah, it runs Git remote. But
perfect.
Locally. Yeah.
So it's checking my remote, and it's basically saying all my remotes, and saying which repository do you want to use for your pipeline to trigger builds and deploys. So I simply pick that. I enter my access token, which I do not have right now. So I'm just going to make that up. And it actually generates some manifest files for me. So there's the Copilot pipeline YAML, which this pipeline YAML is basically what's kind of the manifest for defining my pipeline workflow, right? And then there's the build spec, which I guess, I'll ask this in a second, but the build spec is, with Code Pipeline, it actually uses code build on the back end. Code build is just essentially a way to run builds for your pipelines. That is the actual server that comes up to run your automation and then shuts down. So again, pay for what you use. You don't have some worker running 24/7 waiting for jobs to trigger. And that's where you'll define more kind of technical details related to your build deploy process. So FA, my question to you here is, when would I, as someone who's building a pipeline, when would I modify the pipeline YAML, and when would I look at modifying the build spec YAML?
Sure. Can we open both? And that should make it very clear, I think, for users on when I should be modifying either. So with Copilot pipeline.yaml, like you described, this is the shape of your pipeline, right? So for example, at the very bottom, you mentioned the stage. This will be a list of environments. Like in this situation, we have an environment named MPK. In a more real life example, you might have a production environment. You might have a test environment, a QA environment. And for each one of those, you will be listing them in whichever order you want to deploy to. And you uncommented earlier, we provide some additional configuration there, right? Like you could set up a manual approval step as well as adding test commands. So this, with the test commands fields, you can run, for example, integration tests or end-to-end tests, whatever you would like. So that's what it would. Yeah. So the pipeline.yaml file is just the shape of your pipeline. And the build spec. The build spec itself is, if you look at the Copilot pipeline, the way it works is that you'll have a build stage, and then you will have these individual stages that you defined in your pipeline.yaml. And the build spec is run in the build stage itself. And the only time that you have to really modify this is you don't need to look at the push build commands at all. This is what we use to really just take your Docker files, called Docker build. So we create a container image, push that to ECR, and that's all it does. In the build commands section, if you want to run any unit tests, so if you want to fail early in the build step itself before building any of the container images or something like it, you could just enter the commands needed there. So like make test, so that would run your unit tests.
Got it. That makes sense. So really, that the build spec for me as a developer, if I want to run unit tests, right, just against my code before we get that image deployed, we want to test or run unit tests. Then the pipeline YAML is where I would define integration tests or kind of post deploy.
Yeah, post deployment. Yep, exactly.
Very cool. So that's fantastic. So basically, the next step, what I would do after this is I would just run a Copilot and pipeline. Saying them together is very hard. I struggle with this. Copilot pipeline update, and this will actually deploy my pipeline. I'm going to do it, but I'm just going to tell you right now, it's going to fail because I don't have the I didn't have the proper value set, but that's okay.
Yeah.
So that's what I would run to have my pipeline deployed. And for tomorrow, I'll deploy it. I'll put my proper GitHub API token in there so we can see it work. But that's that. So what we have is so now we're at the point where we have a scheduled job that we deployed with Copilot. So if I just do Copilot job ls, I can see that's again, this is not the actual job, but I have my Twitter scraper job. But you can see if I had more jobs, all my jobs would be listed when I run Copilot job ls. So we have our Twitter scraper job. Our Twitter scraper job is shipping data to our API service. So if I do a Copilot service ls, I can see I have my backend service, Copilot app show, and we can see that. Should I run a status?
Can you run a Copilot service show as well?
Oh, that's what I meant to run. Thank you. That's actually what I meant to run. Thank you.
And so, sorry. At the bottom, earlier we talked about add-ons and how anything that you put in the outputs get injected as environment variables or secrets or roles. And over here, you can see when you run Copilot service show after the deployment, you can get the values for whatever you wrote in your outputs, right? For example, we put RDS endpoint as one of our output. That's for our Aurora database. And you can see the URL there for the database.
Yeah, so I was just curious, did we try this? Was it a tweets database? I don't know.
It's Postgres, I believe.
Okay, I think you're right. Wait. I swear, I think select all from tweets. I'm just going to run it really quick to see, show me. There it is.
Oh,
okay, so
nice.
It was updated and we missed it. So
Gotcha.
in the tweets database, you could see here are all the tweets that have now been shipped to our backend service. So we have 25. We could see usernames here. Austin has tweeted quite a bit. There's FA, there's me, Brent. Again, more people tweeting. I don't know who that is. That looks like a new name to me. We got Dallas.
Awesome.
Dallas Marlowe. Look, we got, looks like Ian, Hercules. And there you go. So now we have the audience tweet AWS Copilot. And so, FA, maybe you can answer this question. Why did we choose Aurora serverless instead of Dynamo for this example?
Yeah, so actually Copilot provides super easy integration with Dynamo. That would have been like our preferred route if we could, because it's super fast, extremely reliable. I mean, both of those services are great, but in this situation, in our front-end service, we want to run a query for aggregating this data, right? Like we want to be able to count and group by, find all the most popular emojis. And for that, RDS, a SQL database, really provides us super easy queries to get that information. And it would have been a lot trickier to model that with Dynamo.
Yeah. So cool. So
Great answer.
That makes sense. That's like we should just take that clip and say like, hey, I'm trying to choose between Dynamo or RDS.
Right.
Here's FA on how to choose the right answer. So, but yeah, so Ian was excited. I saw Ian commented here. I believe this is you, AWS Copilot with this. So now, these are Dallas Marlowe posted. It looks like green people, which is kind of cool. Zombies. Yeah. And then
I'm going to have to step up my emoji game now and go find some zombie emojis.
And then this one here just went all the fun emojis. There's no Halloween here. It's just happy times, which is okay too.
Here we go. 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 Here we go.
Oh yeah.
Hey,
there we are.
I totally cut you off. Sorry, Adam.
Did you know I was just making sound effects? That the ends. Yeah, no. Pure sound effects. You did not cut me off at all.
Nice.
I promise you. How's it going?
Oh, it's good. It's good. It's been a week so far, right? I mean, yesterday
It's only Tuesday.
I know. Yesterday was just that big. We did our whole Container Day 0 event for KubeCon, and man, that was quite an event. It was all day of talking about containers and talking about Kubernetes, and we had a lot of launches.
Yes.
So some stuff was sort of unveiled for the first time. I think that was pretty cool. I don't know what's been going on with you.
Oh, same old stuff here. It's just funny how you say it's been a week. It really, I swear, yesterday felt like a full week's worth of work just wrapped into a day. And granted, it was like 3 containers from the couch shows, but we had some really cool announcements yesterday, and Bottle Rocket being one of them, which I guess, context for today, we're going to be unboxing Bottle Rocket. But I think, talking about container-specific operating systems feels really nice. And I'm really excited to hear what Justin's going to, first of all, what he has to say about Bottle Rocket, but of course the live demo. And of course, is it fair to say, Justin, there's going to be live props today?
There will be a few. Yeah. We always try to give that visual aid if it's going to help someone.
I'm getting a subtle prop just with the T-shirt that he's wearing.
Right.
I mean,
throwback
container-based
to
OS. Exactly. So that was my first container operating system, and frankly, using Core OS kind of solidified the whole concept of putting things in containers for me. There's no longer, what's on the OS versus what should I put in a container. The answer was put it in a container, put it all in containers, strip down the operating system.
It really proved that you don't need a package manager, right? Inside the OS at least, right? You need a container runtime and some controls, and you can do a lot with that.
Totally.
Yes.
Exactly. So
And even the background here with SpaceX launch more rockets. I'm going in with the whole theme, right? It's just like container OSs and rockets. We're trying to get the whole thing just as much themed out as we can.
I like
That's
it.
so good. That's so. And Techie Stories is back. One of our regulars. Hey, Techie Stories, and yeah, she was a big fan of the bottle rocket announcement as well.
She loves talking about security, and I think there's some like inherent security that you get from an operating system like Bottle Rocket. So,
For sure.
So yeah, I can definitely see why that's super popular.
So just, sorry, just I just want to do a quick poll of the group. How many CoreOS shirts do you have? I think I have 4.
I just have one. I wish I had more because they are super soft.
The most comfortable shirts ever.
They have aged so well. So
okay, I win.
Yeah, you do. Although the CoreOS Fest was they only had one, and they actually had like special invites for like they sent a box with a shirt in it. It was like limited edition. I was like, this is amazing. Like making someone feel special around like, hey, we want you to come to this thing. I still had to pay for a ticket, but hey, here's a gift for a shirt. Before you come, it was actually really cool because I was like, I already knew about CoreOS Fest, and I met a lot of great people there. They had a lot of good talks just around. At that time, it was right around that, Tectonic was coming out, Kubernetes Shift for CoreOS is like being a product and a focus was really fascinating. But it was a great time just to be like part of that group of like, how do we make operating systems better and more secure and easier in a lot of cases, right? Like the amount of tuning and things you had to do with operating systems historically has been so much to get to this point. And now it's like, hey, what if that is boring? And what if we just, you can control it different ways and upgrade it and do these things in a different way.
Right. Jesse says he has 3, and I have to ask the question, why do you have any, Jesse? I think you were working at for Solaris at the time, working on Solaris.
I think he has like 100 Solaris polo shirts. Love you, Jesse.
Yes.
Just teasing.
You're forgiven.
Hey, you started it, and you egged me on. Anyways, Brent, you were going to say something, and I interrupted you earlier, so I don't know if you remember that thought.
I think I may have been thinking back to where I got my CoreOS shirt, and I think it was at like one of the first Mesos conferences, and CoreOS was one of the exhibitors, and that was when I was first introduced to CoreOS, and like I said, it just kind of all clicked. So it's cool.
And so I was just looking at Twitter, and Matthew Wilson had mentioned it's Bottle Rocket. Not AWS Bottle Rocket. It's Bottle Rocket. So
yeah, that's fair.
Which I think we said, but I was just saying for further clarification. Anyways, let's get into it, huh? What do you say?
Let's do it.
Sure.
Right.
Are there any other announcements or anything else we want? I mean, like KubeCon's going on right now. Like I've been trying to keep up and connect with people, but it's been quite the whirlwind of just reading news and everything else.
And European time is hard from, especially from the West Coast. So have you seen anything from KubeCon that, is notable?
I went into the virtual space. I went through the expo hall a little bit, and I kind of looked at the listing of talks, but basically almost everything I'm just like, I'm going to have to do this later, which is good. You miss out on that like shared experience of, like we all learned it together at the same time, but there's also a lot of great things that it's, even more inclusion, even though it's a EU conference. Hey, guess what? Like time zones are hard, and I need to sleep at some point. So being able to catch up with that later in the week or next week, and still be able to get all the information from the lineup for people talking is just amazing. So there's a lot I really want to learn about, but at the same time, it's just I got other things. So
yes,
totally.
So yes, glad that we mentioned it. I just saw it and I felt like it was important, so I felt like I had to mention it.
That's impressive, though, that you're like on Twitter and this at the same time.
I have like the full control center here. It's unbelievable.
Slack open too.
I do, but that one's hidden. So at least I
send him a message. We'll see if we hear the little the chime that it does.
Exactly.
Yeah.
Not chime though. We can't have that open at the same time.
Right.
No.
You didn't change your. Go ahead.
By the way, Tanju, hey, back to you, and Stitchy E. Welcome back. We don't want to miss saying hey to our regulars. So
yes,
awesome.
Let's do it.
Let's do it. So should we dive into your screen?
Let me switch that real fast to the. I'm going to show just real fast because I actually have to start. I want to show this with an EKS cluster, so I want to just get that started so that it's not, if there is a problem or something else, we can switch over to it. So here's just a really quick EKS control or cuddle or whatever you want to say, can take a config file and you can tell it basically all the specs. Instead of sending flags to everything, you can say, here's what I want, just do this. So this is, I just wanted to show this off real fast. Don't memorize or whatever. They have great examples. But the main things are, I'm calling my cluster Rocket. It's going to be a Kubernetes 1.17, and then just some node groups. What's instance type? Here's my AMI family with the actual ID that I want to use, and then zone, and then I have some other things about IAM permissions, right, so that I can SSH or SSM to those instances, and they can access the EKS control plane, everything else. So I basically just have 2 of those in here with a public key set so I can SSH into it. So I wanted to show that before I actually just quickly run the command and write out a config file. So that'll run in the background.
Perfect.
And then
I have questions.
Yeah.
So back on your config, I noticed that, well, one, I noticed that you're building 2 node groups, 1 per availability zone. That's less of a question and more of a, wow, that's impressive. Next level stuff there. Tell the rest of the audience why you might do that.
I have a whole blog post that's prepped for it, which isn't out yet. But yes, the main reasons you might want to do that is if you're using EBS volumes or any service that is region or availability zone like constrained. So EFS can go across the region to any AZ, but things like EBS volumes and there's a couple other small things that, like, if you're using them, you might schedule a pod, and if you create an EBS volume, it'll map into that pod. Great. If that node goes away or the pod gets rescheduled or deleted and recreated, if a pod goes into a different AZ, you won't be able to map that EBS volume into the pod. And so controlling that, how they're actually, where your AZs are, you can scale up and scale down each one independently. There are tons of trade-offs with both scenarios. It's harder to kind of manage multiple auto-scaling groups. It's easier if it's just one big one, but if you have one big one, you might get pods that just land randomly in an AZ, and Kubernetes isn't actually aware of which services only work per AZ. There is some work on making topology aware scheduling, and especially for network traffic, so you don't have cross AZ network, and there's all these things that are kind of coming and they're being worked on. But EBS volumes is a good example of, if you're using them and you have one auto scaling group that spans AZs, it might cause some problems for you with pods that can't schedule and or be rescheduled. So
yeah. So if you saw that, noticed it, it's definitely advanced level. It's not that it's necessarily harder, but it is something that you would then have to sort of make adjustments elsewhere as well about how you deploy your pods. So
all right, that was a good catch, and there's always trade-offs. So you're going to manage it at some level. If you don't have to use any AZ constrained service inside Kubernetes cluster, great. Make one big ASG, put it in the region, and you're good. Like, you won't have those constraints. But there's a lot of workloads that might require an EBS volume, and so I show it off sometimes.
So like two examples of when you might not need that would be, one, you have no stateful containers. You're doing completely stateless. So that's definitely how you should start anyway. Your first container that you deploy should probably be stateless. And then 2, you might be doing stateful, but you're doing it with backing from something like EFS instead of EBS. And if you do that, then EFS allows for cross AZ access. So you get the same data no matter what availability zone you're in. And
or you store all your state in Route 53, and you have 100% SLA, and it's global, and it's just, that's a thing.
It's the best database there is. So I wanted to, while we're waiting, give a couple more shout outs. Ayush, hey, back to you. And notice, by the way, he's coming in from the YouTube channel. So if you aren't aware, we live stream to Twitch, of course, but we also live stream onto our YouTube channel, and that helps us from an archival purpose, but it also helps sort of with custom push notifications. With Twitch, if you subscribe, you'll get push notifications for like, every show. But for our YouTube channel, you'll get push notifications for us. So that's pretty cool. And Texan Raj has moved over there. So we used to see Texan Raj on Twitch. And now we see him over on YouTube. So that's pretty cool. Jesse wants to call it cuddle. He is super into, it must be Cube Cuddle or EKS Cuddle. So, all right, I'm coming around. I still say control, but I'm coming around. So Techie Stories has a question. Can you add multiple availability zones for node groups? And I think you kind of addressed that after, like as you were explaining. So yeah, you can totally do that, but it's just, there's a trade-off. In fact, the default is to do that, multiple availability zones, one node group. But if you ever find yourself wanting to deal with state, then it might be easier for you to limit and build one node group per AZ. And watch for a blog post from Justin on that in the coming few days or maybe weeks. So
yeah.
He's
going through a few edits of
exactly.
The other information, because there's a lot to consider. As soon as you have state and containers with Kubernetes, you want to make sure you address it properly for all the use cases. So
yeah, exactly. Stitchy E asks, so worker nodes AMI is the rocket image, and that kind of was my second question when you had that file open, because you said you specified the family was bottle rocket, but then you also specified the AMI ID. And I was wondering, if you left out the AMI ID, would it go look up the current AMI ID for you based on the family?
Yes, there is a way to have it get that information, pull the latest one. I'm actually using an older one here so that I can show upgrades, which is Perfect. One of the purposes of it. But you can, the main difference there, actually, let me switch here. Right here? Yeah. So the main thing here with the family, wherever that went, here is it needs to know what type of user data it can use. And so typically my user data wouldn't necessarily ask for like SSH key and allow it, and then I have a public key name. Public key name or key name is something that's part of a traditional Amazon Linux 2 Linux distribution, but there are other things like this enable admin container. Like that's not something you're going to get in a normal Linux distro. So there's a couple of things that EKS control just needs to know how to parse some of this information when it sends it into the CloudFormation to send it to the worker nodes properly.
Yeah, that's awesome. So Ahmed, hey, back to you. And Gato Libre says, what a coincidence. I was studying about containers yesterday and this stream came up. Good timing. Good afternoon from Brazil. Yeah. That's awesome. Hey from California. We're all in California.
We're all in California right now.
Holy crap. That's awesome. I'm normally in Texas, so I'm not used to thinking about it in these terms. By the way, go ahead.
I was going to say, this talk is a little less about containers specifically and more about the operating system. We're going to go into a little more details around like Linux and how Linux is set up here inside of Bottle Rockets. And it's not going to be like a 101 Docker. I mean, if you want that, you can definitely check out the other streams. So
exactly. And I was going to suggest, if you are exploring containers, check out containersfromthecouch.com. It has our entire archive of videos. You can watch them from there. Or you can link out to YouTube and add them to your own playlist or download them or whatever it is that you need to do. There's some beginner stuff. There's some advanced stuff. There's some in between. We talk about orchestration. We talk about ECS, EKS, Fargate. We talk about Justin did an amazing talk on how Docker images work and how layering works and stuff like that. So there's just all kinds of good information out there, completely free, no advertising or anything like that. So definitely take advantage of that. So cool. Techie Stories was just for clarification. So it's basically, a storage decision. And I think no, not necessarily storage, but that's probably the most common example. There's a lot of ways that you can fine tune things at AWS to be availability zone specific. And once you reach that level, like for example, you might have an Elasticsearch cluster where you've sharded all of your data so that copies of the same data exist across all of your availability zones. So the next optimization might be for clients in AZ1 to try and send their queries into an Elasticsearch node in AZ1 to keep that inside the same AZ. So there's all kinds of stuff like that once you really start to optimize and fine tune, you can get down to be that specific. And this is just one of the tools along the way that will help you with that, help you place your pods in the right AZ so that they can have access to the data in that AZ, and et cetera.
And Justin, could you go back to the config, EKS cuddle config really quick? I just wanted to also, and I don't know if you mentioned this, sorry, but specifically with the admin container. So I think it's, just a question your way is admin access, SSH access enabled in BottleRocket by default?
No, it's off by default. It's also updates, automatic updates are off by default. Admin containers off by default. There's a lot of decisions for what the default experience would be for a user. An admin container, it's unknown for a lot of people. Like, what does that mean? And we'll show it in just a little bit. But basically, like, that's how you get actual root access to the host. There is a control container, which is enabled by default and allows you to do a lot of other things. But that's really just like the way you think about an OS in BottleRocket sense is it's not a bunch of files on disk, it's an API. And how you're going to control it and change those settings and do things isn't from writing files on disk. The root file system in BottleRocket is read-only. Like, you can't change that unless you're using the tooling and API to do some of those things. And so control container lets you do some of that stuff. Admin container lets you do some other, like deeper tuning. And I'll show that in just a second. And
it does sound like Texan Raj has just posed a challenge for me because I do love the CDK. So I'm going, yes, now I'm going to do this. So the question was, do we have a CDK stack for deploying this on EKS with BottleRocket? I don't believe we have any CDK examples that I'm aware of, but who knows? There may be something out there.
Yeah, I mean, it did just launch yesterday, so
yeah, fair.
We're gonna work on that, and we're gonna have a show on it.
Yeah,
I don't know when, but probably pretty soon.
So I'm also going to show. I'm going to run this in the background as well. The EKS EKS cluster is going to create. It's fine. We'll get to that eventually. BottleRocket local deployment is being worked on. There is nothing specific about BottleRocket in Amazon right now. There are some things that are specific on how it gets configured. So things like user data is the only way to configure it. And so if you want to create something with BottleRocket or modify it or enable the admin container, that kind of stuff, you need some way to be able to send metadata to it. And AWS gives that for you. We have a metadata endpoint that every instance gets. But right now, running it locally isn't supported, mainly because of some of those other things. And I'll even show, here's just a command I'm going to use. I think it's the same ID, but I don't remember for sure. I'm going to use the same, the same IAM credentials. And then I have this file, which I really think of like BottleRocket's kind of like the new hipster core OS in a lot of ways. Like there's 100%. TOML, there's Rust, there's, it's all these things that we just like, well, we used to use, YAML files. Like, no, now it's TOML. So it's way cooler. But basically, I'm just going to give it like a name tag. I'm going to add my same SSH key so that I can get into the SSH admin container. And let me actually show. This is all my user data. Is I just say I want to enable my admin container, and then I enable my my control container, which is enabled by default, but I'm being explicit here. So.
And what is the purpose of running this instance?
I'm just going to show you some of the fundamentals of the OS real quick. So this is a pretty quick one to stand up. EKS takes a little bit longer, so I want to just get to this piece. And I actually wanted to. This is somewhat where I want to show like where we kind of came from with like container OSs and like how people ran things in production. And to me, like, again, I thought of this yesterday. It was like, here's a Tupperware, which is now partially see-through. But basically, this is like my VM, right? Like everyone had a VM and they say, hey, I had these VMs everywhere, EC2 instances. And what did you do? You took systemd and you just like ran systemd or initv or whatever, and you just put stuff in it. And for me, like systemd is this catch-all of every service, right? Like everything you run on the OS is running a systemd. And so I kind of think of it as mixed nuts. Like it's just like, it's straight up like just anything you want to run systemd, you're just like, okay, we're gonna like, here's our services, we're gonna run those, and then what do you do, right? Like you're like, hey, this Kubernetes thing's coming out, like I gotta do something else. So like you're gonna throw Docker in it, right? And again, I'm stealing toys from my kids, but it's for a good purpose. So just like, here, Docker in it, boom, like we have a container instance, right? And like that's how like everyone has been doing it for so long with general purpose Linux distros. And you say, hey, what can go wrong here, right? Like once I'm at this point, like what do you do? Right, Kubernetes, run some pods, and you're just like run all the pods I need, and we're running Kubernetes in production now, right? Like this is my Linux distro, everything's there, and so this is like my analogy of like how it's been done for all, since Kubernetes came out, and even before then, like CoreOS had some niceties because like systemd was a little bit stripped down. There wasn't a package manager, so again, you're not writing files to disk, but at the end of the day, like you still have this thing running with systemd and Docker, and so the whales.
Your wife is going to be so mad.
my son actually, I told my son I needed props. I was like, I need some of your. We had a little Docker stuffed animal, and I don't know what happened to it, but he's like, I got this one. He's like, technically, Dad, this isn't a whale, it's a dolphin, and I'm like. I appreciate the clarity. All these technicalities are great. Like it's gonna be okay. And then he brought me like a narwhal and like an octopus. I'm like, no, like the whale's fine. I mean the dolphin. I'm sorry. But that's like how we used to run things. And so let's switch back to the terminal, and I'll show you. So Kubernetes is still standing up down here. I have this instance. Actually, let me. I'll go a little bigger. So, and you saw I enabled the admin container. So that's already going to be there. Let me just get the IP address of this guy. Or girl. I don't know the gender of this VM. It's okay.
Yeah.
And the props are a big hit, obviously.
Absolutely.
Just wait, there's more. We got to explain this in full clarity for everyone. So, okay. So what I need to do is SSH. I have a bottle rocket.
And was that a cereal container? Like, what kind of container was that? It was like really oddly shaped. Like you can't put your leftovers from dinner in there.
Don't worry, it's a C4X. Actually, no. Before I SSH to this, let's not do that. So watch. I'm going to do SSM. This is again. It's a session manager. It's a command line SSM session. It's a command line tool that's Disney Streaming put out, open source, so you can use it. And I gotta get the instance name. And then we just do I and say, okay, what?
Oh, that's the AMI.
That's it. You're SSHing into an AMI?
You're right. That doesn't work.
So everybody knows if you're new, if you're new to AWS,
it doesn't work that way. You got to run it.
SSH into an AMI.
Okay. So here I actually, session manager got into this container running on this host. And so session manager is in Bottle Rocket. It's like thinking of here's my Bottle Rocket instance. Like, where am I at this point? Like, I'm not actually in the systemd area. I have this SSM container that runs on top, and I'm inside that container right now. So like I can't get systemd. I can't get out of that. Like I am in a shell in that container, and so I have very limited things of what I can do. And they give you some help here. Like enable admin container would allow me to have that, but I can't get from where I'm at from this current container into the admin container. I have to actually go out and SSH in. But inside of this container, we can see like they give us super helpful like. API client is a current, let's look at these settings of this API on how we configure the OS. And I can't even, there's no JQ on here. Like I can't, it's so minimal that there's a lot of things that I can't do. You can customize it, and I'll show that as long as we have time. you can customize both these containers, but this is just a basic, like, here's my message of the day. Here's some Kubernetes settings I have about it. There's a bunch of stuff in here. Lock, here's my admin container. Here's the source for it. So we can see that, like, that's where my admin container is running because I set that in user data, and it pulled from this ECR repo. So again, like, there's so little I can do. I can see, like, who I am. There is, again, I'm in a container, but if I do top, not there, H top, I don't think H top's here.
What about yes?
Sudo's not even
W
here.
get.
So, like, there's I could, like, proc. Let's like, okay, how many? I'm in a container, so there's 6 processes running. Like, I can't even, like, there's nothing I can get to from here, from this container, but I can configure the OS. I could set things if I didn't do it in the user data. So it's fascinating, but I can't show you a lot here. So let's exit out of that.
Well, so really quick, Justin. So I guess from someone that's what if I'm going into the control container, what is my intention? Why would I go to that container?
Probably configure something on the fly, and you're going to say, I need to change this to see how it works. I need to change this setting. The API is documented on the BottleRocket site, so you can say, okay, API clients, like, let me write some things. You can write to settings and force it basically works. I think of it like SQL, where you write a bunch of commands and then you commit that and you say, hey, I need to do a bunch of stuff, and then I'm going to save this and see what worked. And then you can take that and go back to your user data and configure all your other instances to be identical. And so API client lets you do some of that stuff inside that control container. But it really is just configuring the OS. If you're doing troubleshooting or tuning, you're not going to have enough access from there to be able to do something else. And that's where the admin container was kind of created and works.
Nice. Very good. Thanks for that.
So I need to get back to IP. Rocket. And it's funny because, again, this admin container is another container inside my VM. This one, though, has escape hatches, I would almost say. Like it has ways for me to get to the host and do more things. So one of the things by default is I'm on the host process namespace, which just means I can see all the processes from the host I can see in this container. But again, I don't have a whole lot of tools to do it with. Justin mentions you can change settings on the fly without connecting to the console, which is, Session Manager, Systems Manager isn't just for starting sessions. System Manager manages systems in a lot of different ways. So you can, that integration inside of AWS is super tight to say, like, hey, Systems Manager, run these commands or configure these things without, I don't need an interactive shell to do that. Very good point.
Right. You can do it across a fleet of nodes.
Right.
Yeah.
And so, again, this SSH gives me some information, so I can see, like, hey, I actually have the root file system here. So if I look in proc, there's some processes. Actually, I'm in the host namespace. So, but that should look the same as BottleRocket root fs proc. It's going to be actually the same thing for process namespace. But if I look at where I am and then look at rootfs, there are some other things that this is the actual host file system. So I'm in a small admin container, so I don't have things like htop or ps, but this admin container has some things that allow me to do, like sudo is here. And so I can sudo yum, and this is Amazon Linux too. So it should be very familiar. PS tools or PS misc, or let's just do htop. htop. Let's get all those tools. I don't remember which one. PS utils, that's what it's called.
Yeah. And let's just clarify, you're yum installing, but this, again, is not yum installing onto the host OS.
Yes. Correct. It's in this container, and so everything is contained. So if I even destroy this, container, like, the files go away. But I do have that access of, like, what is on the host. I can see some processes. So I can, one of the commands I like is ps tree, which will show me all the processes, a process tree from the host all the way to myself. And so you can see where I'm at, right? Like, here's my ps tree command. And so I I'm on Bash right now, and I SSH in. I forget why SSH has so many forks,
Yeah.
but it does. And then I have this container D shim, which is actually where this spawned from. Container D is a shim that ran the container that I'm actually exec into. And then before I was in this Amazon SSM agent, which would have spawned, you would have saw like a bash after it, but you can see it has its own container. They're two separate things inside of my VM that they don't talk to each other. They're controlled by one root tree from system D, but I can't get from one to the other. And I can see things like from the host, again, I can see Kubelet was there. I can see the journal running for logging. And this is Wicked is a networking. Cronny is for time syncing. And API server. There's my API server to configure the host. These are all running on the host namespace. But I still, like, there's some things that I can't do. Like if I do journal, like I can't, journal's like, hey, I don't know where it's at because I'm in a container, but I do have access to the file system of the host, so I can journal. Let's give it the full path to where our log journal. Oops. Sudo, and now I can see the actual logs from the host there that I mounted in that path. And this lets me see it. There's a much easier way to do it though. Shell T. There it is. This is actually, I like showing it because it's clever. It's just a bash script with a few lines in it. It basically says, hey, find my parent process and let me go to that process. Like, let me, like, exec replaces my current process and nsenter goes into that container. So it's basically like, let me go up a level. And this container, the admin container was set up properly to let me do that. But this magic of like, what is shell T, it just lets me go up a process in the process tree to get to the actual host and start a shell there. But again, there's a lot of stuff that's not in the host. And so again, like, who am I? I'm roots, but I don't have htop. Like I can't, there's no package manager on the host OS. I have to do those things inside the admin container. It's just a matter of security. It's a great way to keep this as streamlined and small as possible.
There's also no compiler, and I think no libraries. Is that right? Everything's statically compiled?
Yeah.
To help support, again, a stronger security profile. Techie Stories asks, could it be possible to randomize the admin container like a diode? And Justin's answer is you can customize it. In other words, point it to a different repo, but a random container isn't a feature request we've had yet. And I know you were talking about the possibility of customizing your admin container also.
Yeah, let me show that process real fast. Actually, I don't know if I have it. I did want to show it just because it has a really cool thing in it that we talked about last time with Docker. Where am I? I'm back on. Whoops. I'm back on my host. I'm going to get the admin container is open source. Oh, I'm not showing my full screen. But on GitHub, BottleRocket OS, there's a BottleRocket admin container. There's also a control container, and so you can actually go and customize these containers. So if I here and I just find my Docker file, this is a good example. I love this example of multi froms in a Docker file. Not multi layers. What's it called? I'm blanking on the name.
Multi-stage.
Multi-stage. That's it. But also the amazing ability of Docker build kit to show you like the outputs of how that actually looks. So where's my last from in here? There's my last from. My last from is Amazon Linux 2. And so if I go in here, you can see what it actually does in the container that I was in. This is all the steps that were in that container. But what if I actually want to, so I get OpenSSH server, sudo, and util Linux. But I also want to add htop, and I want ps, what do we call it? PS MISC? Or PS utils?
Utils.
Yeah, so I want those two packages for the next time I I run this container. So I can, as you can see, I have Docker build kit is set to 1. So if I Docker builds admin, oh no. Did I mess that up?
We're doing it live,
Yep.
folks.
It's amazing.
Oh, you know what? You know what it was? I need to set that variable. Hold on. There's a make target for it. That's what it was.
Docker Arch? No.
This builds? Yeah. Okay. So Docker builds, and that sends my flag properly. So I can make builds. And I do have the, so you'll see this multi-stage builds is actually going to do 2 things at once. You'll see like 2 screens start scrolling because it can take both layers and if they don't depend on each other, work on them independently, which I think is just a great way to show that. If you're doing yum installs on 2 different layers or 2 different stages, it'll continue until it has a dependency and then it stops. The other one finishes and then it actually like executes the rest.
That's pretty fantastic.
Yeah, I forget how long this. I want to say it took like 2.5 minutes. So we don't actually have to show the entire thing, but you can see like here's my htop ps utils. That's running. And yeah, look, I don't think that time-wise this is probably not the best to show for now, but you can customize it. It goes directly in that user data. You can just say part of the enabled, you can say where it's from, and you give a URL of ECS endpoint, or not ECS, ECR endpoint, or any Docker registry endpoints where you want to pull the admin or control container from, and you can customize them.
That's awesome.
And so if you had a custom repository with credentials that you wanted to log into, are those flags you can pass in as well?
So I had an example. Let me switch over to, built the same thing.
Lots of questions. And again,
oops,
we're
click
doing
share.
this live.
That's what I forgot. I forgot to click share there. Did I get it? Yeah.
Yep.
So I had this container, which it's not going to show me, obviously. Like I built this last week or whatever. The main difference I put was I actually just threw my SSH key from GitHub keys inside the build process. I just said curl this down and put it in authorized keys, and so BottleRocket at startup, the admin container at startup will look for the admin endpoints and pull in your keys from the metadata, because I tell it I want the BottleRocket key. But because you can control that image for SSH, I said, hey, I don't actually need you to do that. Go ahead and just in the build process, just embed my key. And so I didn't need to specify a key at user data. You can customize it however you want. Again, it's just a standard Docker build, a standard image. The admin container just happens to run SSH. If you didn't want it to run SSH, you don't need it to. BottleRocket has a way that, like admin is meant to have some level of access, but there is also the notion of adding custom containers where I can have my control container, I have an admin container, and I can have a completely custom antivirus or audit or whatever I want for compliance at that layer, and it will start it, and you can say, do you want it privileged or no? All these settings are available in user data, so you can do all that.
So Texan Raj asks a question: are there any issues migrating existing apps to BottleRocket? And if so, what does one need to be aware of? I think I can answer, but I'm curious if you want to answer first.
At the end of the day, it's running containers. If your application runs a container, don't rely on, if you're not mounting host volumes into your containers, because you can do a lot of things that rely on things from the host. And if you're trying to do that, those applications aren't going to work so well. But if you need glibc, you're good to go, right? That's if you're going to exec something that needs to run on the processor and it's x86, it's going to work for, into the container.
I think the one exception I could maybe think of would be there are some, I've seen people run, like the example that I've seen was someone running a VPN server inside a container, and it needed to load a kernel module. So to be able to provide that kernel module, you depended on a certain kernel, and I think the libraries had to be in place, like kernel devel or something like that. So there's that sets up a dependency between the host operating system and the container. So I think that's the scenario that you'd want to watch out for. And as long as you're not doing something like that, then yeah, I mean, it should run just like it would run anywhere else, except it's going to have a lot more resources available to it because you aren't doing nearly as much at the operating system level. That's completely stripped down. Cool. So Carrick, I don't know how to say that. Hopefully, I know that's not right. Oh yeah, maybe so. I would love if you could talk more about cache in Docker image building with BuildKit.
Yeah, BuildKit has a lot of different ways that cache works. So if you build the container without BuildKit and then build it with BuildKit, it's different caches. But there's a lot of other advanced things you can do with BuildKits with regard to caching. I believe there's even like shared remote caching. So if you have a team that always builds the same images and it's local on your disk, you don't want everyone pulling down, some multi-gig image, you can actually have remote caching. You can have a lot of other things that work for your team that BuildKit allows you to do that you couldn't do with a standard Docker build.
That's awesome.
Nice.
So did your EKS cluster ever come up?
No, my EKS cluster failed.
Shouldn't have asked.
I know. I just checked it, and I was just like, okay, where are we at? And I tried to hit it, and it was like, nope, it's not there. So I actually had a problem with. I ran out of NAT gateways in my cluster, so I tried to clean them up yesterday, and I think I cleaned up too much of the VPCs, and now my cloud config is in a weird state. But I can still show, at the very least, what's in. Let's go back over here. What I wanted to show. Here's my admin container. Where's the BottleRocket OS? So there's the update operator. So the way you update BottleRockets is it's a partition-based update system. So you're not doing yum updates. You're running a command called updog. And there's actually a whole glossary. BottleRockets OS glossary has a lot of different words on here, like a host container is started by this host container service in systemd, and that's how I got the admin container and those sorts of things. But there's also a lot of dog themes, such as NetDog and Pluto, and things of that nature that allow you to do more on the OS with minimal exposure to tools, and they're very focused tools. So updog is the client that actually will do upgrades on your OS. When you're on the OS, you can run updog, and it'll tell you what updates are there, and you can tell it to reboot and apply those updates, and it'll reboot the instance to install it on a different partition and come up in the new OS version.
I think my favorite in this list is the RV settings. Like,
yeah.
It's just the naming is amazing.
I know, right? Justin AWS mentions BottleRocket does have a way of building kernel modules, and some of our partners do that today to enable some of their deep monitoring tools. So, and then of course, L Duder says no love for cats. I don't know. Maybe in the next operating system that we release. Who knows?
I don't think it's exclusionary. I just think that in this case, BottleRocket chose the dog theme, and you have to stick with your theme. I mean, once you name it one way, although I don't know how BottleRocket fits in with dogs either, but it's okay. Like they went all in on dogs for everything else, and then past that, like, yeah, we could open up for cats on a different OS for sure.
Yeah, I mean, look, Amazon. There's a lot of dogs at Amazon. Let's
be real. 404 pages. Yep.
Yeah, and I'll tell you, going through it, any of our offices, there's dogs. And maybe this team just had more dogs than most other teams. That's possible. They just fancy the dogs.
So the last piece I was hoping to show off in the EKS cluster, but we'll just have to do it another time, was the actual how you do updates if you have a node group of all different BottleRocket instances. Because you have updog that switches A to B partitions, it's a lot easier to say like, hey, what version are you on? You're on this version. You're on version 2, and someone else is on version 1.9. And it's not a difference of like files on disk. It's actually like which partition did you boot to? And I can check that with the hashes and everything else, because a traditional Amazon Linux 2, I can say, hey, what version are you? But that means nothing, because what I yum installed and what I configured and everything else I layered on top changes what that OS version means. And so inside of BottleRocket, it is one version to another, and you can guarantee that the base OS, base file system, is a specific thing.
Yeah, and just more context around the dogs.
Yeah, 6,000. Goodness.
Wow. So if we control an OS with partition flipping, we can also expose that into Kubernetes as a way to operate on that and say, hey, I want to change this entire node group to the next version of BottleRocket. And Kubernetes can run a pod that has privileges to be able to run updog and do these things. And so this is the operator code that actually does that, but there's also a great walkthrough down here of getting started where it actually deploying the operator and then setting some tags or some labels on the instances to say which operator it should use and that sort of stuff. And then there's even really nice, like there's a make target that says like make git node status, which will show you all of your BottleRocket instances in the cluster. And as they upgrade, it uses the Kubernetes API or etcd behind the covers as a state lock. So the operator will say, hey, if everything had an update and we just said, okay, everyone update now, like what's going to happen, right? Like everything's just going to go away. Like, well, my cluster's down because I'm doing updates right now, right? So like that's not going to work. And so BottleRocket does, it's very similar to CoreOS. CoreOS, etcd was created specifically for this. etcd was created because they wanted consensus in the cluster and said, hey, I only want one instance to go down at a time, do an upgrade. When it's back up and healthy, the next one should go down. And never before that. If it comes up and it's not healthy, stop. Don't do updates. It's not safe. Let's figure that out. And CoreOS also had a lot of really cool features for like, you could set windows for like time of like when you want it. The lockd service was like, I want this many or this percentage of my instances should shut down at once. They should do it during this time. Get my updates from this server. All of that stuff was configurable. And updog is doing a lot of same ways in a Kubernetes native way. And so we can say, hey, let's use that Kubernetes API, etcd behind it. And so we can actually walk through each instance. It'll get a set of labels on it and say, hey, I need an update. Is it safe for me to reboot or not? And the operator will say, yes, go ahead and update, or no, someone else is doing it, or you just need to wait, or your update's failed, or whatever. So there's a lot of really cool things that you can do once you expose that API, and once you work in a more, it's not ephemeral, much more deterministic states. And we say, hey, I know the state of the world right now, and we can now act on that because it's not imperative, and it's not me like saying this step, this step, this step. Oh, I failed on step 2. I need to go back up 1. It's just, hey, no. What's your version? Okay, the cluster is at this version, and I know when I need to do updates or not.
So cool. This is so advanced. But at the same time, it simplifies so many things. You just stop managing the host operating system and instead replace it with the next version.
Well, and you look back, like, again, I mean, I didn't even get to use all my props, but like you go back to this state of where's I got systemd, I got my Docker here, and then there's like, what did you used to do with config management? Like next thing you do is you're like, well, let me throw a bunch of config files on here, and now let me like try to figure out like what state is the world, and you're like, looking at Chef or Puppet and saying, I don't know what's actually happening. If the run was successful, I assume this is my end state. And so I can tie that back to a config management point. But like once you start layering in all your pods and you're saying, oh, like I have this weird error on that one instance and I don't know why. A lot of times, you just throw it away and another one will get replaced if it's in an auto-scaling group. But this is like the state of the world of where we were at. And even like, it's interesting with BottleRocket inside of the Kubernetes instance, Docker's not there. If you notice, like those were all containerd. I wasn't running a Docker daemon. I didn't have Docker running because that can cause other problems. So like in the case of let's make BottleRocket work for ECS. ECS is tied to Docker. So that's where I'm going to say, okay, well, like I need ECS for this, but my host container is still over here on containerd. And so I have the Docker daemon that can run with ECS, and ECS can control which services get put there. But again, like ECS doesn't run pods, right? So I'm going to have like a different abstraction for what is like my ECS. And you did this to me during lunch too. Like this is all like, so like for me, like I think of ECS as like, these are donut holes. And like, here's my like ECS services. But like, if you're running BottleRocket with ECS, like it's a different it looks different because I need Docker and I have these services that don't have pods. And so you still have a little bit of systemd down there to kind of orchestrate some of this. But if systemd went away, like you don't actually care. The API is what you care about, and being able to interface with it at that point. And like the only thing you really care about is, you know, these can like make sure you don't eat the Tide Pods, eat the.
Yeah. I was actually just going to say, did you put Tide Pods in there or was that just pretend? Because I was going to say, don't eat anything that the
I did.
Pods
We're in ECS right now. We're not running Kubernetes. It's okay. Like I can eat the pod or the.
But earlier, I'm just concerned. I'm just concerned for your health here. Okay.
So that's kind of the state of like, you can mix those things, and BottleRocket is coming out with flavors, right? We can have different versions. They're working on an ECS version, so you can run BottleRocket in ECS. You can have a lot of the same control planes of how ECS is going to upgrade your instances and how Kubernetes. And so like that interface of you to the OS isn't about files on disk. It's about the API. It's about how you control it. And it gives a lot more clarity and control at a higher level. So I'm not over there running systemd commands or, you know, these like low level, like IO-ectal, like I'm like doing that layer. You might need to configure things. We have, as Justin pointed out, like there are ways to get kernel modules and things like that to make this possible to configure it. But in runtime, at day 2 operations for the platform, you don't want to be that low level. You want to care about the donut holes on top. And then everything else is like, that's where your money maker is, right? Like I don't make money on mixed nuts. I make money on donut holes. And so that's, these are really good now too. Like I didn't eat enough. And so I'm just going to keep going. So if there are questions.
That's right. You're going to have to eat past the Tide Pods to get to the mixed nuts. All right.
That was pretty fantastic.
Last call. Oh, what? No one said tech peeps are boring, surely.
No, we're just hungry.
Exactly. All right, last call for questions. And let's just wrap up real quick what we've looked at while we're waiting on any last questions to come in. We took a look at BottleRocket OS. It is a new operating system built to run containers. It's starting off as something that you run in AWS, but ultimately the goal is to have it possibly run anywhere. It's completely open source, so if you want to work on this, you can find it on GitHub, and you can open pull requests, open issues. You can talk directly with the engineering team over GitHub issues about what you'd like to see in the future, or what, you know, behaviors you're seeing now that you think maybe aren't quite right or something like that. So definitely check it out. Start using it, start working on it, and start communicating back with us about what you find, because we would love to see your feedback and hear your feedback on it. So thank you, Justin, for giving us a tour of BottleRocket. That was pretty incredible. And as usual, your props are amazing.
Nice.
I just wonder about tomorrow's session, what props you have in store.
I don't know. Like that's ACK is going to be a difficult one. I mean, ACK, or I don't know. Like,
right.
We'll figure it out.
So for tomorrow, we're going to take a look at ACK, unofficially called ACK. And we're gonna, I don't know what we're gonna do. We're gonna do things. So tune in tomorrow and let's figure out what to call it for real.
AWS controller for Kubernetes, by the way, right? Oh, so just for those who don't know what ACK or ACK is, you know, we love acronyms, but there's nothing worse than when you talk acronyms and people don't understand what they are. So
good point. Good point.
Just thought I'd share.
All right, Justin, toss me a donut.
This whale has a bunch of glaze on it now.
You're gonna have to use one of those Tide Pods on it.
No, don't do that.
Don't mix ECS and Kubernetes. What's going on here?
All right. Thanks, everyone. See you tomorrow.